then go to design and quick layout. And that's my quick layout. It's my favorite one. You know, it's in the chart body, I think all this stuff. Yeah, also, I'll show this again real quick. All these options, you got so many cool things. It's so nice.
Gary! I was just looking for the sports channel.
Hey everybody, how are we doing? I moved the camera. I knew I did it. I knew I moved the camera while I was getting ready this morning. I always move the camera. So it is 20 Point Tuesdays. Don't worry, we'll show that here in a moment. But we've already given out some 20 points. And how is everyone doing this morning? My whole setup is going crazy. It's like, no, you cannot adjust this thing right up. There we go. How is everyone? Good morning. Good morning. Got a little more room right there. There we go. Good morning, Emily. Good morning, Brennan right there. Good morning, Megan. A little sleepy. Yeah, I know what it's like. I know what it's like. I got some Red Bull finally. I have Red Bull. I am good to go. I've got some energy right here. We got some punch-out music. Because you know what? Hey, Connor, good to see you right there. We're waking everyone up because the first thing we're going to start today with is, guess what? We're going to start today with a speed run. Let's do it. Here we go. Time for a speed run. Yes. Let's do this. I might... See, what would be bad if I drink a second Red Bull? If I drink a second Red Bull, I shouldn't do that. I'm only allowed one Red Bull a day. That's when you're an adult, when you like limit yourself, when you're like, okay, I can only have one Red Bull a day. I'm not allowed to drink 3 Red Bulls. Even though I want to, even though sometimes I have. Okay. Oh man. So one of these things right here, we're going to start off with a speed run right here today. Got the screen all set up. I gotta like lock that camera down more because every time I turn it on, I like just turn it a slight bit, and like I'm gonna have to like move my whole room around. Like I'm just gonna make circles around the room as every day I turn it on, just move the camera over just an inch. So that's why you always see me like making a fine adjustment right here. Okay. So with this in mind, let's remember the topic we were talking about yesterday at the very end of class is we were talking about permutations, and we were talking about p-values, and we were talking about randomness. So we were talking about all of these different things, which are huge topics. And it's funny because my brother's taking, he's taking statistics right now in an MBA course. Oh, I've got so many great things to talk about. So my brother is doing t-tests and p-values. And he was saying to me, it makes a lot more sense now that he's doing it a second time. And because he has his undergraduate, he's a pharmacist, and now he's doing his MBA, his professional MBA. And so he's like, yeah, it's making a lot more sense to me now that I have experience out there. I've seen these things. I've seen people use these tests. And so he's like, yeah, it's just like you do this, this, this. And he's like, I can't believe, that the first time I heard it, it didn't make sense. And I was like, well, that's the thing. You have to hear things multiple times. And that's why I'm always like showing my students, it's kind of like saying, this is how I teach. And he was like, oh, that makes sense. Like, because if you tell it to them like halfway through the course and then, 2/3 of the way through the course and at the end of the course, and you just keep reinforcing it. And I was like, that's what you have to do. And that's what you're doing now that you're coming back to this stuff, that you're hearing it again and you've been using it multiple years. Now it makes sense. The thing is your brain needs a place for this. So today, as we go through this topic right here, I'm hoping it makes sense. But you're going to hear this multiple times throughout the course. You're going to hear this again when we do correlation. You're going to hear this again when we do testing means and stuff like that, as we do like basically your Stats 1 knowledge again. So I'm hoping, and please slow me down. Please ask questions. Hey, what's up, Henry? And so please be like, okay, this doesn't make sense. Now a speed run, I'm going to do kind of quick here, but put questions in the chat. I do sometimes answer them, but I'm going to try to tell you all about permutations and p-values here in a speed run right here. It's going to take me about, I think I can do it in 5 minutes. I think 4:55 is the world record. So we got to do this here. You ready? So this is your chance to hear about permutations. You're going to hear it again right here. You're going to try to like pay like close attention. This is like the super focused time. And so get ready. Is everyone ready for a speed run? I need some energy in the chat. I need you guys to give me the energy to do the speed run. Because if I don't have the energy, it's going to be a slow run. I won't get the world record. So who's got some energy in the chat? Let me get my pens ready right here. I can get pens ready. That's within the bounds of speed run. We got space pen ready. Corbin's ready to go. Corbin 20 points right there. Stevenson 20 points. James Wright 20 points. Ben 20 points. Let's do this. Permutations. Brennan, cracking me up, man. Let's do it. I like it. Let's do it, Brad. Everyone 20 points right there. Let's do this. Let's get it going. 20 points for all those people who are ready to go with this speed run. Something weird yesterday happened, Jonathan. Monstercat, which has the crab rave, hit me with a copyright claim on the channel, and I got to look into it more. So we got hit with on the randomness, and they're like, this section of your video, this 10 seconds, and it's not a copyright takedown, which would really hurt the channel because then you can't stream and stuff. It was a copyright claim. I know, and I thought they didn't hit people, and that's why I've always used it. I know. They're not going to hit us with 10, like, oh, and well, the good news is I don't even have it on this screen because this is a separate screen. I know I need to look into it, and I'm too afraid to be like, hey, we've been using this for every video. But I got a thing from YouTube, and usually I'm excited when it's like, YouTube, you're a content creator. I know, man, we got to put that F in the chat for Crab Rave. But yeah, I was like, what in the world? And that's the first time it ever happened to me was with Comedy Central. And that one was very justified. I showed like a full Stephen Colbert, like I showed like 10 minutes of it. And I just didn't realize it because I was like showing the segment we show or I show in class, and I just streamed it on YouTube. And I was like, oh, maybe I shouldn't do that. And then the second time was with Julio. I showed some of his clips, and like I got hit with like 3 then because like, and there were little segments and I had cut them up, but those all got hit with like copyrights. And then this is the third time right here with Monster Cat. And I was just like, what? So actually, I did a thing where I muted the stream, but then I looked at their stuff, and it's like, you can use our stuff as long as you don't like monetize it and you don't do these things. And I don't monetize these videos. So we might be all right. And then like later on in the video, it might be muted. I just want to make sure, like, I'm going to look into it more. And I was like, come on. Monster Cat. Like, and I want to contact them and be like, hey, I do education. We just use your song for like a fun thing. We're not making... Like, there's other things on the channel that are monetized, but yeah, and we got hit with Julio's thing, I think, even before we were monetized. So they'll hit non-monetized channels. So I don't think it's because I've monetized the channel, but obviously these videos are not monetized. Fair use, yeah, that's the thing is like, and we only do like a 10-second thing of it, and we've like altered it, and they have things they don't want you to do with it. Like they're like no night mode only, like or night versions. I read the whole like copyright on it, so because I wanted to be like, uh-oh, what have we done wrong? And it's weird to me that they hit us because I've used that song like it's in one of our openings. So, and we just used it was literally 10 seconds. It's like a 10-second sting of the song. But I've heard other people getting hit by stuff. Like one guy who does like a news thing, he got hit with something, and his thing was very short, and all of his videos got hit. So I'm like, let's take him to court. Monster Cat is bigger than I think we are. They're big. Yeah. Okay, you guys ready? Time for the speed run. Crab Rave will return. Rave will return. Marvel's going to come after us for our Thanos snap. Who knows? Let's do this. Let's talk about some permutations. Here we go. Okay, so permutations are basically when we have a data set, such as like, let's write this down right here. We could have person. Let's go person. So we need to go person. It's on screen. Good. A person, and then we have their, let's go to weight, and let's go to height. Now, what is a permutation? A permutation is if we had a list of people right here. So here's our list of people. And we would generally say there's an association with weight and height. That generally, if we have people here, people A, B, C, and then we have weight of like 120, and we have weight of like 180, and we have weight of 240. Maybe this person is 5 foot, and that's 5, and then I think you do the thing here. There we go. 5'2", and this person's 6'1", and then this person's 6'2". It's not like you have to. There's a lot of variation in what we have right here. But what is a permutation? So you see there's an association between how much you weigh and how tall you are. So generally the more you weigh, the taller you are, but that doesn't mean, once again, an association, what does it mean? An association means it gives you information. Knowing someone's weight tells you something about their height, but it doesn't mean you will know their height. It just means generally people who weigh more are generally taller. If your friend weighs 100 pounds, like I had a friend, John, who weighed like 90 pounds in high school, you probably wouldn't think that John is 6 feet tall. John was like 5'2". So if your friend weighs 100 pounds, you would generally think they're not a taller person. It doesn't mean you know that they're not a taller person. It just means it gives you information. If your friend weighs 200 pounds, I'm close to 200 pounds now, you'd be like, well, Brian might be taller 5 feet, shorter 6 feet. Who knows? Like in that range, you'd be like, Brian weighs 200. He's like 5'10" to 6'3" ish. So you'd have a guess, or you could be 6'6". Who knows? but you'd have a guess. You wouldn't be like, I mean, I could be 5 feet tall. You never know. But it gives you information. So what is a permutation? If you were to make a permutation right here of people's heights, this is a permutation of height. Let's add on here a permutation of height. All we're going to do is we're going to mix up people's heights. This is a permutation of height. So this person right here is 6'1". This person right here is 5'2". Now this person right here didn't get randomized. It's all right, but we just mix it up. We just create a permutation and we mix it up. And if there's more to mix up, they'll get even more mixed up. So this right here is a permutation of height. And now, because we've mixed it up, anything we see with the relation, man, I want to hit that button, I want to hit it. Anything we see with the relationship between height and weight should be what? Any relationship we see, you know the answer if I want to hit the button, which I can't hit anymore. So the relationship between, you got it, Mila, right there, 20 points. Anything we see between height and weight should be random. So we create this random relationship right here. And if you remember how yesterday worked, yesterday we were talking about like, did you study for the test? I'm not going to get world record, but that's all right. Yesterday we were talking about, did you study for the test? So let's go right here and things like this. And then we have here study, and we have here pass. And maybe we see something like people who study for the test are more likely to pass. So we could go right here, this person studied, this person studied, this person did not, this person did not, this person passed, this person passed, this person did, and there'd be more. But if you notice right here, it's basically like 100% of the people who studied passed the test, 50% of the people who didn't study passed the test. And this is a very small data set. It's probably not statistically significant, but at least at this point, we're starting to see maybe something going on right here. Like it's like with preliminary analysis, it's like, okay, if you have 100% of the people passing the test who studied and 50% of the people passing the test who did not study, I mean, it's a very small data set. This is not statistically significant. I can pretty much say that because I've done a lot of these with a sample size of 4, unlikely. And so what you do here is you get a permutation of pass. And so what does this do? It literally just randomizes what goes where. It's just going to randomize this. Does that make sense? The permutation of the variables, and you only need to permutate one of them. You can permutate both of them, but it's like mixing up two things. You're still just mixing them up. So if we permutate pass, tell me what should be. Who can come up with an answer for what the first person gets if I permutate pass? The first person should get what if I permutate pass? Let's do that. Yeah, I like that. And because of that, what do the other people get now? So Ryan, 20 points right there. I like that a lot. That we get right there, no. I think the second place is like 9 minutes on this. There's a big gap. Some person used a glitch run. There's a glitch run where you skip part of this. And so I think it was like, I heard that, what's his, Clint Stevens? I think he's got a glitched run in this. I haven't separated this out into categories yet. So you got right here the permutation of pass. And what is this right here? What is this column? It's a randomization of this column right here. It's randomized. We just completely randomized what goes where. And there was only one no. So once we assigned that no via randomness. Now, like, okay, did we do it randomly really? Okay, we're pretending here because we'd let the computer do it. And now we look at what happens here. And what's funny is now everybody who didn't study passed the test. So now everyone who didn't study in this, like if you look at the permutated results, everyone who didn't study passed the test, and only 50% of the people who did study passed the test. So this is a randomized permutation. So it's going to be like what could happen by random chance. So now we get to the big concept. What we want to look at right here, yes, Nicole, I love it, 20 points right there. We look at what happened via our results. So here's the big graphic we need to know. In this graphic, we will see the following. And we have to know this graphic, like literally what is it showing us? We have to be like, what does this graphic show us? This graphic is going to show us first the permutations results down here usually. And whatever we see in the black bins are the permutated results. And usually they look something like this. They'll look something like this. These are permutations. And what are they of the permutations? They're the discrepancy we're seeing. So for this first test we're doing, the smallest discrepancy we can get is 0. And generally you see small discrepancies. Like generally speaking, we see smaller discrepancies when we do random results. The smallest possible discrepancy is 0, but you'd say, well, why aren't they all 0? Well, you're going to get differences by random chance. Does that make sense? Like by random chance, you will get differences. Like if you just randomly assign things, there'll be differences just by random chance. Because if there was no differences, we would see 50% of the people passing and failing, like it would be exactly even, or 60-60, it would be perfectly even. But just the way the data is, you have to get some sort of difference because we had 75-25. So we're always going to get some sort of small difference when we randomize the data. So definitely that one is not going to be statistically significant. And just because it's such a small data set and our results could occur because it's very possible by random chance to get what we got. So these are the permutations. These are the discrepancies we are viewing. The larger the discrepancy, the more different the distributions are. And this is what we're talking about yesterday. So listen on this. If we were to have a discrepancy down here, it equates to a graphic that looks like this. This is the key. A discrepancy down here is when the bars are like perfectly even because there's no differences. A discrepancy all the way over here, that's still on the screen, right? Perfect. Is going to look more like this. Does that make sense what the discrepancy is? I'm just doing a 2x2 plot. But the discrepancy as the gets higher, and think about which of these is more likely by random chance. Is a discrepancy like this, if nothing's going on, more likely by random chance? Or is a discrepancy like this more likely by random chance? The one where they're even or far apart? Which one's more likely by random chance? The even or the far apart? Which of those is more likely? Discrepancy is closer to the even or the far apart? Which of it? Uh-oh, I've lost my speed. We got this. Third place is like 14 minutes. We got this. The even's more likely. Alex and Casey and Corbin and Megan, 20 points right there. The even is more likely by random chance. Look at this right here. Do you see these? How this, want to keep that. The even is more likely by random chance. Do you see right here how we have kind of this area right here? It's closer to the random chance, and that's where the buildup of the distribution is. This distribution has a peak right here, which is closer to this, because we don't get things that are perfectly even, because that would have a discrepancy of exactly 0. Like this one is exactly 0. If it's perfectly even, it has absolutely no discrepancy because they're perfectly even. There's no discrepancy between the conditional distributions. And those within there are the conditional distributions. We talked about that yesterday. So there'd be no discrepancy at all. But we don't see perfect no discrepancy. We see things close to it. Does that make sense for everybody? We see things close to this. Like what would this look like right here? This peak is probably where we start to see discrepancies, not like that. Discrepancies probably somewhere in this range. Like that are close to very small. They're very small. They're likely by random chance. They're not perfectly even, but they're like closer to perfectly even than further far out, like far away apart of each other. And this is what we're likely to see by random chance is small discrepancies. So the smaller discrepancies in this area right here are what we're seeing by random chance. The larger discrepancies are unlikely by random chance. So this is what we have going on right here. Hopefully those discrepancies up top help make sense of kind of this is what is being gauged and this is what is being evaluated, because it's going to literally calculate every single discrepancy for us when we do this. It'll do all the permutations and then do all the math for us and calculate all of these. This is a super advanced way that wasn't available years ago. Like 10 years ago, people were not doing this. This is very advanced. It's literally doing p-values by random chance. So what do we get? Well, guess what? If we land right here, like let's say we observed this result. Like that was our result. The p-value is the probability of our result. And let's say this is our result, just hypothetical. Like our result looks something like that. Or results more extreme, happening by random chance given the null is true. And the null is that there's no difference. So if that's our result right there, can anyone take a guess at what the p-value is? I got to get under 15 for this. Like, you guys got to help me out. What would our p-value be for this? Take a guess at the value of the p-value. And what you want to look at is the red shaded area. Who knows for 20 points? What would the p-value be? What would the p-value be right there? Any guesses? P-values are probabilities. They're contained between 0 and 1. So they have to be probabilities. They can't be negative. They can't be over 1. They have to be somewhere between 0.00000 or 1.0. Not greater than, yes, Brad, 20 points right there. Brad, you're right. It's greater than 0.05. Brennan, 0.5. Good guess. Yes, Brennan and Brad. It's definitely greater than 0.05. And look, that means it's not statistically significant. That's like probably the biggest thing to notice first off. Excellent answer, both of you right there. And also Grant, because this looks to be about 50% of the curve. So if you were to get this right here, this would be a p-value maybe equal to, this is just a guesstimate of 50%, which is not statistically significant. It's just a guess. What we're saying here is 50% of the curve is shaded because our result or results more extreme would happen by random chance about 50% of the time. But here's a really easy one, 20 points. Someone should get this right away, because what if our result was all the way over here? What if this was our result? Now the red line is our result. This is instantaneous. You should know this p-value very quickly. So what would be the p-value here if this was our result? Boom, Brennan right there, and Austin, both of you are right. Yes, because now there's nothing. It's 0. 20 points, all those people saying 0. Yeah, because there's no result as extreme or more extreme than our result. So does everyone, wow, great job, everybody. Because when you look to the right of that, there's no results as extreme or more extreme. Don't worry, Jonathan, 20 points. Yeah, you're following along. Once you see it's like, okay, there's no results as extreme or more extreme than our results. And think about this. You've just said that this result here is likely by random chance, and this result over here is unlikely by random chance. Which of these, in result A or B, we got this sub 15, do you think that there's a relationship or association between X and Y? In result A or B, do you think there's an association between X and Y? Which of these do you think? In results A or B, there's an association between X and Y? Which of those would you have evidence of an association? A or B? In result, we're getting a lot of B's. Good. It is result B, because B is where there's a bigger difference in the conditional distributions. When you look at this versus looking at this, there's a bigger difference. And that's got it. That was a pretty good speed run right there. Who feels like, oh, we lost time on the screen. Do you feel like you understand this a little bit better right now? Who's like, who feels like maybe the permutations thing is like, okay, it's starting to make a little more sense, starting to get it. This is the second time now. With B, the conditional distribution, here's conditional right here, because remember, conditional is the bars within. So I'm going off screen. The bars within is the conditional. And so there's a difference between the conditionals that is greater than A. So you see the conditional distributions for A, like, look at this, like here's X and here's Y. And so there's X and Y. And if you look at, if you know a certain level of X on this one, it gives you no information about Y. It gives you no information. If you know X here, it gives you a little bit of information. And if you know X here, it gives you a good bit of information. So the more information it gives you, the less likely the relationship we're seeing is by random chance. So hopefully, and I really thought, I was like, it'll really help to see these graphics up top right here that is seeing, and that's just kind of, it's not saying these have to look this way, but you will see greater differences as the discrepancies get larger. Brad, thank you. 20 points, Brad, again. But I want you guys to make sense of this. I want to do more drawings because sometimes we do the notes and the notes can just be boring. So I like doing drawings because you have to like practice it. What's the formula for permutations? So what the permutations are? Great question, Ben, right there. Let's hop back to the notes right here. Where's my notes button? Where you got notes button? Okay. So the permutations are done just instantaneously for us. So what it is we just mix up the data. You can mix up one of them or you can mix up both of them, but the permutations are just a mixing up of the data. It's like literally just taking like a box and just shaking it up. It's like, let's just mix it up. And so there's no real formula for it. I mean, you could write code to do it for you, but we already have the code that does it for us. So permutations are literally just mixing up the two variables. You've got the original shape, you've got the original data, and then when you permutate it, you can mix both of them up or one of them up, because it's like if I reassign everyone's grades, then it doesn't matter how long you studied, your grade would be random. But if I reassign how long you studied in your grade, well, then it's just mixed up again. So it's like mixing up X and Y is the same thing as just mixing up Y, because it reassigns everyone's X and Y relationship is now broken and it's random. Your relationship between your X and Y is random. So, and then whatever we see in these permutations, like whenever you look at permutations, So all of these permutations, any relationship between x and y is completely random, and we would expect most of those relationships to be very small. So this is an example right here where our result was very likely by random chance. And look at the discrepancy. The discrepancies are close to 0 for the permutations, and then our result was very close to 0 also. Does that make sense? Like the result we observed in our result was very close to 0 and likely by random chance. So anything we observed back here in this example, which we're way ahead in the notes because we were talking about that example of permutations. We'll get to do the hot or not survey. Okay, we did statistical versus practical. And I think we are right. Here's where we ended. So here's where we ended yesterday. Let me try the zoom method. I've got a zoom button, main screen zoom. That looks a little better. So this right here is an example of permutations that are unlikely by random chance. And then if we go back here, we can see permutations that are likely by random chance. So the differences you observe in this graphic are likely by random chance. The differences you observe in this graphic are unlikely by random chance. And we would need to see the p-value. Is x more often randomized or y vice versa? Doesn't matter. Good question, Brad. 20 points right there. As long as one of them is randomized, that's a permutation. You can randomize both. You can randomize x. You can randomize y. It destroys. Does it make sense that it'll break the x-y relationship such that if you randomize x, then y's relationship with x is now random. If you randomize y, then y's relationship with x is now random. What's the point of a permutation? Great question, Alex. It's to see what could happen by random chance, to see if we get results like this by random chance. So when we do a permutation right here, look at another permutation. All we are doing, we should have a permutation procedure for this one. Here we go. Is we're creating random results. So when we say, like how likely is our result by random chance, then we have here randomly created results. And then we can look at, would our results occur by random chance? So the whole point of permutation procedure is to get a what? 100 points. One person's going to get 100 points. First person who tells me. The whole point of the permutation procedure is to find a what based on it. Let's find the probability of our results or results from our stream happening by random chance variation given that there's no relationship. Boom. Alex, you're right. Did you ask that just to get the points? You get the 100 points. You got it. Andrew, 20 points right there. Good to see you, Andrew. Yep, p-value. Andrew says it. Like he's like p-value. That's the whole point of the permutation procedure right there, is to figure out how likely were our results. And so when we do this right here, we can see in this example that these are all the permutations. Remember our notes we just took earlier? These are all from the permutations, and they have small discrepancies often because they were all created by random chance, and it's unlikely to get big differences by random chance. You can get big differences by random chance, but it's less likely. And then what do we see right here? Here's our result. So this is the result we obtained when we looked at our differences. So our differences were much larger than the ones by random chance and thus less likely. And we don't even see any results out here. So the p-value is 0. The p-value is 0 because we don't have any results that occurred that were as extreme or more extreme than our results by random chance. So this is the whole goal of the permutation procedure, is to get a p-value, to say how likely was our result or results more extreme occurring by random chance. And what do? To assess random chance, we create results by random chance. So these are, people are like, well, how do you know what the p-value is? It's like, well, we literally create results by random chance. And we created 1,000 randomized results. That's where we can change the number of permutations. And the more permutations you do, the better estimate of the p-value you get. So the p-value is now estimated. And what's the difference between a permutation and a combination? Good question. Good question, Ben. I think permutate just means like to mix up the order, like how many permutations of ABC are there? There'd be like BAC, ACB, B, like permutating letters. I think combination goes into number of permutations possible. So to permutate just means to mix up the order. We'd have to like double check everything I say. And because it was a really good question, I'm just like, what is the difference? So permutations lead to combinations, I'd say. Does that make sense? To permeate something would lead to different combinations. So it sounds like a very similar word. So dumbing it down for me, Generating permutations is the best way to verify every data is valid and not just random. So it's to no, Alex, great question again. The point of the permutations is to see if our results, like when we look at this graphic right here, so far back, when we look at this graphic right here and we ask, is the relationship between somebody's provider and their drop calls by random chance, what do? We simply mix up people's provider and their dropped calls. So now it's completely random. And then we say, okay, is what we saw here likely by random chance? And we would get a permutated results that would look like this. These are the differences we observe. And remember our graphic, I think we can view that here on the screen. So, oops, okay, we need to go speedrun screen. Speedrun screen. So when we do this right here, these are the permutations we did, and these are the discrepancies we observed in the permutations. So when we see small differences in the permutations, we'd get differences like this, but our result was much bigger than that. So when we look at this way right here, we see that our result had a discrepancy that was much, much larger than the ones by random chance. So this tells us that our discrepancy here was very unlikely by random chance, such as we think that the relationship between X and Y we are seeing is not by random chance, that there's actually a real association. That's the whole goal of this, is to say that X and Y have a relationship that is not likely by random chance. They are truly associated, that knowing X gives us information about Y. That's the whole goal of this, is to say, well, let's just make the relationship between them random. That's what the permutations do down here, is they just make random relationships. And then we see, does our relationship look random or unlikely by random chance? Does that make sense? Like, if our relationship landed down here, it'd be like, well, I guess our relationship could just be one of these random relationships because it's likely by random chance because it landed in the middle of a big area of these are things that just happened randomly. But if it lands all the way over here, we're like, oh, it's far away from what would happen randomly. It's unlikely by random chance that we would see something this far apart. So that's going to tell us whether or not what we saw was likely by random chance with the relationship or association between X and Y. Does that make more sense, Alex? The whole goal is to look at if X and Y are associated. And if you land down here, you're going to get a high p-value. And you're going to say, looks like it's just by random chance. And we landed right in the middle of these random permutations. And these are random. So our result landing in there, if your result lands down here where space pen is, you'd be like, wow, it looks like our result is random. But if it lands all the way over here where space pen is now, you'd say, oh, it looks like our result is not random. As they do in, yeah, exactly. You have to just keep asking. Alex, you got that 100 points today. Great job. Because I want you guys to keep asking. Guys and gals, I want you to keep being like, what does this mean? What does this mean? Keep asking. Be like, I think I'm getting it. It's a new way of thinking about it. And you have to be like, okay, that result right there looks unlikely by random chance because it's far away from the random results we've created. Whole point of the p-value. Okay, so the big thing here on this slide, which we should know instantaneously, this is something that if you don't know, no, I should feel like I should just fail you. At the end of the class, if you don't know, statistical significance means a p-value is below 0.05. When we say statistically significant, p-value below 0.05. So on the graph from the book, the numbers on the X range go to 80. What do those mean in regard to the p-value of the randomization? Those are the values of the discrepancy. So the discrepancy is the mathematical computation of the differences we are observing. So the discrepancy right here is based on, just to show, where's all the math for it? It's the sum of all the cell chi-squareds. So the d value right here, the discrepancy, is just a standardized metric by which we can look at the differences we are observing. And when they're close, the discrepancy will be equal to 0. And when they're far away, the discrepancy will be much greater than 0. So the discrepancy right here is the differences you are observing in the graphic. This graphic right here would have discrepancy of like 2, 3, very small discrepancy. And this graphic right here would have a discrepancy of like 70, 80. You don't have to estimate those. I'm just kind of making up numbers. But look at here when I say this has a small discrepancy value because it's very close. And look right here when I say this has a large discrepancy value because it's further apart. And this only applies to categorical data the way I'm talking about it. It will do different tests for different types of data. But small discrepancy, larger discrepancy. So this graphic right here would have a discrepancy that is very unlikely by random chance, because when we do these permutations, most of the differences we observe would be very small, but ours was way apart. That's where the red line is. It's when we do the mathematical computations for how far apart are these bars. The further the bars are apart, the bigger the discrepancy, the further away the red line is from the random chance discrepancies. So literally everything here, everything there happened by random chance. Every one of those is by random chance. Even these slightly bigger ones right here, they're still by random chance. They're not likely to occur, but they did happen by random chance because they're in the permutations. But then this right here is our literal discrepancy, and it's way bigger than anything that happened by random chance. So we'd say, yeah, I don't think ours happened by random chance because it's not very probable. We wouldn't get something like this by random chance. So hopefully that helped. This is a huge topic. Like, that's why we're like, we have to know what this is. Statistically significant, this is where it gets easy again. You have to know that statistically significant means a p-value that is less than 0.05. Not statistically significant, p-value greater than 0.05. These slides will be throughout every lecture pretty much. Pretty much just know it like this. Statistically significant, p-value less than 0.05. Boom, got it. I should put that on the test, like, statistically significant means this. It's just like p-value less than 0.05. That's it. I wish it was a written test, because I would just write that, and then you'd just be like, less than 0.05 p-value, done. So we have that the discrepancy is approximated here by the permutation procedure, or the p-value is approximated, and we get this from looking at how often our discrepancy or discrepancy more extreme occurs. So I think, do we not show a graphic with that? I wish we did. So literally what the program is doing in the background here is it's going in and it's looking at how often a discrepancy as large as your discrepancy occurred. I can't highlight today. There we go. And 23 times out of 50,000 discrepancies, a discrepancy as large as yours occurred. And I like to show, let me show some examples of this. Hop over to the main screen here. Okay, so let's look at some examples and let's see. I think I can do some ones that are likely by random chance. So just to show you again how to use the code, you need to do library red class. And that just loads up the red class library, which has packages and also has the associate function. Associate. I forget, I have mute buttons. So associate allows us to do associations. We're going to clear so I know what I have. We're going to go data survey 10. It's my favorite data set. I use it all the time. It's graphical error. And we're going to go here to associate. And we're going to go y tilde x comma data equals. Y tilde x comma data equals. So this format right here you need to memorize. Y tilde x comma data equals. Very, very important. I want to see in the chat for 20 points. Y tilde x comma data equals. This is going to help you find the tilde button on your keyboard. A lot of people are like, whoa, wait, what is this? What is this symbol? I'll see a dash. Let's see some y tilde x for 20 points in the chat. Y tilde x comma data equals. Y tilde x comma data equals. Very important. You have to know this format. Y tilde x comma data equals. Emily, 100 points. First person to say right there. Y tilde x comma data equals. Yes, everyone's getting it. Yes, y tilde x comma data equals. You have to know this. Andrew, how important is this format for the rest of the class? Andrew, get another 20 points, Andrew, on top of all the points you're getting by hanging out here and reviewing. How important is y tilde x comma data equals to like the rest of the code you'll be doing for the rest of the class? Like kinda, a little bit. It's like I could have just taught you this and then continued on because this is like everything uses, yeah, it's the formula format. Like you put your y variable, your x variable. So we're going to predict somebody's handedness and we're going to predict using their gender. So some of your questions ask you like what should be x and what should be y. So this is saying gender explains someone's hand that they use. And then we need to go here to survey 10, and did I mistype a variable name or it's mad about the graphics, I think. Let's see what it does. Now it's doing it. Okay, cool. So when you look at this right here, I want you to take a look. Do these differences between females and males, here's the ambidextrous, here's the left-handed, here's the right-handed, do these differences look small or large? Do these differences look small or large between males or females? Between the hand they use and whether male or female? We had about 50-50 male-female. We have a little bit more females. Very small. So then look at our discrepancy. This is our discrepancy. This is our discrepancy right here. And so with our discrepancy right here, our discrepancy is going to be very small and likely by random chance. Who can take a guess of the p-value? I'm going to give 200 points. That's the max you get today for the person who gets closest to the p-value. Let's see some guesses in the chat. We got 60% from Andrew right here. You get 200 points. That's the max. You get the max right there. So who's going to... I need more guesses. Any other guesses? I have a guess in my head. I got to guess. 75. You got to guess it. What is it going to be? 78%? Okay, we got it. We might have enough guesses. Okay. I'm picking... I want to get really close to it. I'm picking... Ooh, Corbin. Corbin guessed very close to what I... Okay, so we're stopping the guess after 2 more. So we're stopping the guesses at Henry. Oh, Henry, he might have heard me say Corbin was closer. He's like, I was going to guess 0.82. So let's see. Who got it? Ooh, I was a little bit off. Wait, the p-value is about 70%. Who guessed 70 first? Megan, unless I don't think anyone got close. Megan, you were 2 thousandths off. Megan, amazing job. 200 points, Megan, right there. I know, great job. So you were extremely close right there, Megan. And how did Megan do that? Or maybe other people? They looked and they said, how much of this curve would be shaded from here over? That's a big block of it. Like it's a very large. So Megan, amazing guess. But you said maybe 70% is from here over. One thing I think we'd all agree, this is greater than 0.05. Like everyone would have to say this is a larger p-value than 0.05. Like definitely we know that instantaneously. So these differences right here that we see between males and females are what? 200 points first person to say it. I'm going crazy with the points today. It's not even Wacky Wednesdays. I got to come down. I need a good thing you would tell someone. You'd say these differences up here that I'm observing are what? Random's kind of good. They're not random. Random's 20 points. You get 20 points for that. Not random. They aren't random. They did not occur randomly. It's kind of it. You guys are, I don't know. I wanted an exact phrase. I guess everyone's kind of right. I like what I might give the points to Henry right here. I think I'm going to give the points to Henry. Everyone gets 20 points. I'm going to give the 200 points to Henry. I like what Henry said the best so far. He says that we have no association between headness and gender. Like we have no evidence of an association, I would say. Like, not that there is no association, we have no evidence of an association. Does that make sense? Like, for there to be evidence of an association, we need a small p-value. So to just shore up the wording a little bit more, I would say there is no good evidence of an association between it. And the phrase I was looking for, these differences are likely by random chance. The high p-value means that they are likely by random chance. Does that make sense? Great answers, everybody. Great answers, everybody. I was like, I'm looking for like this exact phrase, that they're likely by random chance. Not that they are by random chance. We can't say we know they are. It's just that they're likely by random chance. That's what a high p-value means. Think p-value being high means high probability that your results are by random chance. Not that they are by random chance, but they're likely by random chance. Does everyone notice the small difference right there? We're not saying they are random. We're saying they're likely by random chance because the p-value is so high. There's a 70% probability that our results are by random chance, that the differences we observe here are just random differences that we would get. And think, does that make sense when you look at this down here, that this is smack dab in the middle, or like in a group of things that happen randomly? Does that make sense? Jonathan, 100 points right there. Thank you for like listening and be like, key difference that we're not saying they are random, we're saying they're likely by random chance. So it's not like, oh, those results are random. It's no, they're likely by random chance. Like we're saying it's very probable that they could occur randomly, because they landed in the middle of this. They're hanging out with these things. They're right in the middle. They're like, hey, these are all my buddies right here. And these are all random chance. Like this buddy right over here had a discrepancy of 14. It's ridiculously high, but it still occurred by random chance. And this one down here is a much smaller discrepancy. Now here's the interesting thing. Watch this. You remember that 14 discrepancy? Watch this. I'll do it again. Cool. That 14 discrepancy is no longer on here. It only goes to like 10 now. You can't see it's behind me, but wait, watch this. Where's the black magic thing on here? There we go. So now the discrepancy right here, I don't think I have the button on this. Oh, do I have the button on the screen? I just click my button. The discrepancy right here is our largest discrepancy. And then now you notice a slightly different shape to it. Watch again. I'm just going to be gone for a moment here. When I run this, you can see every time I run it, that the discrepancies over on the right change, or the permutations. Do you see the permutations where Brian used to be changing every time? How are those permutations created? I'm doing it. I'm doing it for a millisecond here. They can't, oh God. They can't get me if I do it for 2 seconds. We'll find out. We'll find out later today. It said it on the screen. We got our random. We got our crab rave. How are these permutations where when you look at gender, yes, Emily, 20 points right there. All of these are created randomly. Now look at where the red line is at. I want you to focus in on that red line. So watch the red line right here. So while you'll see the graphic change, that red line, watch the red line. Although it might look like the red line is moving, it's just because like the scale is changing. The red line is never moving. The red line, it looks like it's moving, but I promise it's just because the number line is shifting. If you notice, if the number line stays very similar, which it has in the last few graphics, that the red line really didn't move any. The shape of the distribution changes because it's different permutations. So if you notice that red line at like 0.7, yes, exactly. These are because how every time you run the code, what happens here? These are created whatly. Every time you run the code, these permutations are created due to what? Just you know I'm gonna do it. take that crap and go away. Randomly, yeah. They're not gonna they can't see that. It's our wolf. We did a redesign of it. Yes. These are all created randomly right here. And so that's the big thing. Now, one thing we mentioned yesterday is we have right here what is called a seed, and this is like your Minecraft world. So Brad, I want you to run Minecraft world seed 1, 2, 3 for running along with me. And I want you, Brad, do you have this in? I want you to do, or Ben, sorry, it was Ben right there. Ben, I want you to do Minecraft world 1, 2, 3, and I want you to tell me what your p-value is estimated to be. So what is your p-value when you do 1, 2, 3 on this? Hopefully you're doing it along. Watch this. I hope. We're going to cross our fingers right here. But let's hope Ben is doing it. And let's see if Ben runs seed 1, 2, 3 and runs the same data, because I think he's running it along with us. He's going to run seed equals 1, 2, 3, and he's going to tell us the p-value. Now, I haven't ran it yet. He's going to tell us this p-value right here. So what is that p-value going to be? What is that p-value going to be? Give it 10 more seconds. Second, run it, and then if 0.05 is in the range, change it. Yeah, I'll talk about that here in a bit. Did you go back up to your p-value right here? Is that your p-value? I want you to say it's that way. And then, but scroll up just a tiny bit, and where you should see discrepancy of this, and then you should see p-value of this. And did you get it? If you ran seed 1, 2, 3, did you get exactly this for your p-value? I'm just waiting for the yes confirmation. Yes. Oh, wait, 0.714? We might be running a different version of R. Here, run this real quick. R version. Are you running the same version of R right here? Oh, wait, did you get, that's what you got? Run your version of R, run R version, and tell me if you're running 4.0.0. And, oh, then there's the R randomness. So the way R does randomness, like the randomness version, you got that right there. I got 0.712. You got 7.1? 712 or 714? Oh, I might be using a different R randomness. We figured out this. We figured out how to change the R randomness. I might have changed my R randomness, how it does random number generation. So if you look, Brad and Ryan and Ben got the same values, but last semester in 474, we had to change the randomness generation, and I might still be using a different randomness generation than everyone in class. So everyone's getting the same result except me. I'm the problem. Version, yep. And I think it's the way the randomness is done. I can't remember. There's different ways randomness can be generated inside of R. And so I'd have to look and see how my randomness is being generated. So I think I'm the problem because I've changed like a different randomness generator. Like you guys are playing Minecraft on PC and I'm playing Minecraft on Xbox because so my seeds are different than yours. But if you change over to the Xbox, you'll get the same randomness because I'm using like different randomness generation procedures, but you'd have to just switch your randomness generation procedures. So many little things. Let's go back. Okay. So we understand very well what's going on with these permutations now. And if you notice how Ryan, Ben, and Brad, 20 points, gentlemen, right there, were able to all get the same results because they were all using the same seed and they have the same randomness generation procedures. Don't worry about the randomness generation procedures unless you've messed with it like I have. Like, if you haven't messed with the random generation procedures, you're fine. So, key thing, just don't mess with your randomness generation procedures. We had to do some stuff with that in 474 like a month or two ago, and it created randomness, too much randomness. So, right here, we see the format of the code. What does permutations control? Permutations controls how many times you mix up the data. So this is just like how many times you shake up the box. So here's something crazy you could do. We're going back to the screen. You could literally go right here and say permutations equals 2. And now, can anyone give me the p-value for this? I would love this as a test question. This is a perfect test question. 100 points, first person to tell me the p-value here. What is the p-value? First person, tell me the p-value. Alex, yes. We're going to give you a second. I think, Alex, you already got points, right? And Mila, right there. It's 50%. Great job. There's the p-value. Let's try this. Can you tell me the p-value on this one? It's iffy. It's iffy because of this. Like, it's either one of two values. So there, I did 5 permutations. So the p-value here is one of two things. I would guess one of these. 100 points first person. What's the p-value on this one? There were 5 permutations. There were only 5 permutations here. So there's 5 permutations. 1, 2, 3, 4, 5 behind my head right here. Ryan, you might be right, or Grant might be right. I think Grant's right. Grant, 100 points. Grant, I think you're right. Grant, you're right. Because 4 out of the 8, when you look at it, 1, 2, 3, 4 out of the 8 results are more extreme than our results. Does that make sense? Because there were 5 permutations. Let's try this. Another 100 points. Who here can estimate this p-value? There's 10 permutations now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's behind my head. So 1, 2, 3. That's the important stuff. Oh man, Tyler, so good to see you. Oh wow, and wow, Emily, Austin, and Nicholas, 100 points. Tyler, so good. Tyler, 500 points right there, Tyler. You guys are getting this now if you knew this one is 70%, because you're just seeing how many are as extreme or more extreme. And look, right there, would you have thought at the start of this class, you'd be like, okay, I understand like how to look at this graphic and get the p-value instantaneously by saying like, oh, what % of the results are as extreme or more extreme than my result? And that's what the p-value is. So you just find out what % of the results on this graphic are as extreme or more extreme than your result. And these results right here, yes, James, 100 points for tagging Tyler right there saying, hey, we love the positivity. That's what we do in our communities. We're all positive right here. So hopefully the permutation procedure is making way more sense to you guys and gals this morning. Hop back right here. It's 200 points today. 200 points max points today. And some people already have the max. So great job on getting some crazy awesome points. Jonathan, another 20 points right there. So what does the seed do? It replicates results. And so here's your output, fun output. And there's that. Here's the result. When we look at the results by random chance, these are the small discrepancies we get by random chance. And here's our discrepancy, which is super unlikely by random chance. And what is the p-value here again for 20 points? You should know this p-value. You should look at this and be like, boom, which I love putting test questions like this. I put one like this all the time, and then I feel really sad. You get it. 20 points right there. Everyone's getting it. Because I feel really sad because people come up to me after the test and they're like, how am I supposed to know the p-value for this? And I'm like, there's no results more extreme. There's nothing over here. There's nothing. So it's a 0 p-value. But don't worry. If you don't remember it, there's a lot to remember. But once you know it and you get it down, you'll be like, oh, I just have to look at how many results are more extreme that happen by random chance. You know it like that, and you see it. And it's one of those things like, just the more you know concepts, it's like if a 5th grader asked you, well, how do you multiply numbers? How do you know 6 times 6? And you're like, it's 36. And they're like, how do you know that? And you're like, I don't know. I've just heard 6 times 6 is 36 a million times in my life. And so it's like this to me, but to them, it's not as quick. Maybe it's like 2nd grader. I don't know. But that's the thing, is when you get these concepts down, you look at this graph and you say, oh, the p-value is 0. And then when someone's like, how do you know that? And you're like, well, here's our result. Here's the results by random chance. There are no results more extreme than our results that happen by random chance. So the probability of it happening by random chance or more extreme is 0. And so hopefully it gets to that point. That's what we want, is when you look at it, you're just like, well, of course it's 0. But then you kind of forget that you had to learn that, and it just becomes secondhand knowledge, or just firsthand knowledge, I guess. Statistically significant, practical significance. We talked about this a lot yesterday, so I'm going to go a little bit quickly through these because we're going to get to the end of these slides today, and I'm going to show you some more stuff that's going to help on your assignment. And do swing by office hours today if you're working on the assignment. I might do some later in the evening office hours too. I think a lot of people have been asking for that, so let's get some more office hours in here. So we need to figure out a good time for that, but I'll probably do some later evening stream. So statistical significance is the easiest thing in the world. You should have in your notes that statistical significance literally just is p-value below 0.05. That's all statistically significant is. That's all it is. What time would be good for everyone? Just put what time you guys want, and then we'll try to do it around there. Statistical significance just means less than 0.05 p-value. That's all it means. Practical significance is the hardest thing to talk about in the world, because practical significance could vary from person to 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 person. One of my favorite examples is this. If I told you that we had a seminar, I think we might do like 4 or 5 p.m., 4 or 5, Brad, we might do around there, and it'll be recorded and probably go for like an hour, hour and a half or something like that. So, and I'm usually here till like, and sometimes I have to leave, like I think I have a meeting tomorrow. I got to look, because there's all like getting ready for next semester. We just have like random meeting at noon, which I like, and I like helping out with. But if I have to, like sometimes I have meetings I have to go to. So sometimes I'll be like, got to leave, meeting at noon. And so the joys of being online when you can just be called anywhere and anytime. So anytime after 2 works, probably 4 would be good. Are we going to be in class this fall? Yeah, it looks like, I mean, everything, you know, it literally changes from day to day to day to day to day to day. And one of the things, so I'll mention that briefly here, we're just looking at with, you know, for classes that are online, so there's gonna be like a mix of things as far as I know. It's gonna be like some classes are gonna be online, some classes are gonna be in person, and they wanna make sure we have the best. The meetings I'm in right now is related to testing, like with Lockdown Browser and all that stuff. So we're making sure we have the best available software, because we take all of these decisions very seriously. We, you know, there's literally from Haslam, about 20 of the best educators in Haslam, like Dr. Cole, who's absolutely amazing, Dr. Jacobs, Dr. Collins, Dr. Stank, like all these top tier educators in Haslam who really care about, you know, like, are our students getting the best opportunities? Are they getting the best, you know, education? And we're all meeting and discussing the best strategies to make sure testing is fair, testing is accurate, and we're using the best platforms, and a lot of big decisions are being made. So we're very serious. There's no fall break? Oh no. And classes are done before things. Whoa. Is that true, Brad? Even I didn't know this. There's a lot of, just stay up to date on it. That is true. Wow. Well, it's oh my God. Oh my gosh, 7:15 to 8:05. Oh my gosh, that is let me just, one last thing. Okay, this is my last story. I like story time with Brian. Maybe you guys do too. When I was it was my second semester at Appalachian State when I was a freshman. I decided that I was only going to have classes. No, it was at UT. I decided when I was at UT, I was only going to have classes on Tuesday and Thursday. So I decided, I agree, Emily, great stuff right there. I decided I was only going to have classes on Tuesday and Thursday, and I had like 15, 16 hours, probably 15 hours, but I had 15 hours of classes only on Tuesday, Thursday. And so I would like wake up on Tuesday, I'd go to like 8 a.m. class, and I would have class till like a 5 or like 5:05 to 6:20 class, like what it used to be. And so I would have classes all day, but every week I would get a 4-day weekend, and I would use like Wednesday to work and study. But I was like, oh God, I can't even remember. Like I was, on break more than I was in class, because, Tuesday, Thursday was like mega class days. And then Wednesday was like reading up and doing the work. And then weekends were hopefully doing some work, nowadays. Yeah, the weekend. Well, it was funny. Like I lived in the dorms. I lived in Grieve, which is no longer a dorm. I mean, it still exists, but not a dorm. And I remember one time this person asked me, like, do you go to class? And I was like, yeah. And they're like on Monday, I always see you just like everything. And like, you're having fun on like Thursday night. And I'm like, yeah, that's my weekend. They're like, wait, you don't have classes on Monday and Friday? And I was like, no classes on Monday and Friday. Of course, Haslam, we don't have classes on Friday. So I really like that. But we have Monday, Tuesday, Wednesday, Thursday. and I still do work now. So, but I've figured out, this is Brian's life advice with Brian. I figured out if you do work on the weekend, all of a sudden your week is a lot easier. Like, it was this magical thing when I started doing work on the weekend. I was like, whoa, if I like do work on the weekend, then like during the week, everything's easier and I can stay on top of the work. Whoa, I just have to like do like, I don't know, like Saturday I do like 5 or 6 hours worth of work. Like I just section off this time, and Sunday I do like 5 or 6 hours worth of work. And all of a sudden during the week, I'm not behind. And so that was one big thing. So and one of the biggest things now is I'm getting ready to move. So that takes up a lot of time. So a lot of my weekends are literally packing, moving things, selling things, getting rid of things. So a lot of time allocated to getting ready to move. So anyways, life advice with Brian over. Let's get back to being serious here. Practical significance is the do we care about it right here. I will be on campus some during the fall. Say hey to me when I'm on campus. And I should have my office. We're redesigning our floor. Say hey to me. Like be like, hey Brian, and like be like, I'm Ben. And I'll be like, hey Ben from the summer, right? And I'll be like, yeah. And you'll be like, I'm in 474 now. I'll be like, oh yeah, of course. Like, you guys know I'm just chill. Come talk to me. It's so funny. Like, Andrew will tell you, Andrew, is it pretty easy to just talk to me? Am I just a normal person? I know I keep talking to Andrew right here, but Andrew, I know personally, been to office hours, was in 201. Kind of related, is BAS 474 online for the 8 a.m. slot? Yep. Should be online. Yep, because I think that's the one I'm teaching. Love coming to office hours. Exactly. And one of the goals is my last, we had a big little aside with Brian right here, is I want my office. One of the goals, and Andrew and I have talked about this, is like, I want it to be an open place for students. I mean, we practice social distancing and everything, but I want my office to be a study place for students to use. I want it to be where you can come in, and hopefully the world is slightly back to normal. It's just crazy. We don't know where anything's going to be at, but and free candy. Brad knows that right there. So I want my office to be just like, you can go there, and I want to be on the screen. So, we'll get the candy, we'll get everything back. And, I want to be on a screen. And so when you come to my office, we've even talked about Robot Brian, but you'll just come to my office. I'll be on the screen maybe. So you'll see a screen with me on there. I'll be like, hey guys, what's up? And I'll probably be like more like, I could do it right here real quick. Rah. Oh no, why did I try to do something? Streamlabs is being weird today. No, there we go. So I could like expand and be bigger on the screen and just be like in the middle of the screen, be like, hey everybody, what's happening? Like, let's just do some work today. And then I could like go to different screens around the room, which is my goal. So we're working on all these things right here. And this is what happens when you try to change things live. Streamlabs is being a little bit slow and being weird. Don't be weird, Streamlabs. Okay, so let's get serious right here. What is practical significance? Practical significance is the literal do we care about it? And this is one of the hardest things to talk about, because imagine somebody told you you could increase your grade by 1 point in this class by taking notes. I hope you would. Imagine someone said you could increase your grade by 1 point in this class by studying 10 hours a day. You'd be like, not worth my time. Not worth my time. You can increase your grade 1 point in this class by chatting one time during each class. Actually, that might be true. You'd be like, okay, well, now it's worth it. I got to make sure I chat. Say hey in the chat right now. Remember, you get those Streamlab points by chatting, like on top of what I give you. If you're chatting, if you're interacting, you're getting more Streamlab points. So everyone would be like, wake up in the chat right there. Wake up. So get those points. Andrew's getting those points right there. Alex is getting those points. You guys know what's going on. Sounds like elasticity. Yeah, and this is all practical significance. This is the do we actually care about it? So do we care about it is one of the hardest things to talk about, because it's like, good morning, Philip, wake up. Do we care about it? But statistical significance is just p-value. So easy to talk about. P-value is the easiest thing in the world. It's just like, it's all good. Now here's a big thing. People notice this. So we have the, is it statistically significant, and do we know it's statistically significant? So please listen to these two distinctions. Is it statistically significant, and do we know it's statistically significant? Let's look at some results right here on the screen and see the differences. So is it statistically significant, and do we know it's statistically significant? So let me try one right here. Figure too large for margins. Oh, invalid graphic state. What are you doing? Invalid graphic states. What's going on? Warnings. Everything's broken. We're taking GPA by gender. Oh, I think I know why. Sure. What is going on? What did I break? Error in external graphics. Let me go here to file save. I feel like something's broken. I broke something. It's not good. Let me go exit. Sure, save selected. Cool. And we exited our. Go back in here. Let's see if we don't have it broken now. So BAS 320. Look at this is what happens when you open everything. And now we go here, here, and here. Look, it runs now. We get small p-values. I didn't want small p-values. Did you get mad about this one? These are too small for us to see. So small p-values. Gender, like text per day. There's a few I could do here. I think we'll see it. Let me show you on the slides. The slides got examples. And the graphics are so small sometimes when you're zoomed in there. So let's hop back to the slides. This is a key concept. The reason I want to show you as many examples as possible is because this is on the test. And I know there's examples way back here. I know I keep going through the hot or not survey. But the key examples you need to see are with this right. Where's the intervals? This right here. Okay, so this is the output you get. And I want you to look at these values right here. This is what the slide is talking about, is right here, and right here. So please note that these are intervals to estimate the p-value. Now, these are 3 tests we have not talked about yet, but these are intervals to estimate the p-values. So we're trying to estimate what the p-value is, and all of these intervals are above 0.05. So tell me, you'd be very confident that these p-values that you estimated here are what? Statistically significant or not significant? You'd be very, very confident that they are statistically significant or not statistically significant. Look at all the estimates of them. You're saying, I think the p-value is in this range. Now, this is what you're estimating it to be like. This is your guess and not significant. Bingo. Because you're saying, I think the p-value, the true p-value, because we just estimated the p-value. This is not, we don't know this is the p-value. It's an estimate of the p-value. That's why it says estimate of the p-value. This is not the p-value. It's an estimate via the permutation procedure. And then, but we're saying, but it could be between this range. Now, what you don't want to see in this range is 0.05. So there's 3 instances. I'm going to draw this out for you here. This is very, 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 very important. I'm going to draw this out for you. There are 3 instances we should worry about. The 3 instances we need to worry about are the following. So let's put 0.05 right here. We have a range like this, and this is significant. This is like we know it's significant. This is question mark. And this is not significant. So these are the 3 things that can happen right here. So you have these 3 different things that can happen. You have right here that it is either significant, like your interval is significant because it's below 0.05, or your interval contains 0.05, and then you're like, well, I don't know. It could not be significant, or it could be significant. Does that make sense? Like you're like, well, maybe the p-value is below 0.05, or maybe it's above it. I don't know. But for this one, you're like, oh, the p-value is definitely below 0.05. And then for this one, you're like, oh, it's definitely above 0.05. This is whether or not you have a conclusive result on the p-value, because this is us trying to estimate the p-value. Does everyone think does this make sense to everybody right here? We do not want to see in our estimate of the p-value 0.05 in the range, because then we're like, well, I don't know if it is significant. Maybe it is significant. Maybe it's not significant. But here you're like, oh, it's definitely not significant. Oh, here it is significant. So you don't want to see 0.05 in the range. So when you look at this result over here, you can see that these intervals are conclusive because they're not significant. We'll go back to the zoom in on the slide on that. So these intervals right here are conclusive. So this is not significant. Does everyone see how these are not significant? But the intervals are conclusive because they don't contain 0.05. That's key. The intervals are conclusive because they don't contain 0.05. I've got a good bit more to cover today. Let's do it. Hot or not survey. And we did statistical instruments. Oh, we finally got to it. Okay, so now we are looking at the association between a categorical and a quantitative variable. This is categorical, quantitative, and we should get through most of this today. Categorical, quantitative. Categorical, quantitative is going to be measured by what? 100 points first person. Categorical, quantitative, you need this note, is going to be measured by what's. What is the graphic we will make to measure categorical, quantitative? It's in yesterday's notes. Yesterday's notes have it. Oh, yes. 100 points right there. Grant, Mila, and Corbin, and Brad right there. You guys are right. Yep, yesterday's notes right there. Side-by-side box plots. So if you have that from yesterday, and if you don't, it's right there. There's your categorical quantitative. That's from yesterday's notes. And we understand that when we have this, side-by-side box plots, measured by side-by-side box. Great job. You got it. So these are some of the examples of what we can do. You can do like, how attractive someone is, all these crazy things. We're just going to judge people. Yay. So we've got these people right here. This dude, I do not understand. He is in water. Like, what are you doing? Why are you sitting in water? Is this like a senior class photo? I'm sorry, man. I'm sorry. I'm going to make fun of myself a good bit here because there's totally me. The me person, that's totally me. I just need to, it's happening. I'm just going to like, wait, I can't do it. I need to go back and look at this. I always joke every semester that that's me, but this is slowly becoming me. This is me in 4 months. I'm sorry, man. I don't know who you are. I like your hair. I like it. That's kind of a cool jacket too. I never noticed that. He's got layers. He's done a good job. I'm sorry, but he was ranked as least friendship potential. So it's, I don't know. I don't understand. He got least friendship potential. The guy in the middle looks like the dude in My So-Called Life. I could see that. I could see that. I love it. You were the guy on the right. See, it's all right as long as you make fun of yourself. I think it's all right then. Like, we can poke fun of ourselves. This guy right here, one of my friends, Jimmy Astro Lewis, people used to know him. He was like, everyone knew him at UT. We got to zoom out. We got to go to the zoom out. But whenever I see this guy, he looks like Jimmy Astro Lewis. And like, he was the friendliest dude in the world. Like, I knew him from like Campus Entertainment Board because I was on there with him. And he also worked at Starbucks. And he was like just the coolest, like most chill guy ever. So every time I see this guy, I think of Jimmy Astro Lewis. And I should see what Jimmy's doing these days. And this guy right here, he's looking like he's having a nice time. Like, he looks like every one of these gentlemen look very nice. Like, you just look at them, you're like, they all look like very nice. And they were the most friendship potential guys. Where there's the bird. That bird right there got highest friendship potential. So that bird right there had highest friendship potential. Definitely bird. And so what are we judging right here? We're judging a quantitative measure for these individuals. So this was an actual survey done. So it's kind of like, one of the things I like is like, I like psychology. I've told you guys 1,000 times probably that my undergrad is in psychology. So there's a lot of psychology. This is rated attractiveness highest, attractive, least attractive, most attractive guys right here. I don't get this guy. I'm sorry, guy. I don't get it. Does anyone else? I don't know. I don't like that picture. Once again, I think these three gentlemen right there, 1, 2, 3, these three gentlemen, the angle, is that the good thing? He's tilting his head because of these things tilt in the background. It's the beard. Is that what does? It's his beard right there. I don't know. I don't get these things. And then least attractive, I got the award again for least attractive. This guy looks like my friend Steve Wusso right here, who I think is a lawyer now. I looked it up. He and I went to a Ben Folds concert, and he drove, and he was a vegetarian at the time. We got some really good vegetarian pizza, but he reminds me of our friend Steve right there. So, but this is Brian and Steve hanging out right here. We just, we did not win. No, I don't like the head tilt. I don't know. Every time I look at this picture every semester, I'm like, I don't know. I just don't get it. So this right here is actual survey data that Dr. Petrie did. He had people rank the attractiveness, the friendship potential. So it's very interesting because it's psychological data. And so we should always consider these things to be like, okay, we actually, these are real fields of study that people measure certain quantities. Like, what do you think about individuals based on how they look? And this is social psychology. I guess it would just be social psych, not cognitive psych, but this is social psych. not behavioral psych either, but it's very, very important and very, very, I would say, influential in our society because there's a lot of like first impressions people have, and it's very interesting to see. And I think we should figure out why those things occur and like dismantle them and try to be like, okay, well, why do we have these preconceived notions and why do we think these things? Like understanding what we think and why we think is very important. If you guys can't tell, I love psychology. Like it's very important just to our world. Like, why do we think certain things? So I love my psych undergrad, and I try to use it to my advantage to be like, okay, like how does our brain work and why do we have these certain like thoughts and create certain kind of pathways in our mind. So once again, we know that X and Y have an association if for whatever reason, knowing one value of X tells us information about Y. So we can see here that we have different distributions. So we have a distribution that has a shift in the mean, a distribution that has a shift in the standard deviation, and a distribution that has a totally different shape. So look at this right here. You would know, like if you had two football players and you wanted to say, well, how far can they throw the ball? The football player right here would throw it further than the other one on average, and it's pretty much the same. The football player here would have more variation, and then this one has a totally different distribution to it. Like the red distribution right here is totally different. So it's a right skew instead of a normal distribution. So you would say that knowing in any of these instances, different football player, the like football player A versus football player B, A versus B would give you information. This one would tell you it's higher on average. This one would tell you it has more variation on average. This one would tell you that there's a totally different like shape to the distribution. Like one's going to be right skew and one's going to be more normal centered at this. So getting information tells you that there's an association if you have information about it. Now here's the biggest thing that we have, and we got more than enough time today. The whole goal of comparing multiple groups is we either compare the mean or the median. So we've got mean or median. So we need to compare the mean or the median. Now we have to know when we compare the mean or the median. We compare the mean when the distribution is roughly symmetric. So the test we choose is either going to be the mean or the median. We use side-by-side box plots, and here's the slide I was looking for. We will use the mean when it's roughly symmetric with no outliers. This is the, like anything you see in these things right here, whoops, you should know instantaneously. You should know that we're going to use side-by-side box plots to compare these. Like you should know this. Like how do we compare multiple groups on a quantitative variable? Side-by-side box plots. We've already reviewed that today. Like you should know multiple groups like on a quantitative measure, side-by-side box plots. And they should know next, we're going to compare the mean or the median. So with this graphic right here, would we compare means or medians? Would we compare means or medians between those? Would we compare means or medians? This is a big thing. Like I could put this right on the test and be like, would we compare means or medians for these groups? Means, because they're roughly symmetric. Nicholas, 100 points right there. Great job, Nicholas. It'd be means. And then I know this is a counter. Well, wait. Would we compare means or medians right here? Would we compare means or medians? For this graphic right here, would we do means or medians? We'd still do means because they're still roughly symmetric. This one has a greater standard deviation, but they're still roughly symmetric. And then we get over to here and we see that there's one of them. And if one of them breaks the rules, we change. We're like, okay, we're not going to do this because now it's no longer roughly symmetric and doesn't really follow the normal. So this one is where we would compare medians. So on the first one, we'd use means right here. So this one right here, we'd compare means between the two groups. We'd still compare means here, even though there's different standard deviations. They're still both roughly symmetric and normal. We'd compare the means. And this last one right here, we'd compare the medians because this one right here is so different. We'd compare the median to the median of this one. You can't compare a median to a mean. So you're like, okay, one of them is no longer normal. I'm going to compare the medians right here between them. So we have to make the choice. Are we going to do means or medians? Now, what's really great about this, and there's the normal curve. This is the normal curve. Mean and median are the same spot. And to analyze whether or not to use means or medians, we're going to use a QQ plot. And this will be a good 5 minutes right here. Knowing how to read a QQ plot is very important. So when we make a QQ plot, it's literally just the code QQ inside of R. And this is from reg class. So you have to have reg class loaded up. It's just QQ. Now, what we want to see, if it's normal, is it follows this red line. Does everyone see this red line right here that I'm tracing over? That red line right there that I'm tracing over. So the red line right there. If it follows this red line, it's normal. If it doesn't follow that red line, it's not normal. And it could really not follow it and be really not normal. It could be really weird. Does everyone notice that the only one that follows it really well is the one that looks mostly unimodal and symmetric? If you're like, well, Brian, that doesn't look unimodal and symmetric. Let's make a few real quick here. Okay, so we hop over to here, and all we need is a quantitative data. So let's go here and go to survey 10 $height. And there's the heights, and let's go to hist. And here it is right here. So this looks mostly unimodal and symmetric. It's got some outliers, so we're going to see those appear. And then we just go and we take the variable, and we go QQ, and here it is. And actually, you know what? It looks mostly, does everyone see these? There's this little bit of oddness at the bottom, and it varies away. It's mostly normal. It's like kind of normal. It's like got small problems. It's got problems here and a little bit of weirdness here. But the more it follows that red line, the more normal it is. That's, it's not great. But we could do something like text per day. Now, if you look at text per day, oof. People were saying in that chat earlier. Does this look normal? Does this look normal? Does that look normal, yes or no? Does that look like a normal bell-shaped curve? And this is what you need to know how to analyze. You should be like, okay, since this doesn't look normal, and I can tell you what this will look like. That's a no right there. Sylvia, 20 points right there. This is definitely not normal. And I can tell you what this will look like when we make it. We'll get this is like the perfect normal. Then we'll get the boundary right here of where it's like our, like the boundary is like the end. And then our results, we're going to get something like this. So this is what we're going to get right here. We're going to get something that looks like that when we plot this. It's going to, that's how a right skew looks. So let's go ahead and bring it up. QQ plot. And there it is right here. So if you looked at the pattern I just drew right here where it has this, that is the same pattern right here. There's that, and there's that. I knew it would have this like bevying out. Don't worry, you don't need to know as well as I do, but I knew instantaneously. And how do I know that? If it's right skew, it's like pushed into the right. It's like smashed in this way. Like right skew is pushed this way, left skew would be pushed this way. You don't need to know that as extreme as I do, but look at how it way deviates from the red line. Like the red line is way, and it doesn't follow it at all. And when does it not follow it? It's tough to say. It's tough to say. This is where, people's, like own personal opinion comes into play. This one right here, if someone told me this wasn't normal, I'd be like, you're crazy. If someone said this wasn't normal, I'd be like, yeah, I can see it. Does everyone see how we have this problem up here? And that relates to this problem area right here. Look at where the problem area is, where there's too much data, and it deviates from the normal. So you can see it happening right here that there's too many values up here. It should bevy out, and that would make it so it follows the red line. But this area right here is like, there's a problem area up here. Like everything's good. Like even these values down here, yeah, it's about what we expect with the normal. There's a little tail on the normal. That's fine. And then when you go over to this is like, wait a minute. These values here of 5,000, if you look at where these are at, they're at 5,000 just like this. So there's actually two observations right here. You can see the two observations right here, but those are the two observations in this bin which relate to things, and the whole thing is just not following the normal. It's got this right skew shape to it that I know so well because I've seen the right skew shape a lot. You've got the bimodality here, which just looks ridiculous. Like if someone told you this was normal, you'd be like, yeah, that doesn't follow that red line at all. So this is not normal at all. So here's the quick version of this. If it follows the red line pretty well and doesn't have too many points outside, like what is too many? This one's perfectly fine. Like if someone told me this wasn't normal, I'd be like, nope, it's fine. Because these are your lines of your like, well, if there's a point outside, it's not that big of a deal. Like this one is like where I'm like, okay, that's not normal. If someone said it was normal, I'd be like, yeah, maybe I don't want to say it's normal. But then when you get to these, you're like, that's not normal. That's not normal. Does everyone hear there's no exact answer to this in my voice? Sometimes it's pretty clear, but someone could argue this isn't normal. I'd be like, come on. It's basically following the red line. It's within the okay kind of not so bad range. Like this is the okay, everything's not going to be perfect range. But this one right here has a big deviation at the end. This one right here has major deviations throughout, especially down here and through here. And then this one right here is like, yeah, that's bimodal. That's not unimodal symmetric. It doesn't follow that red line at all. At this point, if someone told me this was normal, I'd be like, no way. No way. Impossible. That's not normal. So this is not, you can use subjective language on these, but you do need to make a choice, because on this, would we use means or medians for this one? Means or medians? Let's see it in the chat. Means or medians? Means or medians? Means or medians? And during office hours, I'm going to help with a major thing for your guys. Medians. 100% medians. Means or medians for this one? Means or medians for this one? Means or medians, and then it's still medians for this one. Still medians. Means or medians for this one? This one is where I'm probably still going to use medians. So you see decent match, except for large DPAs, some symmetry, departure from normality. I'd probably use medians here. It's not the end of the world if someone used means. And then over here, you'd use means. So this one's means, definitely. This is definitely means. This is probably medians is a better use of things right here. This one's definitely medians. This one's, oh, definitely medians. So we just go from like good match for normality. You could use normality, but I probably wouldn't. And then definitely don't use it. And are you crazy if you use it right here? So there's different degrees of does it look normal. And so once again, our goal of this is just to figure out if we should use means or medians. That's the whole goal. Here's the comparing of multiple box plots right here. And we can see here the 5-number summaries. And how would the box plots look if the difference is, this is how we'll end class. We're going to end class with where we started. Guess what? We're going to go back to here. And how would the box plots look? How would our box plots look if the differences we saw in the box plots were likely by random chance? They'd look very what to each other? If the differences we saw in the box plots were likely by random chance, the box plots would look very what to each other? If the differences we saw in the box plots were likely by random chance, people might be saying in the chat, similar, you're right. Because then the differences you see are just likely by random chance. If you saw some small differences right here, so now we see small differences in the box plots. And then over here at the end, we might see large differences in the box plots. And the large differences would be less, or basically unlikely by random chance. So does this make sense that now we're going to do the same idea we did earlier, but with box plots? And the discrepancy in the box plots are going to be calculated via the differences we observe between the medians or the means, but means you don't usually see in box plots. But the bigger the differences in the box plots, the bigger the discrepancy, and the less likely that discrepancy is by random chance. This was why the start of this class was so important, and I spent so much time going over this, because literally what we're doing here with the box plots, which we'll finish up tomorrow, and we'll do an activity tomorrow, and we do have everything for today with the associations. I'll double check the assignment. I'm going to help out with one thing during office hours that people might be stuck on. There's a conditional thing with the party size. So if you are stuck on that, definitely check out office hours, and I should be doing office hours later today. I'll send out a reminder. But does everyone see the similarity to what we're doing here to if we have small differences, the discrepancies will be close to 0 and we'll get a large p-value. The bigger the discrepancies, the smaller the p-value, because the less likely it is to see a difference like this by random chance. So the graphic we did earlier is so very important in understanding that we're going to look at where our result is and we're going to measure our discrepancy. And we're going to make permutations here. That is what we will start class with tomorrow. I'm going to be so nice here. I want to drink a second Red Bull. Can't do it. That'd be so horrible. I bought 4 Red Bulls for the remainder of the week. And I'm going to be good and drink only 1 Red Bull a day. But this has got it. This is where I want us to end because I don't want to rush through any material. But I just want us to see right here that this is what we are doing again. That's why it's so important to understand the permutation procedure. Drink all of them right now. Don't tempt me. I've done it before. Don't tempt me, Ben. Don't do it, Ben. Don't tempt me. Drink all my Red Bulls. I'll be all tired. I feel like the Red Bull's kicking in. I've been trying to get my 8 hours of sleep lately. We will finish this off tomorrow. We'll do an activity tomorrow. So we'll finish it off. Yeah, we got more. We're fine. I wanted to get through the rest of this today, but I don't want to rush notes. But who here feels like the class has been a little bit easier this week? It took me until this long to realize the Mewtwo. I like that you realize it. A lot of people will tell me that. They'll be like, wait a minute, Mewtwo. Like, wait a minute. When Red Bull first came out, I was given 4 by a promo girl at a gas station. I drank them all and drove from Montana. I like that, Brad. I like that a lot. When one time Red Bull, the Red Bulls reps will come to UT, and we were at a tournament for GoldenEye. It was like the new GoldenEye came out. What was it called? Oh, it was like in 2007. It was GoldenEye for like original Xbox. It was the new GoldenEye or whatever they called it, that because everyone loved GoldenEye back in the day. And so it was a new James Bond game, which they haven't come out with a James Bond game in a long time. That's a series that no longer happens. But the Red Bull people were there, and they gave us like 20 Red Bulls, and that was the coolest thing ever. Like, just like free Red Bull, and they definitely got me addicted. That's see, look at what they did. They'd be like, oh, but we gave them 20 Red Bulls. Well, I've probably bought like 500 Red Bulls in my lifetime now, so they definitely got their money back on me. So smart Red Bull people, like, they know if they can get you 20 years later. I know, like 13, 14 years later, I'm still drinking Red Bull. So good choice. My cousin, he's the reason I started drinking energy drinks. I didn't even realize. I thought they were soda at first. And so he went to Geneseo and he had extra like dining dollars. And so at the end of the semester, he went and bought like cases of energy drinks. And I just thought they were like sodas. And I was like drinking like 3 or 4 a day, and I was getting like so wired. And everyone's like, "What's wrong with you?" I was like, "I drank a bunch of soda," and I didn't realize they were like energy drinks. So like I was drinking like 4 or 5, basically Red Bulls a day. So yeah, it was it was crazy. But man, I missed that. It was like, I wonder if I could find that energy drink. When did Red Bull come out? Like 03, 04? Red Bull probably came out like, I don't remember Red Bull really appearing between like 05 or so. I may have missed. Did we decide on a time for office hours? Let's try to do like 4 p.m. Let's try to do 4 p.m. Let's do 4 p.m. I'll send out a reminder. We'll do some office hours at 4 p.m. That it was 2002. That about makes sense, because I remember the first time I remember seeing Red Bull was 05. I mean, I'm sure it was out before then, but that's when I first remember Red Bull was 05. Because I can think about where I was at and who I knew, because I was in the dorms. So it was like my last year in the dorms. So that's the first time I remember it. And so 05 is when I remember it. So, I mean, obviously it could have came out before then. Will you take questions about how the homework? Yep. You got it, Ryan. Let me make you mod here, Ryan. Yep. I will. Remember to work on the homework and everything. We'll do most of it or some of it, but don't wait till office hours to do it. I mean, like, I'm going to help out, but, obviously, like, give it a look now, figure out what's going on, and yep, give it a look. Awesome. Thank you, Ryan. Give it a look. Figure out what's going on. Don't fall asleep. Go drink another Red Bull. I want to make coffee. I need to see. I always want to use like my fancy coffee makers, and then I realized like Keurig is so easy. Like, I ran out of K-Cups like a week or 2 back, and now I'm just like, man, I want some K-Cups again. Because I know Keurig is not the best coffee, but it's like, how easy is it to just get it? I know, I look at Nespresso, and I have a friend who's a big Nespresso fan, and maybe I should get Nespresso. But yeah, well, I don't know, because we'll have a Keurig machine. I like Keurig well enough. Like, I'll put my cream in there, and it's good enough. And Keurig is, like, super cheap, like 20 cents a Keurig. It's like $1 a pod, but best coffee. Oh, see, I'm gonna get addicted to that, Andrew. So that's my problem. There's a few good, and so I've got my pour over coffee maker, and I like that, but I had a problem because I was making like a full pot of pour over coffee, and I was drinking like 4 or 5 cups of coffee. And I was like getting like jitters, and like I never get jitters, but I was like, and it's also like freshly ground coffee. So I was like, maybe like the caffeine in this is like way higher than like the Keurig, because I'm like grinding the coffee, and then like, I don't know, just the way I'm doing it, I was like, I guess this has like way more caffeine. And I was feeling like so awake, like, I don't know, it was weird. And I was like, okay, I don't know, maybe my coffee's too good. It's like, I can't handle. Maybe I should just not drink 4 cups of coffee. That could have been the problem too. Like, maybe drinking 4 cups is a bad idea. Maybe if I go back to just drinking 2 cups or 1 cup, maybe then I'll act normal when I drink coffee. But drinking 4 cups of coffee in like an hour or 2 is probably, sounds like that was the issue. they have like level 1 through 10 on light, medium, dark, and the lighter ones have the most caffeine. Yeah, and it's that's the thing too. I was debating, and I was like, do I want to start drinking Red Bull again in the morning? And I was like, well, I don't know. It really helps me out. That's kind of, maybe that's sad, but um, like just like getting that burst of energy in the morning really helps. And I'm like, okay, I don't know. Once Chelsea and I have our place up and going, I'm just gonna try to go back to coffee again, just using regular old K cups and just drinking my, 1, maybe 2 cups of coffee. Like drink a cup of coffee in the morning and drink a cup of coffee later in the afternoon. But I don't know. It's like I'm like, okay, I have a caffeine addiction. It's like, okay, I do. Just got to admit these things. Got to make peace with the world. Got to be like, well, I guess that's the way it goes. That's what we've created in our society. I keep playing with. I've got a USB port thing right here. Good old USB port. Keep clicking all the buttons. But I will be back here soon. Andrew, we will be back talking about functions. So I will see everyone here soon. But bye for now. Let's click the button. Wait, watch this. Bye, everybody. Be back.
then you can go to design and quick layout. And that's my quick layout. It's my favorite one. You know, it's the chart title, it's all this stuff. Yeah, also, I'll show this again real quick. Look at all these options. There's so many cool things. It's so nice.
Gary! I was just looking for this.
Hey everybody, how are we doing this morning? Good morning. Tag someone in the chat for 20 points. Carly, good morning. Carly has 20 points. I tried to go back and watch. Yes, there's a problem with it. So because something crazy happened yesterday, so hopefully we're gonna fix it up, and I'm gonna probably do a good bit of your guys' assignment today to help you guys out. So we got hit with a copyright claim, because of Crab Rave and Monstercat, which is like the people who own it, which I've been using that for like 2 semesters now, and so we got hit with a copyright claim, and then I like edited out the audio. It doesn't hurt the channel, but like they can like the video, it's like cannot be monetized. I'm like, well, we don't monetize them anyways. These ones we don't monetize, and so I did, because the video is editing. I think it still has only 2 hours of it posted, so hopefully. And I just realized that because I went and looked at it now, and I just saw that, and Crab Rave's out for now. It's like sad times. Like, let's just F in the chat for Crab Rave. So, so Crab Rave is out for now, and I really need to make sure, because I didn't really play it this morning, but I kind of hit the button for like a second to be like, ooh, we're gonna hit for like a second. But because when I saw this and I was looking at it between classes, that only like the first 2 hours are posted. Now, usually it fixes itself, but please tell me if there's any issues. I'm going to try to help out. Today's video should be fine. But that's the first time they've ever hit us with anything. Yeah, and hopefully they whitelist us. Yeah, Adam, we got to do that. I got to say to them, like, hey, we just used this. Can you whitelist us? Because that's what it means to be, like, if the channel won't hit you with anything, they'll make sure. And so I could say, hey, I'll show you how we use this. We just play it like for an intro, and we play it like for a thing, and everyone says Crab Rave. And so we're trying to be as like respectful to the content owner as possible. And I thought we were good because we've used it for a long time. And then when I saw it yesterday, I was like, what in the world? I was like, at first I thought it was like someone doing a fake copyright claim, because sometimes people will try to copyright claim videos. But then I looked, and it looks to be the actual like content owner, which is weird because we've used their content so many times. I've let Crab Rave play for a while before, just let people like rock out to it, and we always like pay respect to it. We're not like trying to make money off their thing. We're not being like, oh man, come here to listen to Crab Rave. It's like, because I know a ton of people have used it, and maybe they get hit with it too, but I've always heard like the people who own it were like, we want this to be like, because I think that's why I heard about it, is like people put it out there because of people getting hit with copyrights, and then they were like, yeah, just go ahead and use this, like for fair usage type stuff, not to get like millions of dollars off of it, but like we want this song to be like really big, and we want people to use it. So that's what I always heard, and maybe they changed the rules. Maybe they all of a sudden said, no, now since the song is so popular, now the rules have changed on Crab Rave. No, that'd be so sad. Anyways, so let's start reviewing right now. Let's make today's video awesome. That's our goal, to make today's video awesome. Quick question, what does this do? What's the point of, yeah, great question. Sarah, let's talk about that. Like, today is like the last day. Today is like the last day of covering like, I would say like how to code. And then we're gonna start talking about data mining. Who would have thought in a class about data mining, we're actually gonna talk about data mining. Crazy ideas that after today, we're actually going to start talking about data mining. So what does this right here do? This creates blank vector. So if you look in the global environment right here, you'll see there's a blank vector. And I'm wondering what kind of class this blank vector is. It's probably blank vector. What is it? It's null. It has no class. So it creates a null object of length 0, but you could, like, there's other ways. You could say blank vector, and you could go integer 0 here, integer 0, and that creates a blank vector of, it creates a blank integer vector of length 0. So both of these right here, if you were to look at them, if you do length of blank vector here, and length of blank vector here, this here has a length of 0, and it's a null object. Like it has no class to it. it's an empty space and the object has no class, meaning like it has no, R does not see it as any sort of type of object yet. But here we created an integer blank vector and it still has length 0. It sees it as an integer object. So when you create this right here, it has no class yet. And so that can be important because you maybe don't want to assign a class to it yet. You don't want to say make an integer object, because you could change this right here and you could say logical. So this will create a logical vector with a length of 0. So you see here it says logical. And so does that make sense there, Sarah, what's going on with the C? It's just creating a vector of nothingness, and it doesn't even have a class to it yet. Like R doesn't see it as a type of vector yet. It doesn't say it as like, this is a factor, this is a integer, this is a numeric, this is a logical, the different types of vectors it can see. It's like, this is just a thing, and this thing has no type of thing to it. Why would we use a vector of nothingness? If you want to, oftentimes, I would say, here's the thing. This is what I would say is preferred method. So you spell preferred? We'll find out because we got spell check now. I think it is. Spell check. Maybe we don't have spell check. You guys can tell me if I spelled it incorrectly. You guys will be my spell check. So this is the preferred method right here because we are not assigning anything to it yet. So like rather than picking and choosing what it should be, we'll just let, when we create it, choose what it is. Now you could choose beforehand, but maybe it's not preferred. It's just kind of what I've always done, is like saying like, let's just create a space for this. And then when we start writing to it, it'll change the class of it. So if you start assigning to this vector right here, like if you go down here to blank vector and you go to blank vector position 1 and you assign into it 2, don't worry, it's a graphical error. And then we go here to class of blank vector. It's probably going to be, it's either going to be numeric or integer. Let's go with numeric. Boom, got it, numeric. Now I could make it integer, I bet, by doing that. Now it's integer. 2L is if you put the L right here, that just stands for integer format. So it's not like 2 and then like object L. So this is a special thing reserved in R for integers. And you don't need to know. Integers take up less memory than numeric, and it's going to store it as numeric first. But integers, we've talked about this a little bit in chat, are 4 bits of memory, where numeric are 8 bits of memory. It's double decimal precision, just the coding background of this. So integers are 4 bits of memory and numeric is 8 bits of memory. So integer takes up less memory allocation. So if you really get deep into coding, you'd want to make sure your code runs quickly and efficiently. So if you can store things as integer values, you'll do that to make computations quicker because the computer is handling smaller bits of memory. So it's like, okay, this is half the memory allocation. And due to like exponential growth on problems, if you're using half memory allocation, or do you want more precise and more accurate? Woo, computing, fun stuff. But does that make sense right here? So how does this apply to for loops? Well, oftentimes we need a space to create things. So great questions, and amazing questions today so far. Sarah, 100 points right there. Sarah, you had 100. Keep asking those questions. And Madeline and Nin, 100 points. You can get up to 200 points these days on these 20-point Tuesdays. I'm going to go back to 20 points here in a second, but keep these questions coming. When creating a for loop, we often need a space to store something in. So whenever you create a for loop, you usually have to go here and say like output and create that. So you usually create a space. So that way when you go here and make your, well, let's do this. Let's do 9 times I, and then let's go to output, and let's go to 1. And we've created a for loop right here that does our 9 times table. Oof, I got a good idea. We're gonna have a little fun to start class. So once again, we're doing functions today, and we're going to turn this for loop into a function. So if you notice right here, I'm going to do a for loop right here. That's just going to go and change this right here. So I need to hear it in the chat. What value right now looks to be my variable? What value right now looks to be my variable? What value looks to be my variable? What value looks to be my variable currently in this for loop? 2, Jordan, 20 points right there. You're right. So let's go here and let's go to 4. And let's do that. And then we could say, that should, that'll do it. And then let's go here to I. Let's go to I. Now that'll change. And then 1 through 9. And look, if we go to output now, We just created the 9 times table. So we've created a 9 times table, and I should do this. I keep talking. Tolliver keeps getting older, but I could create something for Tolliver with this, because let's say Tolliver wants to learn his multiplication tables. Tolliver's like, I really want to learn my multiplication tables. He's about 4 years old right now. That's the age at when you should learn it. At least I think it is. He knows how to count, I think. He loves calling Uncle Brian and asking him, like, what are some really big numbers? But I could say, Tolliver, I made something for you, and it tells you, like, what something times something is. So we have right here a for loop. But what if Tolliver said, I don't like this 9 times table anymore. I want to do, I want to do a different multiplication table. Well, here's what we're going to do. We're going to take this for loop and put it in here to a function. So here is our for loop inside of a function. Does everyone see it's just inside the function? And now what will we let him select? So what will we let him select now? I'm going to show you some really cool things right here. Because he doesn't want to do a 9 times table anymore. He doesn't want his 9 times table anymore. He doesn't want his 9 times table. Well, we don't want to... You think... Yep, and so you maybe are right. So I is how many it'll... Well, we don't need to change. I won't change. He doesn't want to do his 9 times... What should change in here? Because he doesn't want to do his 9 times table. So the answer is kind of obvious when I say that. He doesn't want to do his 9 times... Say, Brian, I'm tired of this 9 times table stuff. The 9, you're right. Everyone answering 20 points. This 9 is going to change. We're going to call this selection. And up here goes selection. And we'll call this times table. And now we need to go here to return. And that's what you have to do to end your function. And then we go here to times table. And there you go. So we've just done it. We did it. Look at how quickly we turned this for loop into a function that lets us alter. So if you look at what we did right here, we went right here and we changed it. Whoops, we need to put it back here then. Oh, no. Well, let's rewrite it. And let's use the quick trick. Oh, it did it. And then this was 9. No, I'm going to copy paste 9. And then it doesn't have return right here. So we took our for loop right here, which we made a simple for loop that goes through and just does a 9 times table. And we put it inside of here such that we could now alter the value it uses. Now, I'm going to change something again right here. Watch this. I'm going to go here to, I wonder if this will work. I'm going to try something I've never tried before. I'm going to go right here, and I'm going to go to, I'm going to try something I've never tried before. Oh, there's the thing I'd really like to try, but I don't know how to do it. I'll spend more time looking it up than it would be worth it. Because it's a thing we did with the string glue. You know what? I bet I can do it. I'll try it here. The format's kind of in my head, and I'll use the cheat sheet thing. Let's say this. I'm just going to do test right here. Let me see what this prints out. That's what I thought. Yep, that's what I wanted. And I don't know. There we go. Got that. Okay. If you can see down below, I'm printing it out. I hate that it prints that way. And can I do it where it says I? Oh, I wonder if... Let me do one more thing right here. Wow, it did it. So yeah, let's do this. And let's go here. 9 times is this. Okay, so let's look at that. Unexpected, we're missing a comma. Boom. There we go. Look at this right here. 9 times 9 times 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. So this way right here of writing it, let's look at the code again, is I'm using the cat paste, and these are all the elements I want to paste together. If you use paste, it'll put them all in quotes. It's not the end of the world. And so this is with the quotes, and we don't get the separation I want. So the \n starts a new line. And so when we do this right here with the cat paste, we get the new line. If you don't use this special character right here, you won't get the new line. So why am I using this \n? It's a special character that gives the n a superpower, and it makes it a new line. So it becomes not just letter n, it becomes special character n, starts a new line when the code runs it. Does that make sense to everybody what's going on right here? Like this is no longer the letter n, it's a special character which starts a new line. By adding that on here, when I run this, when it gets to that, it says, okay, now do a new line. And when it gets to the next one, it says, now do a new line. So it's a special character. There's other ones, but that one is pretty much the one I use all the time when I'm printing out stuff. Let's see some yeses or nos in chat. People getting this right here? Does everyone see what's going on? Because this is going to be very important, this thing I just created right here. And while writing this, 20 points. Where did selection come from? Oh, good question. So selection was what was 9 before. So this was 9, but then we're allowing Tolliver to alter this. So when Tolliver runs this function right here, he goes right here and he just puts in his selection. So whatever he puts here will go here. Does that make sense? Whatever he puts right there will go right there. So whatever, if he puts 7 right here, it'll take 7 right here and replace it with this. Because the first thing that happens when this function runs is it stores into selection whatever he selects. So that's the very first thing. We talked about that yesterday. But when the function runs, whatever is put there for selection, when the function starts running, this 7 is stored into selection immediately. So now, so technically it'd be like this right here. Selection would become, but whatever he puts there becomes it. So he puts 7. So then when the function runs, it stores that as the value used. Great job. 20 points in the chat. Following along, knowing what's going on. So this sentence right here that I wrote is very important because Carly, 100 points. Thank you, Carly, for asking. Please ask all the questions. I realize this is a lot. I realize we've got a lot going on right here. And so we're going to return this now because we wrote this really nice sentence for him. So we're going to put this in the return, which it should like it. I guess, actually, we don't need to return it because the cat will print to the screen. So 9 times this is this. That's his selection. We need to do that. There we go. Look at that. Look at what we've done. 7 times 1 is this. 7 times 2 is this. 7 times 3 is this. 7 times 4 is this. But you know what Tolliver says? He says, Brian, I've gotten older. Brian, he's 6 years old now. He speaks to me like that. He says, Brian, I've gotten older. Uncle Brian, I've gotten older. So we're being called. Still be weird. I'll be 15. It'll be weird for me to be called uncle. That's only 12 years away. Haha. But he wants to make it so he can do a bigger times table. What could I put right here? Tell me how I could edit this to make a bigger times table. So how could I edit this to make a bigger times table? Put a what and then write what? Who can tell me what to write? 100 points, first person. Tell me what to write right here. Like, tell me what you want me to write. Let's, we can do that. Yep. Sarah, you're right. I'll give Sarah 100 points right there. Sarah, excellent work. We're going to get up to 200 points today. So change the vector. Yes. Yes, 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 yes. So new variable for 9. Yes, yes, 100 points. All those answers right there. You're right. We need to change the vector in the for loop. So we need to maybe put here end. And let's go end equals 9. Now, what am I doing by doing end equals 9? So let's say Tolliver, does he have to put something in for the end of the for loop here? So you see, I'm replacing end right here with this right here. I've already written my code, but now I'm just putting in like, so now if he runs it, it'll still run with 9, but he could go here and do 100. Just like that. But he doesn't need to put in this value because it has a default. Jordan, 100 points right there. You can only get up to 200, but you guys are doing excellent. Yeah, 9 is the default value of end. So this function runs with a default. And let's do this. Let's go here. If selection is greater than or equal to 11, if selection is greater than or equal to 11, then we're going to do this. We're going to say cat. Oh, you know what we could do? We could put a pause time in here. Great job. You've made it to advanced times tables. Okay. So if he selects a number, it's going to print that to the screen. So we go here, we run this, we give it a test, we put in here 11, and we should see at the start. So, but, look at this, we got the problem here at the end. So what we should do is, technically, I don't want to do that. We need to put it at the very end of this. I think we can put it here. Can I do that? Let's see if it did it. Yeah, it did it right there. I hate that it's doing that, but that, yeah, it's not the end of the world. Great job, you made it to advanced times tables, and now that prints to the screen. But if you were to choose something like 9 or 8, then it's not going to print that right there to the screen. And that only runs, so there's your conditional statements right there, if his selection is greater than or equal to this. So watch this. This is where we get to the craziness. If his end is greater than or equal to 100 or 101, let's do that, then we're going to go here and we're going to open it up just to do a bigger thing. We're going to go to read line. This is one of my favorite codes to show you guys. Read line. Do you want this big of a table? And we're going to store the read line into choice. And if choice equals, now we need to do this, enter y or n. And we need to, we got a new line on that. So we need to do then \n right there for new line. And now we go here. If choice is equal to quote y, then return cat paste. Woo! No output. Okay, I think we've done this. That was a lot of coding right there to put inside of here without checking it. And let's take a look. So we don't, no choice was found. Oh. If end is greater than or equal to choice. I shouldn't have asked for my choice because if end is, oh, okay, wait. So if choice is equal to y, let me think right here. We don't want that. You know what we could do? We could cheat. This is a bad idea. Choice is equal to no to start. There we go. So we're just going to put that at the start of this. There we go. And now we go here to the end and we go to 102. Do you really want this big of a table? Whew. Oh, wait. There we go. We need to do this. Sorry, I reversed it. Here, let me slow down here. If you guys can't tell, I love this stuff. I love coding functions. I love making this stuff up as we go. And let's take a look at what we've done right here. So what I wanted to show you guys, and let's slow it down, is I wanted to show you some conditional writing right here. I wanted to put in a bunch of ifs and give him possibilities. Now, one thing I didn't like about this is I'd prefer it to look like this when he runs the output. I'm very particular about how things look, so I wanted to have that space right there. So now it says enter yes or no, and it has the, waiting right here. So if he says, no, I don't want that big of an output, it says, woof, no output. And now if he runs this and he says yes, it creates all the output right here. And that probably puts in our congratulations message. We'll look at all that output right there. Oh, we didn't do the advanced times table. But this right here, if you could code something like this, you understand the chapter very well. Who here kind of was following along as I did these conditional statements right here? And I'll explain what readline done as we did this. Please ask questions if you're stuck. We're going to go back to the notes here in a second. But this example right here that we just built is the essence of building functions. So I hope maybe that's a good thing right there. You did? Yep. If you understood this, then you really understand the essence of building functions and how we're just putting layers. Nice job right there. I'm glad to hear that. What readline does, readline is one of my favorite things that we don't have in the notes very much, is readline literally prompts you with a statement. So readline just enters in a prompt like hello, and then it'll just print to the screen hello, and you can then enter something after hello. So the point of a readline is you then enter something in after it, and then it stores that element. So you usually say something like, how many pizzas should we order? And then you would put a question mark right there in a space. And then it would say like that, how many pizzas? I want to make like choose your own adventures with this. That's been one of my goals, is to make a choose your own adventure type thing where it's like, you do this and do you go down the path? Yes, we go down the path. And you can store this like storage right here. You can store whatever someone says in the read line. So if you go right here, now it has the S in there. Does that make sense? Read line prints a message to the screen and then asks the user for an input, and then whatever the user inputs is then stored. So you can capture, like you can ask someone to enter something in. So whenever you want like a message to appear and then someone to make a choice, like, or to put an input, like you could, we could literally do this. Watch this. We could go here and remove selection, and we could remove end, and we could go here and we could say, watch this, read line, and we could say read line, what number do you want a times table for? And then we go there, we put our special character, and we're going to put this stored as selection. And then we're just going to copy paste for the moment. And then we're going to go here to, what was it called? End. And then we're going to say, what number do you want it to go to? So now, when Tolliver runs this, it's going to ask him, we're going to remove these inputs. It's going to say, what number do you want a times table for? He wants a times table for 5. What number do you want it to go to? He wants it, I want it to go 2. That's the wrong 2. He wants it to go to 6. So up, wait a minute. Do you want a times table this big? Uh-oh. Yes, I do. Oh no, we've done something wrong. This is why you can't break your code. So end is stored, I think I know what it is. As dot numeric. I've done this before. I've had these issues. We're going to store the read line. I think read line stores as a character. By default, whatever you put into read line is seen as a character. So we don't want it to store it as a character. We want it to take it as a numeric. And this is why you have to be very careful when you're editing inside your functions. 5, 6, there we go. So that's the issue. Up, and then we get some weird output, which I don't like at the end. Something weird happened here. So this is where you have to be very careful. Once again, we got our 5 through 6 times table, and then we're getting something else. I don't know if that's because of the global environment. Return, cat, paste, selection, and output. There might be something in the global environment right now stored that is hindering us. And let me remove the global environment. Let me rerun the table. Let me rerun this. I want 5. I want 6. Output is not existing. And yeah, so we broke it. We broke our function. Return. And then output should be made. Cat paste selection output. Selection through I. We broke it. We broke it. We broke it. We broke it. We're going to go back in time right here. We'll make sure we don't break it now. That's what happens when you start editing a function inside of it. You don't want to do that. Like I did the #1 rule of don't edit functions this way, and look at what happened. Even I. And now let's see. Yep. Do you really want a time table this big? Yes, I do. Error output not found. Oh, you know why? Oh my gosh, I'm such a fool. Because output needs to exist right there, and I think that should do it. Do you really want a time table this big? There we go. That was it. When it said it couldn't find output, so literally inside of the function itself, we had to create a space for output. So I just went to the start of my function, and debugging stuff on the fly can be tough. But notice how we ran into a problem. We just went full circle to why do we create this? Because I was getting an error saying output does not exist. It said, I don't have any place to store this. So when you look at the error we got, it's saying output does not exist. There's no, I can't create this because there's no output. So why couldn't it print this thing for me? Because it was never storing to it. And so once again, you want to create your functions from scratch. I kind of went a little off the rails there and started editing inside of it, and then you cause problems. But once again, this is the fun of creating a function. You'll hit so many problems. You'll be like, okay, wait, I just broke this. And probably what we did with creating our inputs would work now. It was just that I didn't create the output, and that was the issue. And it looks to be creating everything well. So that's got it. Let's go to the notes right here. So that was a big example right there, once again, of how to create a function. And we did a lot of conditional. I wanted to stress multiple conditional type arguments that we can use, like the if. If you notice, I wasn't using an if and an else because every time, if the if was not met, what did I want it to do? Just think about this theoretically. If the if was not met, what did I want it to do? I said, if this is true, do this. And then if it wasn't true, what would it do? It would just what? Do what? Because how was I using my ifs? I was like, if it is true, do this. And then, well, there was no else. There was no else, so what did it do? And the else will run when it's false. But if it was true, I just didn't want, there you go, Sarah got it, 20 points exactly, and everyone answering 20 points. I just I didn't want to do anything. So if it was true, do this. And if it was not true, it would go to the next if. Exactly. And that's and if it was false, it would still go to the next if. But if it was true, it would do certain things. So if you look at the code, I know I just went to the screen. If you look at the code right here, if selection is greater than or equal to 11, it'll print this to the screen. If it's not, it just won't do anything. You know what I could do is I could go over here and I could say else, and I could say, I think we can, here, we'll just cat it to the screen. Keep up the good work. So now if he enters in a lower number, now the else will run. So you see it says keep up the good work. And do you really want this big of a table? Yes. So you see it says keep up the good work. But if he enters in a bigger number here, it'll say, great job, you've made it to advanced tables. So now we have the else initiating. If you notice the difference between what I have here is that the if runs when he enters in a small number that is like 1 through 10, and then we could even do negative numbers and stuff like that. Be like, ooh, you're in negative numbers. But we could, you know, put messages from me to him right here, which is kind of cool. Like, you know, I don't know. You'd probably get bored with this quickly. You'd be like, what is this telling me? And I'm like, it's all the times tables. Look at it. Whoa, it tells you everything. And I could make like a guessing game or something like that. Like, what is this? What is this? And he could get points. I don't know. So I want to make a video game of it. I mean, this is, I just think, does anyone remember Math Blasters? Someone's got to remember Math Blasters. Man, I love that game. That's how I know math. So let's hop back to the slides right here. And really the number one way to make functions is to practice making them. Like, I can't tell you, like, the first time I started making functions, it was just horrible. Like, everything broke. But you can see here we have examples of the trim mean, and you can see that there are a total of how many inputs for the trimmed mean. How many inputs? How many inputs does the trim mean have? How many inputs does the trimmed mean have? How many arguments does it have? 20 points. Who knows how many arguments the trimmed mean has? How many arguments does the trimmed mean have? How many arguments does the trim mean have? No one's said it yet. 2. Just 2. Always look for these commas right here, and that's what separates out each argument. So there's 2. Great job. Everyone 20 points answering right there. It's just 2 arguments. But you might be able to argue it's 1 because there's only 1 required. Why is there only 1 required argument right here? And I'd love to do written test questions like this where it says, like, why is there only 1 required argument? Why is there only 1 required argument? These are things you should know like this once you know it. You're like, oh, there's only 1 required argument because why? Why is there only 1 required argument right here? Why is there only 1 required? Why, when we run this, do we only have to enter in one thing? We only have to enter in a vector x, and then we don't have to enter in anything else. So x is required, but why? N has a default. Jordan, you're right. 20 points again. That n has a default as seen right here. So we don't have to enter in anything. It'll take 10% off the length of x, and it'll use that as a default value for n. So we don't have to enter in n. It'll run without, we can enter in just a vector x. So we could literally just take this function right here, and we could just input a vector. Got lots of great notes today. The notes from yesterday are posted. So remember, even if is that the end of our function? Oh, good. That's the end of our function. I was like, when did the function end? We go right here. We drop the trimmed mean in. And did I miss part of the notes? Oh, all I missed was this. All I missed was the end of it. Wait. Mean temp. Okay. We can write that. There we go. And then we'll end the function. Please note that you can see where it highlights. You need to make sure when you go into function world, you end function world. So what's going to go on right here? We're going to put in our x, and then we're going to put in our n, and then it's going to take 10% times the length of x. So if this has like 10 values, this will be 10% of 10, which will be 1. So then immediately it goes here, and it takes whatever n is, and it rounds it. So let's say we put a length of 12 here, then this would be 1.2 times 10, and we are changing this right here. So n equals, so that's how many values we're going to trim off. And it's by default, it's a 10% trim. So you see right here, this will round it. Then this will sort the vector. So now we're going to take our x and sort it. Then we're going to go right here and out lower. We're going to take 1 through n. So that's how many lower values we'll take off. Out upper, this figures out the sequence. And what this will do is this creates the highest numbers to the lowest numbers. So it's going to create the highest number in our vector to the lowest number of positions. It's finding the positions, going from the highest position and then going down -1 by that many positions, that amount we're trimming off. This is the amount we're trimming off. So as everyone's to understand that if I put in a vector of length 12, what will this be right here? If I put in a vector of length 12, what will go into here? If I put in a vector of length 12, what will go there? What will be assigned to that right there? It'll go from what? If I put in a vector of length 12, what will go right there for this part of the code? 12, 20 points right there. And then it's going to go down by -1 each time, and it'll do it of length n. So n is how much we want to trim off. So it's going to go from like 12 to 11 to 10 if we're trimming off like 2 values. So if we want to trim off 2 values, like n is how many values we want to trim off the vector. Like trimming a vector means to take off the sides of it. So we're going to say like, okay, go to the highest position and then go down by position numbers and go down this many position numbers. So that's what it's saying right here. Start at the highest position, go down positions, and go down this many positions. That's the length of how many positions we're going down. Just think of it as the code's telling you what it's going to do. And this is the out upper. How many will be out of the upper part of the vector, and then how many are out of the lower? It's harder to do the out upper. Would it go down by 10%? By default, yes, by default, we're trimming out 10%. We can choose how many we want to trim out, though. We can choose how many we want to trim out. So now when you look at this, we're just returning the vector, and I really like how this concatenate works right here, because sometimes I forget the format on the minus concatenate, because you don't put the minuses on these, you concatenate it, and then you minus out the concatenated. That format gets me every once in a while. It just like makes me tear up. Just said something in my eye. So we are saying these are the things we don't want. So the vector x will be returned everything but these elements. So when you think about these are the positions inside of x, and we're removing out, and we're making this temporary vector here. We're just calling it like temporary storage. Like you could call it trimmed vector. Probably that might be better, and we'll put dots right here a lot of times for spaces or underscores. And so that might be a better, like the mean of the trimmed vector, just to make sense. It's like temp just means temporary storage, but it might make more sense. We talk about naming conventions, use good naming conventions. This is probably better, so we can improve the code. Now we run it, and then we go here, we make a vector. Like if we go to, let's just go here, vector, and we go here, vector of 1. And the reason you use trimmed is if you have extreme values. So if you see with this, we've got the 23s in here. So if you do a mean of vector, it's going to give you 5. And here we'll put in, there we go. And that gives you 8.8. So if we do the trimmed mean, which we call trim mean, now when we do trim mean and we put in vector, it's going to give us this instead. So if you notice the difference between the mean and the trimmed mean, we're seeing a vast difference between the two. Now you could say, trim off 8 values, and that trims off 8 values off of both sides. So on both sides of the vector, you're trimming off 8 values. But probably what's going to happen here, watch this. Yes. Now we get into a big thing today. What did I do? Why did this return not a number? NaN is not a number. That's what that stands for. It's like that the NaN is not a number is because it means that. So what happened here? Why did this break for 100 points? Why did this break? Because what did I do to both sides? I trimmed too much. Nice job right there. I trimmed too much. So what we want to do is we want to create something right here. We want to create something called length. And we want to create just the length of x. So when we run this, it's going to find what the length of x is. And then we want to go here, and let's do this. Let's do half length. And let's go to half length. So that's half the length. So if n is greater than half length, then stop. There's stop. And we'll put right here, you entered in, you trimmed too much. Okay, this is a big thing for today. This like covers almost the rest of the notes. Okay, there we go. Do you know when you get those error messages in R and you're like, what does this mean? Imagine if someone took a little bit more time to put something in that made more sense to you. What I just did is I created a custom error message right here, and I told the person you trimmed too much. So we could remove this. We could trim like 2 objects off, and it works perfectly fine. But as soon as you go to something that is more than half the length, because you're cutting from both sides. Now these are not sorted, but you go from this way to this way. When should one use a trim mean? What's the purpose? Trim mean is used when we have outliers. So not saying trim mean is like the best thing ever, but trim mean is used as a mean that is not influenced by outliers as much. So trimmed means are used when there are outliers, because if you notice right here, this 999, when you sort the vector, it'll get trimmed off. So you've got this vector like this, and you trim from the outsides. It's a sorted vector, though. Does that make sense, Sarah? Sarah, amazing question. Sarah, you're 200 today. Keep asking those questions, though, because I like, well, when would we ever use trimmed mean? It's when you have you have extreme values, you have outliers, and you use a trimmed mean to remove extreme values. Yeah, those are the big questions. Like, well, when will we ever use trim mean? When you have outliers and extreme values, we trim off the outsides to be like, okay, this is a trimmed mean. And people would understand that there's, yep, boom, Madeline, 100 points right there. Great answers in the chat. That's, yeah. And like, well, when we use this? And right here, we put in a custom error message, but we could change this to, I believe it's just warning, right? Should be warning. Yeah. And now if we change it to warning, you'll see right here, we still get the output. So let's talk about the differences right here between warning and stop. Okay, this is a huge note. When we do stop, it'll literally stop the code and end the function. You need this note. Stop stops the code and ends the function and returns the error message. So if this is inside of a stop, I'll make it look like that. If it's inside of a stop, it'll literally stop the code and it ends right there. It's like return. So you don't need to put a stop return, because stop will stop the function. And that's what the point of it is. It's like to say error, stop, can't do this, not happening. Stop stops the code, nin, 100 points right there. Those are the notes you need. Stop stops the code and returns whatever message you put inside it. You could put nothing, but it's going to say error in such and such something, and then it's going to tell you. So this is every time you get an error message where it says error, it's stopping the code. Your code stopped right there, and then it's like, can't do it. Here's why. And hopefully someone put a good message like you trimmed too much. Like, kind of makes sense. Like, the value of trim is too much. And then if you put in warning, what's the difference between stop and warning? Warning, let's go down to when we ran it with a warning. Warning prints out a warning message. Now, warning still runs the code. Great job right there, Carolyn. 20 points right there. Carolyn, well, 100, we're doing it. And Anisha, keep following along. You gotta be here in class. You gotta be following along. You gotta be like knowing what these do. Warning messages are just things that are printed to the screen to give you advice. So what's a warning? Warning is just basically like, hey, you trimmed off too much. Just telling you. But here's your output. Do you see? You still get the output. With the warning, you still get the answer, but you get the warning of like, hey, yep, a suggestion. Yeah, exactly. So it's more like a suggestion, like, hey, you trimmed too much. Just telling you. And then this one's like, you trimmed too much. We're not doing this. So this literally is like, stop. It's literally like the cop pulling you over and giving you a warning, or like, this is like not good. So it is what it sounds like. It's a warning right here. It's like, it's just telling you, just telling you. But you know what's interesting? Watch this. Check this right here. Suppress warnings. One of my favorite things ever. Suppress warnings. I think you can suppress errors. Can you suppress errors? You can't suppress errors. And then there's messages right there, which will suppress messages people print to the screen. So you can suppress the warnings, which will make the warnings not appear. So if you ever have code that's printing out a bunch of warnings, you can always wrap that code in as suppress warnings if you don't want the warnings to appear. Now, warnings are there for a reason, but maybe you just don't want it to appear in your output. So very, very, very important here. We are halfway through class, and we've already gotten so much code done. We had a very productive day today. There's the trim mean, logistic curve, stop. So let me zoom back in. Are we on main zoom? We are on main zoom. So here's the stop right here. Very important that we understand what stop does. Once again, this is just a custom error message right here with the geometric mean, and it's just doing a conditional check if NA remove is not true and the sum of is.NA is greater than 0. And so think about what this is doing. It's seeing, did somebody choose NA remove equals true? So someone would have to say false right here. So if this is not true, so they said false, and then there are NAs, then it's going to say, cannot compute with missing values when NA remove equals false. So it's literally telling you, here's what's going on. And that's part of my issue too. Like, I just wish, I don't know, I wish it was the error messages were better. And that's what we try to do, like give good custom error messages. So stop, once again, stops the code 100%, no output. You don't get output when the code stops due to a stop. These are all theoretical questions I could ask on the test. Like and great job. A few people have been putting like the questions in potential test questions. I'm gonna try to use the Discord more. Thank you, Dennis, so much. But knowing what the theoretical things do, like what does stop do? Like stop will stop your code and go right to the return. Stop will stop your code and print out an error message. The second answer is true. It doesn't go to the return. It just stops your code. Like stop is used with return to get the end of your code. And you think, for someone who hasn't taken this class or who's not paying attention, sorry if you're not paying attention, but pay attention. Stop, I could write something like, stop is used to finish your code and to get a return. And so I'm kind of using words like return, but be careful, like it's not the return. Like return is what we use at the end of functions to return what we're looking for. Stop is used when there's an error and it prints out a custom error message. Does that make sense? Does everyone understand there? Like stop is bad. It means error. And then warning is like, something's going on here. Something's going on. Prevent division by 0. So here's a stop in the code right here. I like it right there. You guys are cracking me up. Oh, you guys are awesome in the chat. Here's our more error messages. Once again, messages and debugging. So we're almost done right here. And we'll start doing some homework and stuff here in a moment. Print and cat. I love the cat print. So you can see right here, just using cat and print. I think we're almost done with these slides. I'm just making sure we've covered everything important because we've seen a lot of these. Throws the phone across the room. 20 points, Madeline, Sarah. You guys crack me up. Examples, messages on air quality data, debugging functions, debugging by hand. Don't want to do that. Writing code in shortcuts. I'm seeing if there's anything else major. The best piece of advice for writing codes to do it in pieces. Yes. Outlining what you need to do. It often separates into discrete chunks and working through it little bit by little bits. So you do not ever want to write out all your code at once. And here's just more examples. I think we've done, I'm seeing if we've missed any big topics we might start working on. Write the body of the function working for a very specific case. Once again, please write your function to work on one thing. Don't write your function to work on everything. I might do one more example of doing that. But if you notice how I write it, I start to make mistakes. Step 2, generalize your specific example to work inside of a function. Put everything in the function form. Choose the names, choose the arguments. And literally, this is it right here. This is the examples. Aggregate and apply. Let's go to aggregate and apply because these are the last things. Okay. And then we'll start looking at the assignment right here. So aggregate is such a cool function. When we look at aggregate, what does aggregate do? Aggregate is going to take a y variable and an x variable and then do a certain function on all the y based on all the x. So where we used to use for loops, aggregate makes life so easy. It's such an amazing function. Watch this. We're going to go here. We'll go to library reg class, which everyone should have now. And we're going to go inside of here, and we're going to go to height, gender, and then we're going to go to data equals survey 10, which I think I already have. Nope, I closed that out. Data equals survey 10. I'll need to do it here for you guys too. And I know those are the variables inside of it. And I'm going to go here to fun equals mean. And guess what? There's the mean for males and females based on just gender. Watch this. Standard deviation. Watch this. Max. There you go. Anything you want. Min. You could even go right here and go to handedness. And now you have the min handedness based on male, female, and handedness, or the min height, I should say. You could go here to GPA and just change this instantly to GPA, and look at what you're doing. You can get the mean, you can get the median. Can we concatenate two functions? It's not going to like this. It's not going to do it. I need to look up how to do it if it doesn't do it. I wish I could do it. What day is the midterm? We're looking at Tuesday next week. We're looking at Tuesday next week. I'll update as we go. But this right here, so Tuesday next week is the proposed day for the midterm. We should, yeah, that looks excellent for Tuesday next week. And it'll be online. We'll review during the day. And I suggest taking it later in the day or like start a Wednesday. I'll put it over the course of like 30 hours or so. So the power of aggregate is amazing. You get the y variable analyzed by the function. So the y variable will be analyzed by the function, and then we do it over the different levels of the x's. So you could literally analyze median GPA by gender just like that. So aggregate is probably one of the most powerful functions we have. We'll be using it later on when we start looking at clusters, but you can easily aggregate over multiple things. So I think survey 11 has different variables which might be of interest to us. We've got all those ones right here, satisfied with weight. So, you know, so yeah, let's do that. Let's go here to attach survey 11, and then satisfied. It's not auto-completing it. Satisfied by weight. Satisfied by weight. XO. There goes gender. Survey 11. Oh, we want to reverse these. So it's XO2. Attach allows you to see the variables inside of a data frame. So that's what attach does right there. And median, What did we get? Oh, is there no median? Oh no, what happened? Satisfied with weight, gender, data survey 11. In default, oh, is there NAs? Oh, wow. So we gotta, I think because there's NAs, yeah. So because there's NAs, this gets really tricky right here. And what I'm going to have to do is do something. I'm so glad we did this because this shows you why you have to know how to code. Because now I'm going to have to go here. I'm going to have to call here, let's go and write custom mean. And custom mean is going to be a function. And the custom mean is going to be a function that simply inputs x. And it does mean of x where NA remove equals true. And now I've created a custom mean function. And, oh, what's it not liking? Oh, because I had the parentheses open. I was like, I thought I did it right. And now I'm missing one close parentheses. Oh, no. What is going on? Wow, today is not my day. Custom mean, NA remove equals true. And in mean, NA remove equals true. Argument is non-numeric or NA. And then what is going on with the data? Let me look at the data right here real quick. So much going on. And so that's still returning that. That's fine. We're just going to see what's going on with that. So let's do this right here. Let's go to summary of x2. No, I'm going to do satisfied by weight. And let's do survey 11. And so we have everybody's giving that. Gender. Males and females. Is that not numeric? Oh, I know why. Because it's not... Okay, I know why. Because I'm trying to do the mean... Oh my gosh. I'm trying to do the mean of a non-numeric thing. My gosh. Talk about one of the simplest mistakes we could make is we're trying to do the... You know what we want? We don't want satisfied with weight. We want to do like this right here. And then we want to go here to EX... Let's see right here, weight, and this should work. Now we should get, that should print out tail. There we go. So we see here males and females, wish they weighed less, wish they weighed more. It's pretty interesting to see where the lines are for like males and females and everything like that. So we're able to do this right here, and we probably didn't need our custom mean function, but the custom mean function is working. And the complexity of what I just did right here is really super helpful, because I created my own custom mean function that this custom mean right here, check this out, you ready? This is huge, because now if I have a vector, and my vector is the following. So here's my vector, and if I run the mean of this vector it gives me NA. But if I run custom mean, my custom mean function gives me the answer. Does everyone see what I've done here with my code? Let's look at the very important thing that Brian did, is I created my own custom mean function that simply takes whatever x is and runs the mean of x, but the mean of x, and I should probably put return around this, just makes more sense because that's what's going to return. But my custom mean function takes whatever x is and just runs x, but then does NA remove equals true. Who sees this, that my custom no NAs in the mean? Yep, so exactly. Vidrina, you got it. That is true right there. It's going to make sure that it does this and it can do it with the NAs. So it is 100% it right there. So that has it. This custom function right here is very valuable, and it really helped with the aggregate because I was working with the high school student who's doing the data, and we had to create custom functions for his aggregate. Literally ran into this problem where there was NAs. Why return? Because this is where I want my function to end. All my function's going to do is run the mean function, but remove NAs. So my function is literally just the mean function, but it returns the mean with NAs removed. So my custom mean function is NA remove equals true. And when you use aggregate, you can't actually go inside of the function you choose will just do that function on how you aggregate it. So I can't go mean. I've not found a way to be like NA remove equals true then. I don't think that'll work. It gets mad. Oh, did it do it? No, it didn't do it. So I've never found a way to edit that because you can't change what's inside the function. You can't be like mean of x comma this. It just gets mad. So you can't do that. You have to change the function because this just takes a function and then that runs right here. So this is the complex way we have to use stuff. This just takes a function right here, such as like standard deviation, and it'll find you whatever you want. So you can literally find, I think count will do it. No, count doesn't work. Is it length? That's awesome. That's what I wanted. I wanted to see how many individuals there were. So it gives me the length of that vector. Why does it just return the mean of values? So then it aggregates it. Great question right there. So it's giving me all the weights. But this is, when I did length right here, it's telling me how many are in each vector. So it creates a vector of just the females who want to weigh less, the females want to weigh less, or the males who want to weigh less. So it creates all these vectors right here of data, and it's doing length right now. If I want to do like median, it gives me the median values for all those groups. So it's a super quick way of doing things. It's like so quick. And what we could probably do is we could do something crazy right here. Is we could go right here and, whoops, not that crazy. If we call this tab 1, so we're going to call this table 1, and if we want to put like the mean and median together, we go right here and we call this, so we'll call tab 1 mean, and we'll do tab 2 median. So now we're going to do the mean and the median, and we've made two tables. Let's see here, tab 1. It might need to be a data frame though. How's it seeing these? Oh, it is seeing them as a data frame. So now what I'm going to do is I'm going to take all of tab 1 and then I'm going to row bind. Let's do row bind. No, wait, it's columns, 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 columns. C bind. So this goes back to something we talked about earlier. Tab 1, comma, tab 2. And that's graphical error. Okay, good, it did it. But I don't want all of tab 2. I only want tab 2, column 3. And there we go right there. If you notice, I can go here now, because maybe I'm making an output for somebody. I want someone to input some variables and then get output. And now we want to go here, call this maybe tab 3. I just call it tab 3 for like table 3. Now I want to go here to tab 3. I want to go here to names of tab 3. And names in tab 3, we're going to assign the names of gender and satisfied with weight. Satisfied with weight. And then here we're going to put in, this was the mean. Yeah, mean usually looks like that. And this is the median. And then we look at tab 3. And there we go right there. Now we've created some output that someone can use And just think about we could add more things to this. We could add the standard deviation, but we're creating a table of output for someone to use, and it's just computing all these values for us without us having to do like a for loop and doing it. But does everyone see the value of this right here? In my code, I've gone and reassigned the names of these. So we got the different names. I've row binded my tables, or column binded, because I had to think, I literally had to think in my head, I'd be like, okay, we're joining columns together like this, because we had the mean column and then we had the median column. Does this make sense how I'm using codes we've already learned, which is always my goal in class, to do things like binding columns together, all of table 1 with just column 3 of table 3. So when you go back to table 3 had this value right here. This could be table 1 or 2, but we're binding together just the third column right here. But I took the original ones. Does that all make sense? How are we doing on that? This right here is the goal, and this is, as you get better at coding, it just makes more and more sense. Hopefully, it's at least being like, I kind of get what's going on. I know I went over a lot right here, but each of these individual codes build into it. Yeah, Anisha, I think it's super cool. It's like, how can we, redo this and make this better for people? And that's our goal, like to practice coding, to know what every code does. Like column binding is just going to bind columns together. And we have here that we're just reassigning the names of the columns in the data frame. So when I run this code, I'm just overwriting this names vector right here. And you just have to see it multiple times. You have to practice it multiple times. With that said, I think we have one more thing to do, and then we're going to start doing homeworks. The apply function. So the apply function, I haven't used it lately. Let me double check. So apply function uses on rows and columns. That's what it does. So apply function is either going to apply a function on the rows of a data frame or the columns of a data frame. So the first thing you enter in is your data frame. Then you enter in how you want it to apply it, and then you enter in the function you want it to apply. So you could have, like if you had a grade book, which do we have a grade book example? Imagine if, let's go here and let's make a data frame, and let's talk about how we would use apply. Oh, this is perfect. Okay, so we're going to do data.frame, and this is a grade book, and this is the perfect way to use apply. So we have here homework 1, and let's go here, and homework 1 will be, we'll use equals. Yeah, sure, why not? So this is your guys' first homework assignment. Sure, there was one better grade. We'll have 5 students. And then we'll go homework 2. I didn't put a comma after the concatenate. It's going to get mad at me because this is the next vector. And I usually assign the equals in here. Oh, wait, uh-oh. Sure, and then this, they did poorly again. Sure. And then this person right here. Let's talk about what we have going on right here. We'll put in one more homework. So I'm creating a data frame right here. This is good practice here, just knowing how to create a data frame of values. And we're just going to create, what's going on, people? And here we go right here. Okay, so when we create this data frame, look at what we get. Very important to see this is a data frame. Let's just store it as data frame. And then let's talk about using the apply function. So rows is 1s, columns is 2. So 100-point question. I would love to put this on the test. Keep reminding me, people, because I would write this. Tell me, should be fun. There's fun, good. Tell me what this will find right here. Tell me, there are 5 students in the class. There were 3 assignments. Tell me what this code will find. I wish we could do written responses. I wish I could just say, what is the apply function finding right here? Like you should be able to identify and understand in words what the apply function is finding. Close. Ahmed, so close. Ahmed, and I'll show you. That would be this right here, unless I'm wrong. And I can be wrong every once in a while. So really close. Everyone's getting 100 points for guessing. Anisha, you got it. Anisha got it. It is going to do here it's going to do the mean of each of the rows. So explain to me what that means in words when we find the mean of this, the mean of this, the mean of this, the mean of this, the mean of this. What is that in words? Like if you explain to your boss, which is something how we phrase things a lot in this class, like what is the point of this? Like what is the point of this right here? Because right now it's rows because it's 1. How do you know if it's rows or columns? Rows is 1, columns is 2. So it's 1, so it's the mean of the rows. But what does this mean? What is the mean of the rows? What is this like in logical wording? Like what does it mean to find the mean of the rows right here? Remember, it's homework assignments and it's students. Average of each student. Yeah, Hannah, 100 points, Hannah. Great job. Jumped in right there and you're like, yes. There we go. And so this is the mean for each student. Just look right here. You see the 93. The 93 was this student right here. You see the 88.66. That's this student right here. But I could change this, and now I've got the mean for each homework assignment. Just think about how quick this is. What if you want the median for those? Well, boom. There you go. You just want that. You want the standard deviation? Boom, you got them right there. It's just like that. It's that quick. That's what code does. It's like, here, let me get the means for each of these. Let me get the means for all the assignments. Let me store these. Like, what was the mean for all the assignments? What was the median for all the assignments? What was the standard deviation for all the students? There's the standard deviations for all the students. You can see student 5 had the least variability in them, and you can see student 5 had very little variability. We could change it so student 5 has no variability, and now student 5 has no variability. They got 89s on all the assignments. So student 5, just so we can see it on the same screen, student 5 here has 0 variability. There's no variability in their grades. So it's so cool. It's so quick. 100 points right there. I like it because the whole point of coding is to make things easier and quicker. So when you look at this data frame, you have to ask, do you want to analyze the homeworks, which would be 2 because that's columns, or do you want to analyze the students, which would be 1? And you have to watch out because you can't, I made this data frame because you can't do the mean if there's like different like numeric or categorical. If you want to do the mean of something, everything has to be quantitative. But you can do this. Can we do a summary of the columns? Could we? Which is the same thing as, of course we can. Of course we can. Oh, and it does it like this? What was that? Oh, that was a summary of each student. Whoa. So this is a summary of each student, I think, right? Yeah, student 1, here's student 1's min, Q1, median, Q3, and max, and all this good stuff. There's the mean. So student 2, student 3, student 4, and here's student 5 with no variability. So we can get a summary of every student, or you could get a summary of every assignment, just like that. There's a summary of every assignment, just like that. Pretty nice output, too. It's very similar to if you did a summary of the data frame, you'll get it like this, which maybe do you like this output better or this output? I kind of like this output better. It's a little more concise, and I like how it doesn't repeat because it knows, the min is just going across right here. So there is similar code a lot of times, but summary won't let us do it on each student. It only lets us do it for the variables, but we can change that and we can get each student. So this is student 1, student 2, 3, student 4, student 5. So the amount of analysis you can do instantaneously, it's like, here, let me create a summary output for each student. And what's even better is you could code this so that you could, call student 5. Can we call student 5? This should be, it should be this. So that should only call student 5 right here. So if you wanted to create, you could create a form email to student. You could think about what you could do with this if you're an educator. I should start doing this. It would work. I know, July's the month where I should start doing things. But I could create alerts in my gradebook to where, if a student has this, every week I should download my gradebook. Tell Brian to remember to do this. Every week I should download my gradebook, and if there is this alert, it'll send this email, and it'll be like, form emails are, they're blech though. It should be like, hi, so-and-so, I just saw that you have a grade of such and such, and all I'm doing is just grabbing, from this, I'll grab, you achieved a grade of such and such. I can literally put in the grade by, choosing things. I could choose their minimum grade. I see currently your average grade in the class is this. So we could go to our bad student right here, which was student number, which was it? Student number 2 is our student who's yeah. Hello, student so-and-so, I see you have an average grade of this, so I could report this in the thing, because all I have to do is say, we'll grab this code right here, and I'll go down here, and I'll go cat, paste, wrong paste, and I could say, hello, and then you'd insert name, so we'd go name, hello, Brian, and that's the name, so we go hello, and then we say, Brian, and then we say, we put a period, and then we say, I see you have an average of, and then, we could do, so we can store this apply right here as a value outside of here, so we don't have to put it in here. We could say value, and then we store that right there, and then we go here and we say value. And it should like this. Oh, we didn't close it off. Hello, Brian. I see you have an average of this. And then we're going to change one last thing here to make it look all pretty. And we're going to go this. We're going to put that. And then we're going to go sep equals, because sep is the argument for the separation. What's going on? Oh, cat paste. Uh-oh. What did I do? What did Brian do? Where's my sep? Comma, comma. I see you have a. Oh, huh. Just there. Wasn't giving me the autocomplete. Sep equals nothing. And we got the graphical error. Hello, Brian. There we go. Hello, Brian. I see you an average of this. So there we go right there. This right here is how you want to use code to your advantage, because if the code can look into the gradebook for me, and also I could have it send me an analysis. So maybe I don't automate the email. I have it send me an analysis of this where it says maybe I could put in the name of the students. I could put in like just this week, student has an average of. So I could have it. Doing. Think about this. I can have my code email me every week, and I really should start doing things like this, because there's so many companies that want to sell us stuff as educators. But if we build our own products and if we build our own like code that will analyze stuff for us, this is maybe one of my goals I should do in July, is like create code that scrapes my gradebook, which connecting to Canvas can be pretty interesting to scrape from Canvas. I think one of the people in the class, I need to post their scraping code, but it's awesome. But if I scrape my Canvas gradebook and then I have it analyze grades and I have it say like, this student is falling behind, this student is like doing excellent, and figure out what's going on, that would really help me, because then I can get a constant update on how my students are doing. You, Jordan, yes, exactly. And with that, you have to like, because of the two-factor login, that's what makes scraping on things like Canvas really hard, because it has to like connect in. So Kenny was dealing with two-factor login with scraping. And so, if I can scrape my Canvas gradebook, get the grades every week, or I could set up like a thing that scrapes it every night, and I could just look at grades, and I could create plots of every student. Oh my gosh. Like I could go through and just create output and like look at plots, or I could have it show me the plots of students who are like changing a good bit. Like this student recently dropped down and didn't do the last 2 assignments. It'd be so easy to like look at that and be like, oh, hey, I just noticed that you did this. And I could then personalize emails. Like maybe I don't do form emails, but I like personalize emails, because I only need to email so many amounts of students. But these are the things I think about as an educator, like how can I use coding to my advantage? And I can automate. Like I usually look through the gradebook and try to find people who are falling behind, but why not automate that? I'll just code what I look for. I look for students who stop doing assignments. I look for when there's a shift in their grade. So if a student's doing good and then all of a sudden their grades go down, well, maybe they were like getting high A's and they go to high C's, which that's not horrible, but maybe I'll say like, hey, I noticed you were doing pretty well here, and then your grades dropped a little bit, and I'll code something to be like, this student had a drop in their grades. They had an average of this, and they dropped to this. So Jordan, we should post that. We'll be posting Jordan's web scraping stuff, and Ahmed has amazing stuff too. Like both of you, so many people in this class are being like, hey, Brian, I'm using this right now even, which is awesome. Okay, so that does it for the lecture. Yeah, and I think because you said I could post it, so thank you very much. As long as thumbs up on posting it, Jordan, I think we're good on posting it, right? I'm 99% certain. Unless you're like, no. I think we figured out what apply does. We understand apply pretty well. So, Sir Ken, awesome. So you can check out Jordan's web scraping. I'll post that there. Okay, so let's go to the assignment, and let's finish up today by talking about the assignment. So this is assignment 3. Who has questions on the assignment? Who has questions? We did part of it yesterday. I don't know if it's in the video. I don't know what parts of the video posted. Q3, D, Q4. Okay, we got some stuff. Adam is ready to go. Let's do it, Adam. Adam, 100 points right there. Throwing out the big 100 points today for 200 points max extra credit. We're going to try to get everyone to some crazy extra credit by the end of the class. Okay. Define in range. We got this right here. We got Adam and Sarah's got questions. Remember, we will head office hours right after this. I'm playing some Mega Man. Just get us pumped here as we start going. 3C. So we got before that. Now Nintendo's going to come after me. Nintendo, don't take down this video. We've had no problem with playing a little Mega Man, because people play video games on YouTube. So we can play Mega Man. Maybe we got to switch to that. When we play random, it might just be Mega Man now or something. Okay. Now, oh no, but we need to do 3B. Okay, we need to do... Okay, I think we have to start with 3 to get to do it. Okay. So, consider the churn data set. What, Adam? That's insane. Yeah, it's back in the day. Nintendo was more like you had to have like you had to be like in the Nintendo like what's going on. It's just like I'm just playing a video game. I'm promoting your, I'm not trying to. I am. Yeah, it's who knows. The churn data set is about people leaving their cell phone carrier. We've got churn, which is yes, no on them leaving their cell phone carrier. For now, we're going to study the values of total international calls column. The goal is to define each element of the matrix in range. The value in the lower and the upper in range, lower and upper, will give the number of values in the total international calls column that are between the lower and the upper interval. For example, in range 6 through 9 would equal to 1126, since 1126 are total call columns are at least 6, but no greater than 9. Okay. Since such analysis could be useful if we want to discretization, the values of total calls into a smart set of characters, low, medium, high, by finding the shortest containing the values, the intervals containing 50% of the observed values. The goal is to write a nested for loop to define each element of the in range by one by one. Let's build the code slowly, play around with the test code, find the number of elements that are in at least 3 in most. Initialize counts to be a vector. Okay, cool. So we need the counts. And we need this right here. And initialize counts using a for loop. You are going to store the ith element of the counts, the number of values in the total calls. There are at least 3, but no greater than I. But let's get the code working on a specific test case first. Yeah, and that's just loading it in. So define count 7 to be the number of elements. Nintendo's greedy. So define count 7 to be the number of elements in total calls between 3 and 7. Okay, so this is a check right here. So now we want to look at, so here's what we need to do before we get count 7, total international calls, and we need to go to churn. Okay, so this right here, if we take a look at it, so now we want to figure it out. How am I going to, like, what things am I going to use? Just like I'm doing like this right here. What am I going to use for numbers between 3 and 7 inclusive? Like I want number of calls between 3 and 7, but inclusive of these numbers of calls. So numbers between 3 and 7, but inclusive of those numbers. What shall we do? 3 through 7, but inclusive. You got it. Greater than or equal to 3. And we want, and then we're just going to copy this right here because we don't want to write things. We want to copy them. And less than or equal to 7. And so we run this. Now what do we want to wrap this inside of? Yep. And so this will give us trues and falses. Now, but what's the quickest way? 100 points, quickest way for me to figure out how many there are. Quickest way. Length, there's a way you can do that. 100 points, quickest way though. You can do length and which. Sum, yes. There we go. And you could do, you could go here and go length, which, and do that. So it's just quicker to do sum because you can, and then mean will tell you the percent. So we don't want the mean, which there's a lot of them. We want the sum of them, which will add them all up. Yeah, you can use length, which it's all right. Like we're just seeing the differences between the code right here. And this is just how we practice and how we learn. The quickest way is with sum because it'll just add up all the trues. It'll tell you how many trues there are, which will tell you the positions of the trues. And now since you know just the positions of the trues, you can find out how many positions there are of the trues. So length, which tells you the positions of the trues. Length tells you how long the positions vector is. Does that make sense how length which works? Because it gives you the positions of the trues. And then you just ask, well, how many true positions are there? So sum just literally treats the trues and falses as 1s and 0s. So it adds up all the trues. And when you do this, you'll just be adding up all the trues, which is the same as how many true positions are there. So this code reads, find the things that meet these conditions, find their positions, and then how long is that positions vector. This code reads, find the things that meet these conditions, and then add up how many things meet these conditions. So a little bit different reading of the codes because this one tells you the positions, and then this one tells you the length of the positions vector, which is how many positions are there that meet the condition. So same thing, same code, good stuff. Don't need them all. Quickest way is this way right here. You'll see the first 6 element are NA, have yet been defined. The 7th is, print counts to the screen. Oh yeah, okay, yeah. Yeah, makes sense. So since we're now storing into this, it'll store to position 7, and position 1 through 6 have nothing in them because and we had to create counts to start. Here we can remove counts real quick. I think it'll get mad if we do this, like when we try to store to it. So if we try to write to counts right now, it'll say counts not found, but we can easily just remake counts as we did above, and then we can store to it. So that's That's why we have to create counts. We have to create counts because it needs a spot to store the counts to. And then when we store to position 7, and just so you can see, I'll show again. When we store to position 7, it's going to, let me run everything above, currently counts has nothing in it. It's going to create positions 1 through 6 now, and where counts had nothing in it, it creates positions 1 through 6, but there's nothing in positions 1 through 6. So it puts a position 7 in there, but positions 1 through 6 have nothing in them because there's nothing. There was nothing in this to start, and then when we write to position 7, does that make sense to everybody? Let's get some thumbs up or yeses in the chat right here. How are we doing? Does it make sense that we wrote to position 7, but position 7 had nothing in it? It's like, yeah. And so we're doing pretty well on this. We're doing pretty well. Got it. Now that you have your code working for the test case, write a for loop with the upper that goes through the integer sequence 1 through 20. Put the counts in the upper, the number of the elements and total calls that are between 3 and the upper inclusive. Print to the screen there were counts sanity checks provided. The first 2 elements are 0 because it's impossible for a number to be at least 3 but less than or equal to 1. So now that the inner loop is working, it's time to write the outer for loop code. So this code right here is our for loop skeleton. So we got the skeleton. Thank you so much. 20 points in the chat for following along. This is our for loop skeleton, and the only thing we need to change here is the number we're using. So this can become I right here, and this can become I, and whoop, not you. It's not you. And then this becomes I, and then it said 1 through 20. And that should do it. That should. There we go. I think it's got it. Yep. And so all we did was change. Remember, we wrote our skeleton, which was the whole goal of that previous line of code, was to write the skeleton. And then we put our placeholder in there for what has to change. And what has to change, let's look at the code. What has to change about the code is 7, because we're not always going to store to position 7. And that's augmented by the end of it right here. So the end of it will be where we, store into. We're going to say, okay, 3 through 7. And I think there's nothing in international calls that is below 3. The min's 0. So, but you can't do 3 through this. But we're going to change the outer loop right here. So if you notice, the outer loop is going to control this number right here. That's what the outer loop is going to control. That number right there, which I'm guessing the next part of this is to create the outer loop. So define the in range to be a matrix. Okay, so you're going to give me the matrix right here. I don't like matrices. I don't deal with matrices. And so we got right here the in range. So there's our matrix. And now we're going to have to store 2 positions of this matrix. So this is where it gets a little bit confusing right here, is we're going to store 2 positions of this matrix right here. And we need to think about how to do this. We need to create our nested loop now. So we're going to go right here, and we're going to take our for loop and put our for loop inside of a for loop. So here's our for loop inside of a for loop. Now, what should 3 become? What should 3 become? Any ideas what 3 should become? What should 3 become? Any votes for 3? It could become lower. Yeah, and maybe it tells you to do that. Maybe I should do that. Lower, probably says that. Is it 2? It's just, yeah. I think it says to call it lower. I like calling things shorter names. Okay, we're gonna go down 1 font size. It's too small. Too small, or can you guys read it still? Too small or too? That needs to be upper. Because I'm gonna call this upper. Is this too small, everyone? And this needs to be lower. Too small. It's fine. Better. Okay. Yeah, because I want you to see it all on one screen at one time. And right here we have the lower is going to go from this. The upper is going to go from this to this. Now this is where the change has to occur. We've already created our in-range object. And this is where the change has to occur. So right here is where we're storing it. And we're storing it into the lower and the upper. So whenever this runs, it'll store to position like 1, 1 the first time. It'll do, because this is row, so it'll do row 1, column 2, and it'll be a symmetric matrix. Is it symmetric? Oh, because we didn't print out, yeah, that's not going to be symmetric because it's not, yeah. This matrix is symmetric, but what we printed here is not a symmetric part of the matrix. And so that should do it. That's graphical error. Dang you, graphical error. Stop it. One of these days we'll learn how to make that go away. One of these days. Oh no! What happened? Okay. We broke it. We broke it. Well, that's what happens when you do your code sometimes. In range, lower, upper. We'll see what happened right here. How'd I break it? In range. We created the in range. There's a bunch of zeros. Lower. Make sure these are spelled right. Upper. And what happened? Okay, let's grab this and let's run it outside the for loop. And let's see what happened here. Okay. So when the for loop runs, it's going to run the first time with 1, 1, and it should get zeros for those. You know what? In range might have worked. No, because we did the sanity check. It didn't work, obviously. And this should store into here 1, 1. You know what we should do? We should do 3 and 7 and see what it gets. So here's this. Wait, that's getting a value. Okay, why did that value not store? Okay, that did store. Okay. So that did store. Mine worked with that code. Yeah. Okay, why is my code not working? Let's try it again. You know, sometimes I say to people, just try it again, and they're like, oh, it worked now. And I'm like, yeah, that's not how it... You know, R just trolls me sometimes. R just trolls me. Did I not run the loop, maybe? Is that what I did? Did I not run the loop? Did I think I did that. I think I didn't run my loop. Yeah, I never ran the loop. There's where I ran that loop. And then I didn't run the loop. I coded the loop. I didn't run it. I was like, I don't understand why this code wouldn't work. And then I pulled it out of the loop to see what's wrong with it. And it worked. I mean, because then I ran the loop. What I did was, if you look right here, I made the matrix and then I checked the matrix. I never ran my for loop. So once I went down, that's me checking the full matrix. Yes, I like that right there. And then here's me running the loop. And then it's stored to all the values. We get the sanity check. We're all good. And optional 1 point extra credit if you get it. But we want you to figure out how to do this on your own. So I don't think I'm going to help on this one. No help on 3E. This is your extra credit right here. Find the shortest integer. The values is shorter than... So we want to figure out how to do this on your own. No TA help. Can't help you out. Find the shortest interval. Like 9 through 3 is the shortest interval containing 10 through 15 because through your values that contain at least 50% of the values in total calls. If there is a tie for the shortest interval, choose one that contains closest to exactly 50% of the values. So what you're trying to do right here is see an interval that contains 50% of the values. And when you look at your matrix, let's look at the matrix real quick right here. It's a pretty big matrix, or it's called in range, right? When you look at this, you want to figure out like this right here, and we're getting zeros right here because it can't do it in the reverse order, so it's not a symmetric matrix. What's wrong with that? This is from like 1 to 9, 2 through 10. What you want is, like, if you were to go 1 through 20, then that's all the values. It says 4,000. Why is there not there's an extra value? Let me get the summary on this. Churn total international calls. Oh, did we not do 0? Is that why? Did we do 1? Oh, we didn't include 0. I think that's it. Yeah, we didn't include 0. We should have included 0 because now... Oh, that's interesting. Does it say include 0? Mixtures of all zeros. Yeah, so if you want to do this, you have to go here and you have to do this. Don't do this. Don't do this. Don't do this. Now the sanity check won't hit, but we do see that we have 0. And what I was concerned about, I'm concerned about that. What is going on? Oh, because lower, upper 0 through 21. Oh, then that needs to be 21. No, 0 through 20. Number of rows, number of columns. And that's weird. On 3D, can you explain how to print 3-column pairs that have the number 6? 3D, did we just do 3D? Let me revert this back before I start breaking it. I did the question, and I went off on another tangent. Wait. On 3D, can you explain how to print out the 3-column rows pairs that have number 6? Oh, right here. So print out the 3-row column pairs that have the number 6. Okay. So where are we looking for? So we're looking for ones that have 6 right here. So we're looking for this, and there should be a few others. There we go. Here's another one, and here's another one. We just found them. Okay, there they are. They're printed. No, don't do that. Okay. So great question, Caroline, right there. Thank you. 20 points, Caroline. These are office hours points, so you can add these on. It's the end of class right now. How would we find if something in the in range is equal to 6? Remember, I might not do everything. Oh, yes. I think Andrew totally, and here, wait. Well, yeah, deleted Andrew. Andrew, thank you so much. I'm copy pasting. He's going to delete. Okay, I got it. Go ahead, delete it. So we want which, and let's look at Andrew's code right here. Great job, Andrew. No, Andrew, excellent work. And so let's look at what's going on right here. If you don't do, like, you would probably think to do this right here. So the difference between these two things are very subtle, is that we're going to look at in range and we're going to find the values that are equal to 6. If you do this right here, it'll go through each column, and the first, like, well, let's look at the very first value in a column. Do you see how this is 265? So we should get returned to us 1 right here. And you see 1. And then in the second column is 1008, so we should get 21 and 22 because it did 21 things, and that was the 22nd thing it did because I think so. And so that's the 22nd kind of thing. Is that right? It was 21. Okay. Oh, because I still have my. Yeah, let me delete my. Sorry, I've still got the error from before. Delete. Let me rerun everything. Because I was like, it should be 21. And let's run this. And there's 21. Good. It's 21 because it's the very start of the column. Of course, the output's going to look crazy. There we go. It's the very start of this column right here. But here's the issue. You don't want, is array index. I always get this one wrong. Array index equals true. Now, this is going to return the row and the column. So what should this return right here when it tells us where in range things have values of 1008? What will this return to us? The position with array index equals true. Without array index equals true, it says 21 because you go all the way down here, and this is the 21st index because it does all of these. Then it gets to the next one. That's the 21st. Then it would do all of these, and that's the 41st. So it'll turn the row and the column. Yep. So it's going to say 1, 2. And just so we can see visually what's going on right here, it tells us the index in the matrix of where it is. So the which returns back to us positions of where things are at. So this returns back to us the position, the row columns. If you don't do array index, it's going to say 21 because it's the 21st thing. And it does it by columns. It goes column 1, then it does column 2, and it just does like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 21, 22, blah, 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 blah. And so does that make sense what the which is doing right here? And with array index equals true, it turns it to an array like rows and columns. So instead of doing like all the columns here, all the columns here. Yep. You just have to know the subtle differences. And these are things that took me a while to learn. Like, when do we use array index? Is when we have a matrix, is we use array index. So, and then instead of it returning, going through all the columns and being like, because you could test like the last ones down here. You could do 1, but there's probably multiple things equal to 1. So that's the last one. We go here, 1. And you see, oh, it is in the last one. So if you don't do array index, this is 20 by 20. So 20 times 20 is 400. So you get 400, right? Yep. And just understanding, those are good theoretical questions. Like, how did I know that would be 400? Because it's the very last observation. And I could check the second to last, which is 3. So I should see in here 399 somewhere. Oh, it is. That's the only one. You could check the 4. But it gets confusing if you have like, like 5. Oh, there's nothing to return. 7. There's 2 positions. But now if we do array index, we'll find out where they're in row 16, column 16, and row 18, column 20. So that right there is good information for you right there. Yeah, really good stuff. Really good, like, knowledge on how to use this. Excellent. And that kind of leads into the next one, because you can kind of do it with this sort of code. Man, it's like the more you learn on this. And what other? Let's go on. Was there questions on 4? I see 5A through B, and question 4. And so Adam wanted question 4. Let's go look at question 4 real quick. A leap year, one that has February 29th, occurs when the year is divisible by 4, except when the year is divisible by 4. There we go, like 2020 are all leap years. Except when the year is divisible by, so when it's divisible by 100, it's not a leap year. So 2000 was not a leap year. Put in here 2000. Don't forget the year 2000. In the year 2000. Unless the year is divisible by 400. In the year 2000. There we go. Thank you, Conan. So we have this right here. All of these right here are leap years. So when we code this in, we want to define a vector called leap years is initially empty. Boom. Do we know how to make this? I want to see the code in the chat. Make a vector that is initially empty but has, but we want that many elements. Or put whatever you want in it as long as that. Yep, Madeline, 20 points right there. That's office hours points. You can add that onto your, if you got your 200 today. There you go. So leap years, code in blank. You could do this or leap year. You could go rep NA and you could take that and we're going to copy paste these numbers. Don't ever try to write things. You could do that, Adam. Yeah. And here, let me explain. And Adam, don't worry. I'm going to explain why I maybe wouldn't do this. And this will work right here. And I'll explain why. So this does work. And the question literally says you can put whatever you want in it. And we don't need to concatenate it. It doesn't hurt to concatenate it, but since it's already a vector, you can just do it as that. Don't worry. This is like same thing. Like it's the same thing. It doesn't matter. It's literally like same thing happened. The reason I would maybe do this one is this creates a blank space. The reason I'd maybe do this one, this creates all the blank space spots we want. I'd be wary on this one though, because it puts numbers in there. So I think we're doing trues or falses, right? Probably one of the best ways as I think through this is to maybe go here and go and do this. This is probably one of the best ways I could think of right now. Like if we were to be very serious coders. So now leap year is a logic. Oh, it puts all falses in there. That's interesting. So when you do a logical vector of length this, it creates a completely false vector. And this, I'm between this way and this way is the best way to code it. But literally any of these ways work. But if I'm going to be making a logical object, I might put a logical vector with this many spots, and it just kind of puts falses in to start. All of these ways are 100%. Don't change your assignment if you've already put in one of these ways. Like it's perfectly fine. So I think I know the spirit of this one. I think I know it pretty well. Is that we are trying to just figure out if things are leap years. So it just walks you through how to do it right here, and it gives you examples. So when we go down here and we're going to check if something is a leap year, we need to do these kinds of logical checks right here. We also have the logical check, is it divisible by 400? So the last logical check would be, is it divisible by 400? So we're going to have here 3 separate checks. So let's go right here and do our first check. If, oh, you know what, Adam? Adam, I stand corrected. I kind of like, I really like what Adam wrote, and I'm going to do the following. I'm going to go here and I'm going to make years. I'm going to make a vector of years. I like what Adam wrote because we're going to need these numbers, and I'm going to do this. So there's the years. Does that make sense? So we have right here the years, and we're going to do this right here. And so I have my years stored. So if, there's a few ways to do this. Should we do this? What do you want to do this? We're going to probably do this the 2 ways here. Do you guys want to do this with a for loop and an if? I need at least 5 votes for one of them. First one needs to get 5 votes wins. For loop with an if or if else's. For loop with an if or if else. For loop with if or if else. 5 votes. First one with 5 votes wins. We need 5 votes. We got for loop. We got if else. We got for. We got 3 4s. So we need at least 2 more votes for one or 4 more votes for another. We need more votes. If else, for loop times. It's really close. Next vote wins it. Next vote wins it. If else. Okay, people want to do if else just won it. Maybe I'll do the for loop with an if too. If else. So if else takes the vector itself. So if years is %%, which means divisible by 4. Then we're going to say yes. And then, well, let me just think here. If it's divisible by 4, I'm just like double checking my work right here, because then, but we need to go inside the yes because there might be. So we might need to do this. If it's not divisible by 4, if it's not divisible by 4, then it's automatically a no. Like anything that's not divisible by 4 is a no. Does that make sense? Anything that is not divisible by 4 is a no. And does everyone see how I flipped this? Because when we check the years right here, these are all the years that are not divisible by 4. So if it's not divisible by 4, no. Just instantaneously no. Does that make sense? And then are we storing trues or false or yes or no's? I can't remember. Okay, we're doing yeses and no's. Good. But does everyone understand the code I've written right here? Like, if it's not divisible by 4, it's 100% not a leap year. Like, boom, we've decided this. Now we're going to go inside of here. If, and we've already written everything we need basically, if it is, and we got to be careful here. Here's our if we're inside of. So now, is it doing that? I think you might be right. Let me see. It might literally be checking. Oh my gosh. Do you know what these years are? The years where the trues are might literally be, no, wait, 1, 2, 3, 4. So it is doing that. Does it know that nowadays? Let's double check. Thank you so much. I do agree. That looks like it would have been an error. Yes. Oh my gosh. Who said that? Adam, you're getting 200 office hour points. Adam, that was a huge error because we're checking to see if the amount is 0. And you see, these are all the ones. Yeah, this makes a lot more sense because year 1 is not a leap year. Year 2 is not a leap year. Year is not a leap year. Year 4 might be. Adam, amazing correction. I make errors. That would have definitely been an error. And we would have been looking back on that and saying, what's wrong? But it makes sense that year 1, it's true that it's not a leap year. Year 2, it's true that it's not a leap year. Year 3, it's true that it's not a leap year. Year 4 will be a leap year. But now we're going to say if else, and we need to copy our code right here. So we're just going to copy this. And now we're going to see if it's divisible by 100. No, not that. We're going to see if the years is divisible by 100. So if the years is not divisible by 100, actually, you know what? If the years is divisible by 100, and then you have to be careful with your parentheses. Cool. If the years is divisible by 100, then it'll be no. And then I think we have it. And then we need to go here. And then we're going to take this line of code right here. And we're just going to copy it. And if the years is divisible by 400, it'll be no. And else it'll be yes. And I think that did it. I think that's got it. And so I think we've now done it. Because look, this one is divisible by 100. That's why it said no right there. We could go to 600 or 800. We'll go to 800. 800 is going to be right here. Do you see how, does everyone see the pattern? What is the point of the exclamation points? Oh, yes. So exclamation points literally flip if you have like 2 equals 2, which is true. It literally flips this to a false. So it just means not that. So if you put an exclamation point, it flips it. So if I want to see if something is divisible by 4, I would do this. Like the years, the remainder of years when we divide by 4 is equal to 0. So this tells me whether it's equal to 0. And then what I want to do is not equal to 0. I just put an exclamation point around it. And it's like the remainder of 4 is not equal to 0. Now, I guess you know what I could have done? That. Could have done that right there. That should work the same way. Now it's the years when we divide by 4, the remainder of it is not equal to 0. So if you want to put your exclamation point there, that's a little bit easier. And that's the not equals inside of it rather than flipping the whole thing on the outside. But the exclamation point just flips your trues and falses. Whatever is false becomes true. Whatever is true becomes false. It changes the world. But does that all make sense? I think we just did it. Oops. I want you guys to have a lot of help here, and I want you guys to ask all the questions because I think sometimes seeing it and working through it makes more sense. Yep. And you got to like practice it. You have to think what it means, and you have to be able to read it and be like, how do we build this? You know, we're going to do the for loop example here just for fun. We need to go here, and we need to just do the first case to practice writing a for loop. Does that need to be stored into a vector? Yep. Yep. Wow, great job right there. We're just going to go here to leap years. Great job. 100 points right there. Boom. Boom. And there we go right there. And probably what we want to do is we want to go leap years. Leap years? And then we want to go factor there, and then there. And then, yep, there it is right there. And you could do a summary of it now. And we should check it also. So we've got the check right here. It's called leap year. We'll call it leap years, sure. And so it should, yep, no. Uh-oh. Something's going on right here. Dun, dun, dun. Brian's got a problem. Problem looks to be with the, it stopped, it did the 100, the 400 is having a problem. So if, I probably just need to flip these. If it is divisible by 400 is equal to 0, then we will store in there no. And it only makes into this when it's divisible, if it's divisible by 400, if the remainder of one is divisible by 400, that's not going to be right if I flip these. So if it's not divisible by 4, then it's no. If it's divisible by 100, it's no. If it's divisible by 400, then it should be no. I just want to run it the other way just to see. Let me check the sanity check again. Okay, something's happening with the... Because the 1000 is correct, this is correct, but the 1200 is wrong. And years divisible by 400. Oh, they are leap years? Oh, so it should... Yeah, and it should be that. Okay, wait. Okay, so it should be... Okay, so wait. So if it is divisible by 400... Okay, wait. So here's the problem right here. So you're saying... You know what we need to do first then? Okay, I see it. Is we need to go right here. It's the ordering of this. Thank you very much. 400 are leap years. So my code is doing what it should do, but we don't want it to do that. Okay, we have to start recoding it here. Whoops, made an error. We're going to go right here and grab this one, and we're going to put this here. And if years is divisible by 400, yes. And if not, then we go into the 100. Sorry about that error right there. Go into the 100, and then no, yes, and I think this should do it. So notice the key difference right here. That should fix that error. Now we go down to the sanity check. Now we run it. There we go. Okay. So what we did right here is now we have it first check. Is it divisible by 4? And if it's not divisible by 4, it'll say no. So this first one says, is it not divisible by 4? And then if it's divisible by 400, we automatically say yes, because every 400 years is a leap year. Like the year 2000 was a leap year because it was divisible by 2000, because it was divisible by 400. So 2000 would be a leap year because it's divisible by 400. So that needs to automatically be a yes. And then we go down to here, but if it's divisible by 100, so it only enters into this if it doesn't meet this condition right here. Like things that are divisible by 400 will automatically be labeled yes at this point. Like we don't actually get to this point down here with them. Only the things that are like 100, 200, 300, 500, 600, 700, 800, not 800, 900 would go into this portion of the loop right here. So things that are either not divisible by 4 or things that are not divisible by 400. We've already evaluated those things. So we're only passing through the things that are not divisible by 4 and the things that are not divisible by 400. Because if something is not divisible by 4, or actually, I stand corrected, what passes through here is 4, 8, 12, 16, all the multiples of 4. And then what passes through here is all the multiples of 4 except the numbers that are divisible by 400. And then when we get down to here, we're only evaluating numbers like 4, 8, blah, 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 blah. And then we're not evaluating 400, 800, 1200. Those got stopped out in this step right here. And so when you run this, it only looks at numbers like 4, 8, 12, 100. So if it's divisible by 100, it'll say no. And then if it's not divisible by 100, like 4, 8, 12, it'll say yes. So this is actually where the leap years are created. We create some leap years here, but this is where the majority of the leap years are created. Does that make sense how the code works and how it's passing things through? What passes through in this step is 4, 8, 12, every multiple of 4. What passes through in this step is every multiple of 4 that is not a multiple of 400, which is basically everything. And then in the final assignment right here, where most of the leap years are assigned, is we assigned no if it's like 100, 200, 300, 500, 600, 700, 900. We've already dealt with the 400s here. And then we assign all the yeses right here. So hopefully no one uses that code. That code was slightly out of order. And that's why we have sanity checks, because even I make mistakes. But just making sure you do it in the right order, because you need to pass through each thing as it goes. How's everyone doing on that right there? That's why sanity checks exist. That's why sanity checks exist. So we got that one. We're going to do it. With the for loop is a lot less fun. Yeah, 320. Yeah, Emily, ask away. Let's do a 320 question. We haven't done one in a while. Emily, ask away. Let me pull up 320 assignment while you ask it, Emily. You're more than welcome to. Thank you, Emily, for hopping in and asking a question. I want everyone to know that, especially during office hours here, this is just our time to ask questions. Say, hey, Brian, I have a question. So let me go to assignments. Let me pull up assignment 3 for 320. Associations. Here we go. Summer 2020. Emily, what is your question? I'm confused on how to interpret it. 3A through 3C, and then we'll hop back here. If it's divisible by 4, it means leap year. Do we need to use... I mean, as long as it works. Jordan, as long as it works, and tell me if it's working or not, and you can post your code here if it's not working. 3A through 3C. Let's take a look at that one, Emily. 3A through 3C. I might need to pull up the book for this. Oh, no. Okay, I got to pull up the helper book. Let me go to the modules. Module time. Let me go to homework packet. Let's broadcast the book. Dr. Petrie hits us with a copyright claim. He says, you broadcasted the homework package. And I say, I'm sorry. Update successful? Why didn't it update? Okay, now my computer is pausing on this. Don't crash, computer. Ooh. Screen. Okay, good. There we go. Okay, page 70-something. 70. Oh, we're close because the homework packets are shorter. Page 70. Wait. What? Am I going mad? Page 71. Okay, I thought it said 76. Page 71. Page 71, exercise 3. So exercise 3 right here. I got it. Okay, cool. Okay. So this is I love this question. It's an excellent question. Let's talk about it right here, and let's see how everyone's doing. So with this question right here, we got to bring back up the notes. Where'd they go? Here we go. There we go. Okay. Do we need to knit the sanity checks, or can we remove them? You can remove them. Please tell me if you get points off for removing sanity checks. They shouldn't. The graders shouldn't take off. Please look at your grades. Always be, like being like, did I get the right grade? Always say, hey, Brian, I think I got too many points off. If you think you did, I'm always open to, hey, can you take a look at this? Just ask nicely. Be like, hey, Brian, can you look at this and tell me why I got points off? Perfectly fine. So consider the bicycles from the kiosk in this side-by-side box plot. What about this plot suggests there may be an association? So let me ask you this, Emily. Which day has the most demand? And sorry, I'm blocking it. Which day had the highest demand? Was it Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday? Which day had the highest demand? Which day had the highest demand? Which day had the highest demands? Saturday, you're right. Yeah, look at that. It's right up here. So Saturday had the highest demanded. And then notice how Monday has less variation in it. Monday also has a lower median. If we look at the median for Monday, now they're all pretty similar. It's kind of not moving around too much. But it's like Saturday is a little bit higher than Mondays. Mondays look to be some of the lowest demand. So when you look at this right here, we actually see different medians. And what does this mean? And we see different mins right here. Does knowing the day of the week give you some information about what the demand will be? Like if you know the day of the week, does it maybe give you a little bit of like information about the demand? Like I'm not saying it tells you everything, but maybe it's like Saturday has some of the highest values and the median's a little bit higher. Monday has one of the lower medians. Yeah, it's not a lot of information, but we do see differences. They're not perfectly flat. So if they were perfectly flat, then we'd be like, well, there's really no information because knowing day of the week would tell you absolutely nothing. There seems to be like a smaller association here. Like the association doesn't seem to be too strong, but the fact that they're more separated away from each other. And you know what? I think I hate to move homework assignments because we just covered this today. So I think I need to send an announcement and say, hey, just a reminder, I'm going to move this to Wednesday because I saw like this right here. So it's because the medians differ and the maxes differ. And so I think, but notice how you see how this is different right here. So knowing what day is the week it is would give you information about what the demand is. So knowing what day of the week it is would give you information about the demand, such as Saturday has a higher median and has a greater range and a greater highest value. So we see right here that we get information about what day, like what the demand is based on the day of the week. So if we know the day of the week, that gives us information about the demand. Does that make sense, Emily, right there? That if we know the day of the week, that gives us information about how much demand there would be, such as Saturday has a slightly higher median, has a higher maximum value, has a lower minimum value, and that right there. So that's really good. Let's do B right here. So the F statistic, once again, this is definitely, I wanted to get all through this today, but I don't want to rush. So I need to send out an email here in just a little bit and just say, hey, I am doing office hours later and we are moving the assignment. So come to office hours, let's talk through the assignment. I am going to move it because I don't want to rush you guys and gals. So because we didn't talk about the F statistic today. I thought we'd get through it, but we didn't. It's all right. The F statistic has been calculated. It turns out to be 4.7. So the F statistic, which you don't need to. So what is this right here? What would this ratio be? What would this ratio be? It would be what? What would that ratio be? Because the F is just going to be a ratio of the two numbers of the observed of the expected. This ratio right here would be there's silence. Oh no. 50 divided by 10. 20 points, whoever gets it. What would this ratio be? It'd be 5. Nice job, Emily, right there. It'd be 5. So, oh no, that's all right. 5, Andrew, right there, 20 points also. So when you think about this, what does the F ratio tell us? It tells us how much bigger. Oh, really? That's so weird. Hopefully everyone's fine. Was it us, maybe? Hate to think it was like our YouTube. So weird. So when you look at the F ratio right here, what's going on with the F ratio? It's a ratio of how much larger the observed differences were based on what we expected. So the ratio of the F is the observed discrepancy we have compared to what we would expect via random chance. What is a typical F value for us to see? What kind of F value would we expect? What F value would we expect? Maybe some 474s know this. What F value would we generally expect due to random chance? The F values we would generally expect due to random chance are probably close to what? The F values we would expect due to random chance are probably close to what? I'm giving a hint with this right here. Like if we observe what we expect to see, what would the F be? Yep. And because in this instance, you observed what you expected to see. Does that make sense? Like up top here goes what you observe. So if you observe what you expect to see, then you get an F of 1. Does that make sense? Like an F of 1 is saying, well, we observed what we expected to see. Like the value we observed was the same. It wasn't any bigger. So if you were to observe something like 10 times this right here, you would get an F of 10 because now your observed value is 10 times larger than what you expected to see. And that's just the observed, but it would be down here like if you observed getting paid $100. And just think about this. You know, if you expect to get paid $10, do you think it's likely by random chance that you would get paid $100? Like if you expect to get paid $10 an hour and you get paid $100 an hour, do you think that's likely by random chance? Where we could do a different example where you get paid $11 and you expect to get paid $10, that would have an F ratio of 1.1. So you'd say maybe it was just like random chance, like maybe it's just variation, like maybe they just paid me a little bit more. So yep. So this one over here is likely by random chance. This one over here is unlikely by random chance. So the larger the F, like what is the most likely thing? If you expect to get paid $10, the most likely thing would be to get paid $10, and that would be an F of 1. So if you expect to get paid $10, the most likely thing would be to get paid $10. And we can see less variation, less discrepancies, but it's like the discrepancy. Now, it's not an actual amount that we're viewing, but what does this F ratio then mean for us in this assignment? The F ratio for us in the assignment right here is telling us the discrepancies between the medians were 4.7 times larger than we would have expected due to random chance. And that's kind of large, like 4.7 times larger, and we'll view it right here. If you're watching this video, I will let you snip this out. Greater. Please don't say everyone cheated, but watch this. Do you see how this F ratio is 4.7? This goes right to what we worked on today. What am I going to put? You should draw it yourself. Don't snip. I don't know. Now I said you can do it. I don't know. What am I going to draw at 4.7 like we get in our output? What will I draw at 4.7? What will I draw at 4.7 since this is our output right here? Like these are all, you can look from the review notes from today, and it'll literally give you the answer. I hate that it does that. Is it this one? No. There it is. This is the answer. Do you see how this right here is almost exactly what we had from today? Like look at the red line will be drawn in where our result is, and then the histogram right there are the permutations that happen by random chance. So all I'm going to do to see where my p-value is at is I'm going to go to 4.7 and draw in a red line right there at 4.7. And then I'm going to shade the area to the right of this, which is nothing. And what's my p-value? This is a constant review question from today. What's my p-value? Who knows what the p-value is for this test? What is the p-value? Good review question. What is the p-value? 0. Great job, Grant and Mila. Yep. Good to have you guys here. 320 in the house. We're all hanging out. So the p-value is 0, telling us that this result we observed here is very unlikely by random chance. And I'm going to move tonight's assignment. That way, you know, we can make sure we talk about a little bit more tomorrow. And do we have 3D? Did I cover all these yet? Why you do that? So is the demand observed statistically significant? Is this statistically significant? Is this difference right here statistically significant, yes or no? I mean, we just estimated the p-value. So is that difference statistically? Do you know what time you'll be doing office hours? I think 4. I think let's try to do 4 as long as it's kind of a tentative type thing. I think we'll try to do 4 for office hours. So I think that'll be good. We'll try to do 4. 4 should work, hopefully. Fingers crossed. Fingers crossed, 4. We'll try to do like 4 p.m. office hours. Lets me take a break. Lets me relax a bit, get some lunch. We go out. Hey, everyone's still here. I love it. So makes sense that this is statistically significant right here. It's very much statistically significant because the observed result was very unlikely due to random chance because there were no results as extreme or more extreme than our observed result. And that's at 4.7 is where the F statistic was at. And then let's go back here and look at why does it do that? I want to go to this. Management only cares whether the demand differs by 1,000. And you know what's really cool? Watch this. What we can do is we can actually use a code from 474 today to help us do this. So watch this. I think this is the EX. We need to go here to library, reg class, and we need to go to data EX6 bike, EX5 bike. This should be it. So does it have weekday in it? Weather, working day, day. It's got it. So 474. What function will Brian use to find the median for every day? 100 points, 474. What function will Brian use to find the median for every day? One of the last 2 functions we used in class today. Give you 20 points for a guess. And what function will I use? Let me build it real quick. I'm going to build the function, but not write the name of it real quick. So I'm going to go here to, I want to know the demand. Close, Jordan. So close, Jordan. So close. Could I? There might be a way to do it with that. There might be a way. I want to do the demand based on the day for the data equals EX5 bike. Very close. It's not apply. Fun equals, yep, that's it. 100 points, Jordan. You got it. So we can go, I'm going to copy paste from Jordan. Boop, boop. And that should do it. There we go. And there's the median for every day. As we can see, Saturday had the highest median and Monday had one of the lowest. So using a command from 474 today, we can actually get all the medians. So while you might be able to, it's going to do it, it did it. While you can visually inspect this, like you can visually inspect this and be like, that does not look to be a difference of 1,000, because the difference in 1,000 is this. Like I don't see any of the box plots differing by that amount, but some people will be like, is it? I don't know. It's hard to say. It's because they're not lined up so well, like they're not in order. You can go right to here. Saturday is at 4,903 and Monday's at the lowest. We could probably sort this. I've never tried this on this. It doesn't like that. Probably we'd want to store as data frame. But we should be able to... Oh, it's because it's a data frame. So you got to go here to data frame. And then... Does it have it? Data frame? Yep, it does. And then go here, data frame, and yeah, go here and order the rows by that. And there we go. So now we see the ordering of the rows from the lowest to the greatest. So this is once again using our order function. So it's always good to kind of know how to do these things, just practicing. I try to keep myself sharp by being like, can I create an order for this? And you could just as easily go data frame and go to demand and just do this, go to range of it. And there's the range of the data frame. And so there's the min and the max. So the range is like, what is it? 333. So max minus min. Can Brian do math in his head? 333. I think it's it. 333, there we go. So is it more than, is it at least 1,000? Nowhere near close. It's nowhere near close to 1,000. Not near it. And we just did a lot of work to basically say, no, the range is nowhere near 1,000. But it's kind of good to like know these things and know how to do the code, because the differences are from Monday and Saturday, and that's a difference of 333. It's nowhere near 1,000. So we can find this out mathematically right here with all of the code we wrote to just compute it. And it'll compute the exact differences between the medians. And if we want to do things like means or anything like that, we could easily just change to means. And so now we can see the differences. Ooh, means have a bigger range, but it's just that easy to change. You just change whatever you want. Cool. Other questions? I think that does 3 right there. And we got to throw in a little 474 practice. What other questions are there? Any more questions? Feel free to ask. I know 474 had a few more questions. Can you explain 5A and 5B? 474, you got it. So let's go right here, 5A and 5B. and 5B. And today's the 9th, huh? Imagine we start with n equals 531. Okay. So question, starting with the positive integer n, imagine forming a sequence of errors the following way. If n is even, if value is to true, divide it by 2. If n is odd, multiply it by 3 and add 1. Okay, so this is, I think is it. Emily, I'm glad that helped a lot. Awesome. So we just have what we do right here. If example, if n, okay, and then we have to loop it. Okay, so it only ends, divided by 2. If n is odd, a value is to false, multiply by 3 and add 1, and repeat. For example, if n starts out to be 5, odd, the next value is 16, followed by 8, followed by 4, then 2, then 1, then the series repeats 2, 4, 1 indefinitely. An open question in mathematics is whether eventually the sequence will always end repeating indefinitely regardless of the starting value of n. Exploiting the computation is easy. As of 2017, students made from the starting value of up to, wow, do eventually repeat, but accordance to top mathematicians, proving it does in general is extraordinarily difficult problem, completely out of reach of present-day mathematics. What? Did anyone ever figure this out? Because there's people who solve these things. There was a PhD candidate, and she recently solved one of these things. She recently solved one of these ridiculous problems right here. So I don't know if in recent times someone's actually, histogram of, oh my gosh. That's so cool. So cool. But people look into these amazing mathematics problems right here. And just the visualizations are really cool. I've seen so many cool things about all these different things. So looks like no one's still figured this out. So it's the way you can do it with code and represent it, it's just beautiful. What is this? Oh, so crazy. Man, someone might eventually figure it out. In popular culture, it's in a movie. A grad student explains the culture to a group of undergrads. She puts her studies on hold for a long time to address some unresolved questions about her family past. Late in the movie, the judge turns out to have foreshadowed disturbing. No, that's horrible. And people are still working on this. It looks like there's 2019 right here. Almost all Collat's orbits obtain almost bounded values. Cool. That's so cool. Man, I just love hearing about mathematics. Imagine we start with n equals 531. The next value of n is this. Then use a for loop to place into the elements of the vector n the values of the sequence. So make 100 elements. Hint, since we already have n equals 1, loop over positions 1, 2, and 3. Print to the screen head and tail once you're done. And sanity check is provided. Okay, so we're storing into n, and we know what position 1 of n is. It's so crazy because people have shown that this works to very high levels, but then why does it work? And will it eventually always work? So these codes this right here is very important. And then we need to know right here if n is equal to 2, then we are going to take n and divide it by 2. And we're going to store that into n. So, whoops, I hit that. So we're going to store n and divide it by 2. Okay. And that is what we do right here. So if n is divisible by 2, we'll run this code. Let's just try this. N is 10. If that is that, let's see what n is. N is now 5. Now n will not, oh, well, they did that again. And now if we run this, it won't change it. But we need the second code right here. The second code is if it's false, multiply it by 3 and add 1. Okay. So now we need to add a what. If you're following along and need you guys' help, I need to add a what here because if it is true to this and then something else, I'm going to do something else. What do I need to add to the end of this to make this work? To make it. Else, you got it. Boom. Where'd my thing go? Else, run the code. And remember, these are code brackets. We're going to overwrite what n is with n multiplied by 3 plus 1, right? So we multiply by 3. N multiplied by 3 plus 1. And I'm going to do my famous parentheses tricks. Okay. So now, when I run this, I should be able to run it now, and it makes 16. Now we get 8. Now we'll get 4. Now we'll get 2. Now we'll get 1. And once you hit 1, that's pretty much, it's got to create a repeating sequence after this because, and I don't know if all of them will hit 1, but once you hit 1, everything has to follow the same pattern. It's just eventually going to run into numbers that everything will hit, and it's just going to make this repeating sequence here because now it's stuck in a loop on that. But you could pick a crazy big number, like something like that, and then just check out how this works. And it's just kind of cool because eventually this is going to get to a repeating thing. I don't know how long it'll take, but we could do this, highlight the code, and just keep running this. And up, it's getting low. Whoa, it's so crazy. Up, it's down low. There it goes. So if you looked, it finally got to this repeating sequence here, and that was starting with a crazy big number. You can just take any big number you want. You can just take this number right here, start with that number, and run your code repeatedly. What's it sound like I need? What's it sound like I need right here to do this? Instead of me just doing this right here by doing this, what do I need? You guys know what I need. You know it. You know it. There it goes. It's done it. It's done it. What do I need? What do I need instead of me doing that? What do I need? What do I need? So this right here, what I've accomplished by doing this and then doing this a whole bunch. What do I need instead of just doing this like this. Like I'm being ridiculous right now on purpose. I need something. Jordan, you're right. For loop, for loop, for loop. I'm just running a for loop by not running it. We're going to go here, store this into position 1, and that will just store into the first position of n. So we already know what position 1 is. Now we need to go here and think about how this becomes a for loop. Well, we only need this right here. So we're going to go to for loop. We're going to put this inside of here, and then the variable that will change will be, I guess it'll be, the variable that will change is going to be the placeholder position we're storing in. So this needs to be I, and I will run it 100 times or 99 times. We'll run it, we'll get 100 sequences of this value. And so now we're going to go here, and we are going to store into n position I, and we will take, yes, and we'll take position n I minus 1, the one right before it. Or right here, we'll store into position I. Now, the important thing to do, and I'm going to take this out of the for loop for the moment, is to think about how this works. Because the first time the for loop runs, what is I equal to the first time the for loop runs? The first time this for loop runs, I is equal to what? What is I equal to the first time this for loop runs? What is I equal to the first time the for loop runs? The first time the for loop runs, I is equal to what? I is equal to what the first time the for loop runs on these lines? These are the big important key things right here. The first time the for loop runs, I is equal to what? Any ideas? First time the for loop runs, I is equal to what? I think, actually, you know what? This is a problem right here. This needs to be I position I minus 1. And this needs to evaluate... Yeah, that's correct. Okay, that's right now. I is equal to 2. I is equal to 2 the first time it runs. And so when you look at this, this is going to go to the first element of I. Does that make sense? This is the first element of I is divisible by this. Store into the second element, the first element of n, because it's I minus 1. The first element of n, which is what we have here, is going to evaluate that, and it's going to then store into position 2, and it's going to take what was in position 1, because this is 2 minus 1, and it's going to divide that by 2 if it was divisible by 2, and or else it's going to store into position 1, and it's mad about that. Cool. So all this right here is just going to take and store into position 2, and it's going to use what was in position 1. And it's evaluating what is in position 1 when it runs the code. Does that make sense, Jordan? It's evaluating what is in position 1. So it has to evaluate what is in position 1 to then store something into position 2 using what was in position 1. Let me highlight that as I say it. It's evaluating what was in position 1 the first time it runs, storing something into position 2 based on what was in position 1, the previous position. So we're going to store into position 2 some sort of mathematical equation based on position 1. Yes, you just have to look at each part of this. You have to think, why am I building this? You can't build it all at one time. And now I'm going to run the for loop outside of here. And you notice now we've stored into position 2. We'll view n after this each time. So there's position 2. The next time it runs, it becomes 3. There's position 3. The next time it runs, it becomes 4. And now we view n again, and we're just building this sequence right here every time it runs. So what I'm doing right here is this is the #1 way to make sure your for loop runs. To know your for loop runs, you can build it like this, and you're literally running your for loop by doing this. I'm literally just doing the iteration and creating it. So this right here is how I'll check for loops sometimes. I'll pull them out, and then I'll kind of like manually run the for loop by changing I, because it'll do it for me here. But here, I'm just manually changing I. And then I'm just viewing my vector afterwards to make sure it's running. Now that I have this right here, which I think we might have made one more change to it. We did. Now that I have this, let me re-indent my lines. Doop. Code, reformat lines. Oh, no, 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 no. Don't do that. Don't want that. Code, re-indent lines. Thank you very much. Now that we have this going right here, and it gave us a starting number, we can delete this workout that we did. And it gave us a starting number right here. And I like calling it position 1. We're going to do one thing real quick. We're going to remove n. And that's fine because I don't think we stored it previously, did we? It's fine. I'll overwrite it. So now we've just got n position 1. I guess we're fine. Just do that. Sure. And now that should do 100 positions of n. And let's take a look at the sanity check. Do we get it? We got it. Now here's the coolest thing, Jordan, is because what we can do with this is we can go here and plot it immediately. We can just go here to plot n, and we can get a plot of this showing us, oh, it's so cool. Just the way it jumps around. And we could change this right here to plot to like 200. And now we're going to see it's going to go to its pattern. That's when it peters out on the pattern right here and goes to like 1, 2, 1, 4, 1, 2, 1, 2, 4. But look, who would have thought it would jump back up? It's got kind of this flowy pattern right here. But what's even better is we should be able to, this is where it gets amazing. And of course, I like doing extra things in these. Let's go to function, and let's go and put this inside of here. And let's go to return. And here, we're going to allow somebody input n equals, and let's put 50. And we're going to call this the name of what the function is called. Call it here. Call it ccplot or something. There we go. And so now what we've done is if somebody calls this function, which is kind of cool, they should get the plot. See, there's the plot, and we could put the end. We could change the end right here. Let's go to end equals 50, and go here to end. And that should do it now. Okay, cool. And now, look at this. We've created a function which allows us to plot any number just by throwing it into a function here. So if we go here to like 500 and we say to 20, it's going to create a plot of the first 20 numbers. Now we can go further out to like 200 to see the plot of it. But here's a plot of 500. We could put in a ridiculous number. So there's a ridiculous number. And did this one actually do it? Whoa! This number right here so quickly went down, the speed at which this number went back down. And you could just enter in, will that work? Whoa, did it work? And it went down to 0. It went down, it did it. So you can look at these crazy numbers that by about 80, like who would have thought this number right here, this ridiculously long number, let's put a 1 at the end of it. That's going to maybe, it did it again. And let's just add more. I wonder if I want to break this up. It worked again. It worked again. And this one went even quicker. This one went even quicker. I don't know if it's because maybe I've got the 5-0 at the start of this. Let's change to a 7-0. And now this, yeah, it's, whoa, and look at how it bevies out. It got stuck. Maybe it's not down to 0 because the scale on these numbers are pretty crazy. But you look at how much it's like decreasing very quickly. Pretty interesting. And, you know, the amount of numbers we can handle right here. I don't know how, whoa, look at this. Sorry, I just find this so cool. We need to put this into like Plotly so we can view it better and like zoom in on this. But this number right here, this crazy, probably because they're repeating, probably because I did that. Let's throw some 8s, let's throw some 4s, let's throw 5s, let's make it not so random. 9 and 1, we want to break it. There's 29 warnings. Did it run? But did it run? That's all we care about. Did R finally say, nope, I can't handle this big of numbers? Eventually I'll break R. That's the way it goes. 29 warnings. It looks like it's not redoing the graphic anymore. So yeah, we broke it. That 22 warnings, 19 warnings. I think we have too big of a number in here now. 16 warnings, 12 warnings. There. Okay, now I think it's doing it. Maybe. It's mad. It's mad. It's too big. There we go. Now it's doing it. Really, that one looks like that? Yeah, that was that graphic. And yeah, so we're breaking it by entering in so big of numbers. But the fun nature of like we turned this into a function now, and you could make it so it only plots certain values. Like I could start the plot at different amounts and control where it plots. But pretty interesting this wavy pattern you get through it, where it kind of gets this like flutter, because when it's going up, it's doing a it's a constant pattern, but then it gets pulled down by half. So then it goes up in like this flutter pattern. So that's that going up, strikes down, going up, and then just getting pulled down. It's pretty cool. What other questions are there? Any more questions? We might take a break here for a bit. Got a lot of good work today done. I think, was there any other ones? But you don't have to put this into a function, but this helps with today's class, I think, to see it like as a function. So when you think about how can you put these things into functions, 5b? Yeah, let's take a look at 5b. Let's do it. Okay, is this the same thing right here? Clearly, it's going to take a while loop for the series to start. Oh, because we need to throw in a while. Use your rote in A as the basis for the while loop that continues to make new amounts until 1 is produced. Hint, okay. So what we want to do right here is we want to take the code we have right here, instead of doing a for loop. So what do we want to evaluate? So Jordan, I need your help with this. Think about the only element of n we need to evaluate to see if it's reached 1. What is the only element of n that we need to evaluate to see if it's reached 1? You know what? This will work way better in our function. What is the only element of n we need to evaluate to see if it's reached 1? The only element of n we need to evaluate to see if it's reached 1. There's a few ways. There's 2 ways I can think of. I just thought of one and then I thought of the other. What is the only element of n we need to evaluate to see if it's equal to 1? Any ideas? What is the only element of n we need to evaluate to see if it... Not the first. Very close. Like, not the first. I think I know you might be saying the one we just created, but that will go somewhere else. So not the last one. Boom. Yep, the last one. And we could also evaluate the minimum value. So you could check the minimum value because the lowest it can get is 1, or you could check the last value. So you can, as you're appending onto this, as you're writing more values, you can check the last value, or you can check the minimum value. And sure, why not? I'm being super nice today. I realize there's a lot of work. There's a lot of work in this class. It's the summer. I might not be this nice during the year. I might have to like take down these videos. People like, you did all the work in the summer with them. You explained how to do it. Like, summer's really fast. Summer is so quick. Summer, it's a lot of work. And I don't want people to be like, I can't do it. And I'm like, no, you can. You got this. Okay, what goes inside of here now? Since I'm doing a while loop, what goes inside of here? While loops always have a this inside of them. Like, a while loop must have a what. It's super mad at me right now. A while loop must have a what inside of there. A while loop must have a what. Everything with a while loop always has a this that it checks. Every while loop always has a this. A logical, yeah, but condition. So we're going to go while min of n is not equal to 1. And this should do it. That should do it, right? There. I think it. Let me remake my vector right here. Let's try this. N is 8. No. Well, min of n. The min of n is 8. Is this not equal to 1? This is true, right? Okay, wait. And then... Oh, do we have to use a for loop with a while loop? What's going on here? What's going on? What did I break? No, a while loop does a for loop. So while it is this, what did I do? Did I not run it like I did last time? Error. Missing value for true or false needed. So, okay, wait. N minus 1. Oh, okay, wait. Oh, okay. I got it. Okay, yeah. No, we need to store I outside of here. I know what's going on. I should read my error messages right. I equals 2. And then go here. This will do it. I equals I plus 1. There we go. Done. Yeah, is that 320 or 474, Alexa? Is it? I think it's 474, right? Is it 320 or 474? Which one is that right there? I do not know. 320? You got it. Let's go. We'll go back here to some 320. You got it. And look at that right there. Boom. Get it. Got it good. So, and then it wants us to do a certain number. Double check your certain numbers right here. But, yeah, there it even tells you how to do the I plus 1. Reading the error messages, double check and be like, why is it not working? But this double check, read everything, see what's going on. 531. So checking 531 right here. And then we go down here to the sanity check. And there we go. You're getting an error. Jordan, you might, if you post your code real quick, Jordan, then we'll hop over to Alexa's problem. Post your code real quick. Let me take a look at it and let's see what's happening. So just you might have to drop it in like 2 messages and then delete the messages afterwards. But if you want to drop it in the chat, we'll take a look at what's going on right here. And then we'll hop to Alexa's 1B, 2D. You got it. Thanks for swinging by, Alexa. We got this. We didn't show like 20 Tuesdays too much today. While min, what is going on? Let's drop it right here. Let's see. Okay, while min, okay, that's got that. if it is this, we're just going to make it look perfectly the same. Oh, and then, yeah, here's this. Did you store did you store I as 2 before outside your loop? Outside your loop, did you store I as 2? And I think that'll do it right there. Did you put I2 outside your loop? Because I needs to store as a value to start. It might say like I does not exist. Did you get an error saying like maybe I does not exist? Like if we don't have I stored here, you probably are getting the following error. Well, no, it might just, oh, did it? Oh, let me remove N. Move N, and then let me store, and then let's run this. And then, is it that error? You store it as 1? You need to store it as 2. Since you could do it as 1, but then you'd have to change how you have things assigned. Let me try storing I as 1 and see what error I get. Yeah, it can't evaluate that because when it goes, think about what it's putting in here. It's going to 1 to start, and it's doing 1 minus 1, so it's doing it's doing element 0. So we have to start I at 2, because the first time it runs, this will become 2, and this will go to position 1, and this will store into position 2, and this will go to 2 minus 1, which is 1, and this will store into 2 if it runs, and this will be 2 minus 1, which is 1. So you should store into I2, because the first time it runs, it's going to do, and you can see all these things appearing again. All of these things right here are going to be 2 minus 1, which is position 1 will be evaluated to see if it's divisible by 2. And did changing it to I stored into 2 work? Changing I stored into 2, did that work, Jordan? Hopefully it does. And then, yeah. Oh, you could do 1. Here, let's do that. If you do 1, then this is position 1. And this is position plus 1. This is position 1. This is position plus 1. This is position 1. So now if we're indexing this way, you could do this right here, and this should work just fine. Yep, there you go. Switched. So notice the difference on the indexing. Now we're storing into position 1. We're evaluating position 1, and then we're storing into position 2 because we're starting out with I equals 1. So when we run it this way, it now stores into position 2 right here because I is 1, so this is 2. And what are we storing into position 2? What was in position 1 divided by 2. And then, or else, if it's not even, we'll store into position 2, because this is I plus 1, we'll store into what was in position 1 times 3 plus 1, because that's position 1 right there, because I starts out as 1. So now we're indexing on 1 to start, and then 2 is I plus 1. So hopefully that makes sense there of how it's, like, you could use 1, you could use 2, you could use 10, but then that'd be weird. If you use 10, you don't want to do that. You'd have to use 10 right here, and no, you wouldn't. No, don't use 10. 10's ridiculous. You could use 1 or 2, either or, because as long as one of them's I, it makes a little bit of sense. So yeah, no, Jordan, great questions, and keep asking. And like, I know the gist. I've done these questions a lot of times. So, you know, like I do 201, 324, 74, and we change the questions a little bit every semester, every once in a while. And so I've done a lot of these questions a lot of times, so I know like how to do them, and then I might do them differently. So, but the answers still turn out the same because there's a billion ways to do things with code. What is up, Alexa? Questions on 1B. Let's take a look at 1B. 210 extras. I'm going to move this to tomorrow night, Alexa. I'm going to send out an announcement once I hop off online saying, hey, it's due tomorrow night. And everyone will be like, yay! My plan is not to move assignments, but it can happen. It's just the way it goes. And so let's take a look right here. We've got right here exercise 1. Exercise 1. Okay. So when we look at this right here, what we need to look at is we need to ask ourselves which of these explains which one. So I want you to think about what explains what right here. You can say it 2 ways. Number of open cashiers will explain how long your wait is in the grocery store, or how long you wait explains the number of open cashiers. If you're like managing a retail store, would you say the number of cashiers explains how long people wait, or the number or how long people wait explains the open cashiers? Which sounds better? Like always just think, which way would I say this? Like the number of open cashiers explains, that makes it the X variable, how long people wait, or how long people wait explains how many open cashiers there are, which makes more sense from like a business aspect to be like, this explains this. Yep, number of open cashiers explains how long people wait at your store. Yep, because the store probably wants to understand how long customers have to wait. The store doesn't want to understand. You might say, but don't they want to know how many cashiers they have open? They can kind of control that one. That is they want to understand why are people waiting longer in line. So when you look at things like weather and demand, especially from the aspect of a business, which of these makes more sense to say this explains this? Like from a business, this explains this makes more sense. Like this, what would explain, like, does the weather explain the demand or does the demand explain the weather? And people can be like, well, technically I could tell this from this. And it's like, well, yes, X explains Y and Y explains X. But usually there's one we want to understand and one we would use to explain it. So what makes more sense to say this would be what explains this if we put it into like an equation. Like, let's try to understand this by using this to explain it. And then what would be the explanatory variable right here? Weather explains, yep. So when you're like with a business, you'd say like weather explains demand. Like the weather outside today explains our demand. And you could say the demand is explained by the weather. Wait, that's the same thing, right? The demand, we can, weather, I just can't say the wrong one. It hurts to say it wrong ways. Weather explains demand. Demand explains weather. Okay. Yeah, demand explains weather sounds weird. It's like you want to understand the weather outside and the demand explains the weather. But think of it like a cause and effect thing. Like, it's not cause and effect. You can't say cause and effect. Like, you can't say, but it is kind of for this one. Like, if there's a huge storm, I worked in retail, and we had, like, they were so mad at us. I always remember this example when we talk about this question, because when I worked at a clothing store, they got mad at us for our sales were, like, 60% of what they were the previous year. They were like, your sales on Tuesday were way lower than the previous year. And I was like, well, there was, like, torrential downpour. There was like a severe thunderstorm warning all day. Like we had major downpours, and they're like, well, that doesn't matter. And I was like, we can't compete with last year's sales when today is like hazardous to go outside. So, you know, all these companies don't take that into account, and I wish they did, because they shouldn't say anything to us about Tuesday. They should be like, hey, Tuesday was pretty good considering you had, you know, torrential downpours. They should always like look at the variation that goes into it. And I wish I had that understanding at the time to say, we're not doing a high level multivariate analysis here, because the day of the year, also days of the year differ. Like maybe I don't know, maybe they look at it like the second Tuesday, because you'd have to take into account the day of the week, because you can't compare. Like last year was a Saturday and this year is a Tuesday. Well, of course, if you work at a clothing retailer, it's going to be higher sales on Saturday because everyone goes shopping on the weekends. Not everybody, but more commonly shopping is done on the weekend. So I think it's ridiculous. So I don't do that kind of stuff anymore. Yeah. Brian's past lives working in retail. Where is that question thing? So you wanted to do 2D. What's 2D say? 2D. 2D. Cool. So we can do the calculations. My job got upset that we made the half-hour predicted sales from the previous year when our store. You should be happy we did any sales. You know, it'd be really. Is like people are like running through the fire, still buying things, and they're like, "Your store's so awesome. We still want to buy stuff. I know it's on fire right now, but I need this product." And you're like, "We were still selling stuff. It was a literal fire sale," and it's a Arrested Development joke with fire sale. Good show. But yeah, no, that's a serious thing right there. That's variation. Like they should take that into account and be like, okay, considering this is what happened, and then they should understand. Like they should look at stores. It was as our AC, it got so in length 3 hours, but it's still crazy. Yeah, oh my gosh. Man, oh, I'm sorry to hear that. I hope everyone's all right. I don't mean to make light of it. And it sounds like everyone got out all right, and it looks like the store just received damage and the store was able to reopen. So I'm hoping everyone was all right in what happened right there. But obviously, companies need to take into account that sort of variation, because that would explain, think about that. The fire explains your sales. That's the explanatory variable right there. Not this, you wouldn't say the sales explain the fire. I mean, you could say lower sales explain a fire, but a fire would be the explanatory variable for lower sales. Like the fire explains why you had lower sales. So fire would be the X that explains why your sales were lower. So see, great examples. This is how we try to think in statistics. Like the fire explains why we have lower sales. So fire is X, lower sales is Y, or just sales in general, like value of the sales. Great, Alexa, 100 points. Like that, thanks for sharing that. And thanks for it's statistics. It's how data works. The fire was the explanatory variable, whether or not there's a fire. So what does 2D want us to do? What does 2D want us to do? I don't know. What do you want 2D? What do you want 2D? 2D says report the conditional distribution of females' locations. You know what I'm going to do? I'm going to do this a really cool way right here, and I'm going to try to do something I've never done before. There's a lot of ways to do this one, but it says report the conditional location for females, give the percentages, round to the nearest percent, compare the conditional distribution. Okay, so we have the male, report the marginal. Okay, so the marginal distribution of location. Do you know how to get the marginal distribution, Alexa? Some people have emailed me about this. Do you understand here how to get the marginal distribution of location? Do you understand what is the marginal distribution of location? How do we get it? Like, does that make sense? Because here is location, and here's the margin, and the... Okay, so the marginal distribution is the distribution in the margins. Can you tell me the marginal distribution for the percent of people who sat in the back? Can you tell me the marginal distribution for the percent of people who sat in the back? Can you do that math right here? What is the marginal distribution for the percent of people who sat in the back? What would that be? The marginal distribution for the percent of people who sat in the back. So you only focus in on location and back and total. So the marginal distribution for the percent of students who sat in the back. What would that be? And so you only use the numbers down here. What would the marginal distribution be? And that's the previous one where we do the marginal. So we need to look at this number. Yep, that's it. You got it, Alexa. That is totally it. It's just that after that, and then you just do each individual one. So you just do this divided by this divided by this divided, and it looks to be about 54%. So let me do the math you did up here. 107 divided by 579. So it should be 18.48%. 18.48%. Does that make sense? So you just divide them like this, and that's the marginal distribution. So this is marginal distribution of back. So that's the marginal distribution of the back. So that is the percent of students who sat in the back. And that's for like all students. So the marginal is just like all students. And this data set is found in survey 11, and I think it's seating location. So if we go to survey 11 and no, it's sitting location. It's survey 9, sitting location. You're not meant to know this, but it is here. Here it is right here. And if we were to go to a table of this, there we go, there's the back. We divide by the number of rows and survey, click the button. Divide by the number of rows, and there's that number there. So if you notice, this number here is obtained by 107, because there's the table right here that we have, and it's 18%. And we can do some nice stuff to this right here by going around it and putting a round around it. And we could round it to 4 decimal places. And there's all the, does that make sense, Alexa? Does it make sense what I'm getting right here? You can do this by hand, though. It's not with the assignment. You can go in and just divide 107 by 579. What is the marginal distribution for front? So what would be 20 points again? You get some bonus points, office hours here. What is the marginal distribution for front? Like this is, we look right here and we say the marginal distribution for front is what? It's just the percent out of the total students who sat in the front. And that would be what? I'll let you type it right there and then I'll enter it in. Yep, that might be it. That sounds about right. 216 divided by 579. And it's, yeah, I think it's right there also. And there it is right there, and you can see it right there in the front. And great job, Mila. Awesome work. And that's how you get it right there. That's the marginal distribution for front. So you could literally take and put your answers here, right here. Now, we only want for females. Now, this is where we can do a few things right here. Is we only want, we get points not taken off for doing the for loop. We get points taken off for not doing the for loop in 4. I think, are you supposed to, Jordan? Oh, is it the bonus one? Is it the bonus one with the in range? No, which one's 4 again? Is that the in range? Are you supposed to do, oh, I want you to do, no, you don't got to do a for loop. You can do the if else. Yeah. If else is fine. Please tell me if they take off for if else. It's fine. It's much quicker to do if else. For loops are, no one likes for loops. I'm kidding. I like for loops. But if else is better. It's just easier to work with the vector with than if else. So and I might go back and do the for loop on that. So we could do the for loop way of doing it. So I know, right? It's just like, if it works, it works. That's what matters with code. That's literally the theme of code. Does it work? It works. Good. What we can do right here is we can do a few things. We can actually get the distribution of, so let's get this. Let's go here and go to sitting location, and let's go gender. And what is gender in this survey? The survey is so weird because I hate the EXs and everything. Gender, there we go. There we go. So this is y tilde x comma data equals. I'll show you here in a second the format of it. This is y tilde x. Ooh, is there a dollar sign on that? What's she doing, dollar sign? Y tilde x comma data equals, and whatever the data is. So this format is very important. Y tilde x comma data equals. Let's zoom in on it a little bit here. Y tilde x comma data equals. You should know this format very, 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 very well. So all you do is put in your y variable you want to understand, your x variable you want to explain it, and your data equals the data frame you're using if you are using a data frame, which we often will use. So if you notice here, my y variable is location, my x variable is gender, and my data is the Survey 9 data frame, and it does all the work for me. Please notice that here we have not too large of differences. Males were a little more likely to sit in the middle. Females sat in the back a little bit, front a little bit more, but males are pretty much sitting in the middle a little bit more than females. So you don't see really any big differences here. And what do we have right here? What is this distribution right here that you notice? What is that distribution right here, as in right across here? This distribution right here is the what distribution of seating location. This is the what distribution of seating location. You got it, Mila. Excellent work. That's the marginal 20 office hour points right there. Remember, those can be added onto your regular points. This is the marginal distribution of seating location. This is the marginal distribution of gender right here. So you can see there's a little more females than males in the survey. And now when we look within females, it looks very similar over here. Nice job, everybody. Alexa, 20 points also. Let's go right here. And we actually get all the output we need because guess what? Given someone is female, here's the distribution. Guess what we also get here? We get the marginal distribution we calculated earlier. So you can actually check your marginal distribution here in this output if you do it this way, and you get the marginal distribution for female. But you might say, and you might have this on the test, you should know how to calculate the marginal distribution. How do we calculate the marginal distribution of females who sit in the back? What is the mathematics for the marginal distribution for female who sit in the back? What is the, conditional. What is the conditional distribution for females who sit in the back? So it's conditional female distribution sitting in the back for females who sit in the back. So what is the conditional distribution for females, and what is the probability of sitting in the back? And you can show me the mathematics. I think it's around 20%. It's a little bit less than that. It's like 19%. It's like 18 almost exactly. What is the mathematics for conditional distribution for females who sit in the back? Basically the conditional distribution for someone being female. And to do this, let me make it very clear. For the conditional distribution of female, you only look at the values right there. So that's the conditional distribution of females, but you need to turn it into a, like, percentages now. So how would we get conditional distribution of females? Yep, Alexa, great work. Does that make more sense, Alexa, that this is the conditional distribution of location for females? So we're looking at a conditional distribution for females, and we're looking at the location of females, 18%, yep. And so we hop back over here and look what R calculated. That's what R is calculating right here. This number right here is the number we get when we do 629 or 62 divided by, yeah, that's awesome. Great work. This is what I want, is I want you to look at these things and then come to office hours and ask questions. And then when you start to see it, you're like, oh, that makes sense now. I don't want people working I know people have jobs. I know people have kids. I know people have responsibilities. I know it's a crazy time. I know so much is going on. But the more you look at this and the more like you practice it, is there a way? Yep, warnings. Drop your code in the chat real quick, Grant, and I'll show you the trick. And drop your code, and then I'll fix it, and I'll send it back to you. Drop it in the chat, then remove it, and I'll send it back to you. I'll show you a quick trick. And see, Grant, perfect, Grant. Grant, you're getting 20 points right here for just being here to ask the question about how do I fix this code. and this assignment will get extended till tomorrow, and we will have office hours later today. So I'm going to show you a quick trick, Grant, right here, how to fix this. I have been emailed about this by a few people. We're going to go to suppress warnings, and we just take Grant's code right here. I think we have everything loaded up, and I'll show you what happens without this. So, okay, good. The 3 duplicates, size of party, what's it mad about? What are you mad about today? Oh, did it run? Error in levels. Oh, I think it's doing this as 2 lines. I think that might have been 2 lines there. Uh-oh. Is this the error you're getting? Because this is a different error than I would expect. So, yep. And so, associate, smoker, size of party, data equals ex2 tips, error in levels. What is it mad about? What are you mad about today? Why are you mad? ex2 tips. Level 3 is duplicate. Let me decrease the size of this window down a little bit. Where's my ex2 tips? No, I changed it once and now I have an error, but that wasn't the error I got. Yeah, I've never seen this. I haven't seen this error. So that's why I'm really confused. I'm like, what is this error? Let me try building this from scratch right here. Okay. So the ex2 tips data frame has smoker, and we want to predict it based on, what was it? We're doing it based on size of party, which was spelled correctly. Size of party, comma, data equals ex2 tips, right? Invalid graphic states. Okay, that's better. That's fine. I can take that error. Error in levels, temp. Maybe it's something I have stored in here. Let's run that. Oof, what is going on? Value as character. Is this like an update? This will be really weird. So is anyone getting... The error I didn't expect you guys to get is not this one. Association between using this many complete cases. Error in levels, temp. Factor level 3 is duplicated. Is this the error everyone's getting? Is this the error? Because all of a sudden, maybe an update to R, and I'll have to contact Dr. Petrie about this. Oh no. Oh, no. Jordan. 24. He cracked me up there, man. This was not the error I was expecting. Not the droids I was expecting. Okay, what is going on right here? Factor level 3 is duplicated. Okay, I think I know what's going on. Okay, I think I know what's going on. I got ideas now. Okay, I think actually relevant. Relevant was misspelled. No. Smoker, size of party. Okay, I think that's what it is. This is, I think, the issue. Why didn't I see that? There we go. There we go. Everything's good now. Was it question 6, exercise 6 on page 72? Let me look at this. I think that was the issue. So everything's fine. Everything's fine. Exercise 6 on page 72. What? Exercise 6 on page 72. Page 72, exercise 6. So the data frame right here, we are curious to see if there's an association between the size of party and whether or not people smoke. Party range sizes between 1 to 6. So in this case, it's appropriate to compare the average size of party using the average tip, run associated to perform the test. So we're trying to see whether smoking can explain the size of a party, not if size of the party can explain whether or not people smoke. So the restaurant is not trying to understand if their customers smoke. They're trying to understand like how many people come to the restaurant and if smoking explains that. Like, are smoking parties larger than non-smoking parties? Not do people smoke based on the size of their party? Yeah. Okay, good. Now are you getting different warnings? What warnings are you getting now? Because if you switch this to this and you add in the permutations, so let me grab your permutation stuff. You shouldn't be getting. Is everything good now? Which warnings are you getting? If you get warnings, you can go here and go to suppress warnings. Just make sure you want to suppress them. If you go to suppress warnings and put your code inside of this, you won't get warnings. So wrap it in as suppress warnings. Like, you just do suppress warnings, and then whatever code you want to have the warnings suppressed on. Yeah, do that. Do this right here. So take your code and just put it where X is at. So whatever code you have written, Grant, great job, Grant, 20 points, Grant. Whatever code you have written, just throw it in where X is at. Like just take your code and just put it where X is at. Like whatever, do you see how right here I have all this code? All of this code might as well just be X. It's just the code that will be what I'm going to suppress the warnings on. So I'm just going to suppress the warnings on all of that right there. And then if it does have warnings, it'll suppress all those warnings. There you go. That's how we do it. And don't worry, these are problems people hit. It's problems the assignments are meant to have. That's why I was really confused when the thing wasn't working at all. It's like, what's going on? I was like, oh, the X and Y are reversed. The X and Y are flip-flopped. And so if it's having trouble doing it because it was trying to do logistic and it couldn't do logistic on the way it was done. It was like, nope, can't do it. Can't do logistic. Can't do it. Won't do the logistic. And I was like, do I need to convert this? And I was like, I don't remember the assignment having this. Don't remember it. Do we look at the p-value by the ANOVA to make sure to answer the questions? I believe so. Yeah, so first thing we want to look at, and we got just to the end of this today. So I need to look at the key for this, double check. Because do you remember the very end of class today? We want to look at, and this is literally, see, I'm like, could I have it due tonight? And I'm like, no, let's be nice. If we had had 10, 15 more minutes today, I would have had it due tonight. I'm going to send out an email after I get done teaching today. But so the first thing we want to look at here is we want to look at, do we want to compare the means or the medians? And this one's a bit of a weird one, and I think the key says, like, it's all right either way. So if you notice here, the QQ plots. Do you remember us, Grant and Mila, do you remember us covering QQ plots today for normality? Do you remember the whole, like, QQ for normality plots thing to see if it's normal? And the red line down the middle means it's normal. So we do see some deviations here. So it's like, I mean, how far does it deviate? It's just because it's integer value. So here's something you'll hear later on. Because it's integer value, like you have people with 2, you have people with 3, with 4. So it's really hard for it to follow a perfect normal, and normal data can't just be integer. It has to be randomly distributed. I mean, I'd probably go medians. It looks like there's a right skew, but don't look at the histograms. I'll try to repeat that throughout class. Like, don't look at the histograms. Look at the QQ plot. The QQ plot shows a skew to the data. We could also do the following. We could go QQ plot on EX2 and party size. So here's the QQ plot for all the data. And it's got a bit of a right skew. Like, remember, this is what we saw earlier today when it was like pushed in. And it's got this, like this, right? This is bad. That's bad. That's really bad. It's like bad, super bad, horribly bad. So I'm going to go with medians. So now when you look at your output from the associate function, which we'll need to redo the screen right here to look at, let's remake the output so we can see it all on one line of code. When we look at the output from the associate function, we look right to, really? It shouldn't have. Did Dr. Petrie change the way this works? No, don't know. Did you do that? He might have. He was updating the packages a while ago. I don't think he did, unless it did. I don't care. It's going to get mad at me for invalid graphic state because it's like I can't reproduce the image. There we go. Let's take a look at the output. We might have to zoom out. Takes that long? Something weird is happening. We broke it. There it goes. There's the output. That's the way the table should look. This is the way I've seen the table 1,000 times. So if you look at this right here, what we notice is that if we're comparing medians, wow, we got no difference. No difference between the medians, and we definitely got no difference. So if you compared means, you would get a difference, and it would be conclusive. So this is a very good review here at the end. You can keep asking questions if you got them. But you notice here, if we were to compare means, but we didn't choose means because the QQ plots have such a skew to them. So I chose medians. You don't choose based on the p-values. You choose based on the QQ plots. So the first thing you want to do here is look at your QQ plots for normality, and then you want to make a choice based on that. And so I might try to make a video later today about analyzing these outputs and try to walk through examples about what does everything mean in this output. So I think that'd be very, very helpful to be like how to analyze this output, and try to put that out there in a video format, like analyzing the chi-squared test of independence, analyzing the differences between means and what this output means, going through step by step and knowing each segment of the code. So I might try to make some videos today on that. So hopefully that would help because it's kind of like shortened versions of the lecture, but you still have to, it's like, for people who are reviewing or understand the concepts, it'll probably help. But then it's like, how much can you explain like a 10-minute video, which I'll try to do a 10-minute video on, like explaining the chi-squared test or explaining how to analyze two means inside of R. So that's got it right here. We did not choose to analyze averages. We chose to analyze the medians, and there was no difference. The discrepancy is basically 0. I mean, I don't know why it doesn't just say 0, because that's basically 0. It's like calculating such a small number. And then we see here that we are also confident that there is no difference between them because the p-value is definitely larger than 0.05. Does that make sense, Malia and everyone who's looking at this output right here and how to understand it a little bit? That we can either compare the averages or the medians. The Kruskal-Wallis is mean ranks, which is you can use it instead of medians. It's going to compare the mean rank. It's going to rank all the numbers. So it deals with things like skew, but a lot of times people just compare the medians instead of the mean ranks. So it's a test that we could use that would be used in case of skewed and outlier data. But that's got it. Probably going to grab some lunch, relax for a little bit here, come back for some office hours. If you have questions, say them now. But I think you're welcome, Leah. Excellent. So we will head off. Thank you guys, everyone, for being here. And that's got it for now. So bye, everybody.